Certified AutoTech Master Introduction to ASE and Automotive Basics by Valentin Vishnyakov, published by Infinia Publishing. Introduction. Automotive Service Excellence (ASE) certification is a globally recognized standard that validates a technician's expertise and commitment to quality service. In an industry where technological advancements continuously reshape vehicle systems and diagnostic procedures, ASE certification stands as a testament to a technician's proficiency and dedication. Achieving ASE certification not only enhances your credibility in the eyes of employers and customers but also opens doors to numerous career opportunities and professional advancements. The automotive industry is at the forefront of technological innovation, integrating complex electronic systems, advanced diagnostics, and cutting-edge repair techniques into modern vehicles. As a technician, staying abreast of these advancements is crucial for maintaining relevance and ensuring the highest standards of service. This book delves into the fundamental aspects of automotive systems, providing a robust understanding of engine mechanics, electrical systems, transmission, suspension, brakes, and more. By mastering these basics, you lay a solid groundwork upon which you can build specialized skills and adapt to emerging technologies. Effective learning in the automotive field requires a blend of theoretical knowledge and practical application. Introduction to ASE and Automotive Basics emphasizes this dual approach, offering detailed explanations complemented by hands-on exercises, real-world examples, and diagnostic scenarios. This integration of theory and practice ensures that you not only comprehend the underlying principles of automotive systems but also develop the ability to apply this knowledge in real-world service and repair situations. Career advancement in the automotive service industry is closely tied to continuous education and professional development. ASE certification is a key milestone that signifies your commitment to excellence and your readiness to tackle complex automotive challenges. Beyond certification, the skills and knowledge gained through this book empower you to pursue specialized areas such as engine performance, electrical systems, heating and air conditioning, and more. These specialized competencies enhance your versatility as a technician, making you a valuable asset to any automotive service team. The structure of this book is designed to facilitate progressive learning, starting with fundamental concepts and advancing to more intricate topics. Each chapter is organized into sections that focus on specific automotive systems and repair techniques, ensuring a systematic and comprehensive coverage of essential subjects. Detailed diagrams, illustrations, and step-by-step procedures provide visual aids that enhance understanding and retention of complex information. Understanding the intricacies of automotive systems is only one facet of becoming an exceptional technician. Effective communication, problem-solving skills, and a customer-centric approach are equally important in delivering outstanding service. This book also explores these soft skills, highlighting their significance in building trust with customers, collaborating with colleagues, and fostering a positive work environment. By honing both technical and interpersonal skills, you position yourself for sustained success and professional fulfillment in the automotive service industry. The ASE certification process itself is rigorous, encompassing a series of examinations that assess your knowledge and practical skills across various automotive disciplines. This book serves as a comprehensive study companion, providing in-depth coverage of exam topics, practice questions, and test-taking strategies. By thoroughly preparing for each certification exam, you enhance your chances of success and ensure that you meet the high standards set by ASE. In addition to preparing you for certification, Introduction to ASE and Automotive Basics serves as a valuable reference resource throughout your career. The detailed explanations, diagnostic techniques, and repair procedures documented in this book can be consulted as needed, supporting you in addressing a wide range of automotive service challenges. Whether you are troubleshooting an electrical issue, performing engine maintenance, or conducting a comprehensive vehicle inspection, the knowledge gained from this book will guide you in delivering precise and effective solutions. The automotive service industry offers a multitude of career paths, each with its unique challenges and opportunities. From working in local repair shops and dealerships to pursuing roles in fleet maintenance and automotive consulting, the possibilities are vast. This book provides the foundational knowledge that is transferable across these diverse settings, ensuring that you are well prepared to navigate various career trajectories and seize opportunities for growth and advancement. Commitment to continuous learning is essential in an industry characterized by rapid technological advancements and evolving service standards. As vehicles become increasingly sophisticated, the demand for skilled and certified technicians continues to rise. By investing in your education through Introduction to ASE and Automotive Basics, you demonstrate a proactive approach to professional development, positioning yourself as a knowledgeable and adaptable technician capable of meeting the demands of modern automotive service. In conclusion, Introduction to ASE and Automotive Basics is your essential companion in the pursuit of ASE certification and a successful career in the automotive service industry. Through its comprehensive coverage of automotive systems, integration of theoretical knowledge with practical application, and emphasis on professional development, this book equips you with the tools and insights necessary to achieve excellence and advance your career. Embrace the learning journey ahead, and let this book guide you toward mastering the fundamentals of automotive service and achieving automotive service excellence. Lesson 1. Overview of ASE certification tests. An inviting look at the ASE certification landscape. The Automotive Service Excellence (ASE) certification program stands as a benchmark of professionalism, technical skill, and dedication in the automotive industry. Encompassing a variety of specialized exams, ASE certifications help demonstrate competency in areas such as engine repair, brakes, and electrical systems. Whether someone is new to automotive technology or a seasoned technician, the ASE certification path offers both a valuable credential and a measure of personal achievement. Those who pursue ASE credentials signal to employers and customers that they can be trusted to diagnose and repair vehicles correctly. This lesson provides a broad overview of the ASE tests, their structure, and the significance they carry for anyone interested in establishing a successful automotive career. Understanding the foundational purpose of ASE. The ASE organization was created in the early 1970s to address concerns about the quality of vehicle repair and service. Before ASE came into being, there was no widely recognized standard by which automotive professionals could prove their expertise. As vehicles became more complex, the need for an official means of assessing knowledge and capabilities grew more urgent. ASE filled that gap, establishing exams that evaluate a technician's theoretical understanding as well as practical skill. By passing these tests, professionals can set themselves apart, showing that they have studied diligently and mastered core principles in one or more specialized areas. This sense of legitimacy benefits service facilities, too, as customers look for shops with technicians holding ASE credentials to ensure reliability and confidence. In the decades since its founding, ASE has expanded its purview to include dozens of specific test categories that span automotive, medium/heavy truck, collision repair, school bus, and more. Each test focuses on a targeted skill set, with the intention of evaluating an individual's ability to both understand fundamental principles and apply them in real-world scenarios. The organization continually revises and updates its tests, so technicians must stay up to date. The approach fosters a standard of ongoing professional development, leading to service outcomes that better meet the demands of today's complex, computer-driven vehicles. ASE's role in the automotive landscape also extends to ongoing education, workshops, and awareness campaigns. Technicians who pursue certification often discover that the process challenges them to refine their critical thinking skills, ensuring they can navigate emerging technologies. This focus on staying current in a rapidly evolving field is part of what makes ASE credentials so prized. The tests themselves measure learning, problem-solving, and diagnostic expertise, which are hallmarks of what the automotive service industry requires. For newcomers to this field, the ASE certification program can initially appear quite comprehensive. However, once they understand how each exam is structured, how the recertification process works, and what sort of study resources exist, they realize it's a supportive framework rather than an intimidating barrier. The exams cover everything from entry-level basics to advanced diagnosis, placing emphasis on theory, application, and ethical work practices. Learning to navigate these exams sets the stage for a fulfilling career trajectory, one that can open doors to promotions, specialized roles, and leadership positions. Today, ASE remains a not-for-profit organization driven by the mission of improving the quality of automotive service. By earning ASE certification, automotive professionals contribute to an industry that values systematic training, transparency, and high standards. In turn, the public gains confidence, knowing the person working on their vehicle has been validated by a respected institution. The entire process underlines a shared commitment to raising the bar in automotive service excellence. Structure and organization of the ASE tests. ASE divides its certifications into various series, each corresponding to a core area of automotive service. The most commonly recognized certifications pertain to automotive technicians working on passenger cars and light trucks, but there are also separate categories for medium and heavy trucks, collision repair, part specialists, school bus technicians, transit bus technicians, and more. Each series contains multiple tests that delve into specific systems or operational tasks. For instance, under the automotive and light truck category, one might find exams focusing on engine repair, automatic transmission, brakes, and so forth. A typical ASE exam includes multiple-choice questions that test a candidate's theoretical understanding of the subject matter, their ability to interpret diagrams, and their familiarity with everyday automotive repair scenarios. Often, questions feature real-world examples that require combining knowledge of fundamental principles with diagnostic prowess. The format ensures that passers can demonstrate both the conceptual and applied facets of automotive service. Passing these tests is a demonstration that the technician has kept up with evolving vehicle technologies while maintaining a strong grasp on well-established repair and diagnostic procedures. In addition to the core certifications, ASE also offers advanced-level specialties that cater to more seasoned professionals. These advanced certifications require passing tests that measure deeper knowledge in areas such as engine performance or hybrid/electric vehicle technology. They're typically pursued by individuals aiming to specialize in cutting-edge vehicle systems or aiming to become recognized authorities in their field. Earning an advanced certification can signal that a technician is proficient in complex tasks beyond the scope of a general ASE certification. Each test series is governed by an advisory board composed of industry professionals, educators, and experts who continuously refine and validate test questions. This inclusive approach ensures that the exam content remains relevant to industry needs, reflecting the constant technological advancements in the automotive world. The questions are often framed to reflect real scenarios that technicians commonly face, thereby validating practical readiness. While the tests are administered in a standardized manner, ASE provides different testing windows throughout the year, allowing flexible scheduling. Candidates can choose a testing center and date that suits their commitments, ensuring that preparation can be done at a comfortable pace. This scheduling flexibility benefits working professionals who have to manage their day-to-day responsibilities while studying. The result is a series of exams that truly capture a current snapshot of a technician's knowledge and ability, all while offering convenient ways to engage in the certification process. Why ASE certification matters in the automotive industry. ASE certification brings credibility to technicians, repair facilities, and the industry as a whole. Employers tend to gravitate toward ASE certified technicians because those certifications function like a trusted seal of quality. Many shops even feature the ASE sign, proudly indicating that their workforce has been officially recognized for competence and skill. For a business, having certified technicians on staff can lead to better customer satisfaction rates, fewer comebacks, and stronger word-of-mouth referrals. It also often results in cost savings over time, as certified professionals tend to diagnose problems correctly on the first attempt, reducing wasted parts and repeat labor. From a technician's perspective, ASE certification can translate into better job security, as employers recognize the value of validated expertise. A certified technician is often in a stronger position to negotiate higher wages or pursue specialized roles in advanced diagnostics or supervisory positions. Additionally, customers are more likely to trust and appreciate a technician who has gone the extra mile to attain certification, understanding that it represents a commitment to excellence. This trust can turn into loyal customers who consistently return to the same shop when their vehicles need servicing. The certification also benefits the broader automotive community. By establishing a universal yardstick for competence, ASE encourages continued education. Technicians who want to maintain their certification must recertify every 5 years, ensuring they remain current on new tools, revised techniques, and emerging vehicle technologies. This ongoing cycle of evaluation and training elevates the overall standard of service, promoting a culture of lifelong learning that benefits everyone, technicians, employers, and consumers alike. Vehicles today are more complex than ever before, featuring advanced driver assistance systems, complex computer modules, and sophisticated powertrains. As a result, the stakes for automotive technicians have never been higher. A misstep in diagnosis can be costly and even dangerous, which is why an ASE credential is so meaningful. It offers a measure of protection to both the professional and the consumer by ensuring technicians meet a verified standard of proficiency. The industry's embrace of ASE certification is testament to its effectiveness. Technicians who pass the rigorous exams and maintain their certifications gain access to an array of career possibilities. Whether someone works at a dealership, an independent repair shop, or even runs their own business, ASE credentials can serve as a strong foundation to build upon. This empowerment helps shape an ecosystem where skill, innovation, and service quality continually progress. Exam categories and specializations. ASE certifications are sorted into specific categories that address nearly every facet of vehicle maintenance and repair. For passenger cars and light trucks, the categories often range from the A1 engine repair test to the A8 engine performance test, with each covering distinct components, system operations, diagnostics, and repair procedures. Similarly, the brakes test evaluates understanding of hydraulic systems, power assist components, and computer-controlled brake systems. To pass any given category, a technician must exhibit broad knowledge and the ability to apply that knowledge to real-world scenarios. In the realm of medium/heavy trucks, ASE provides certifications that address the more robust systems found in commercial vehicles. These tests might look deeper into diesel engines, air brake systems, and specialized transmissions designed to move large loads. For collision repair, separate tests exist to examine how well a technician can work with various materials, structural repair processes, paint and refinishing, and safety protocols. This wide variety ensures that technicians can pick the certification path that aligns with their career goals and current expertise, while also letting them build competence across multiple domains. Beyond these core automotive and truck categories, ASE has branched out into niches like school bus and transit bus certifications. These tests cover the unique features and regulatory requirements pertinent to passenger transport vehicles. An individual who repairs buses might focus heavily on evaluating safe seating restraints, entrance doors, or specialized emergency exits. By offering these targeted tests, ASE recognizes the different challenges that arise in various segments of the transportation world, ensuring each certification upholds the same high standard of thoroughness and expertise. There are also advanced level specialties, often denoted with an L, such as the L1 Advanced Engine Performance Specialist test. Passing an advanced exam indicates deeper competence in diagnosing and repairing complex issues. These specialized credentials often prove helpful for technicians who want to become shop leads, instructors, or respected experts in a particular area. They can also open up opportunities to consult or contribute to research and development projects with vehicle manufacturers. The advanced level certifications typically require strong analytical and diagnostic skills, going beyond a fundamental understanding of a system into the territory of advanced problem solving. Given this breadth, ASE offers a testing environment in which each individual can align their certification roadmap with personal and professional aspirations. While some technicians might choose to master every aspect of passenger cars, others may concentrate on medium/heavy trucks or collision repair. In essence, ASE provides a structured path for honing one's craft, with each certification representing a new milestone in professional growth. Our how to register and prepare for ASE tests. Registering for ASE tests typically involves signing up through the ASE website and selecting the tests you aim to take during one of the available testing windows. Since the tests occur at authorized proctoring centers, you can choose a convenient location, date, and time slot. Payment of the registration fee secures your seat, and each test has its own fee structure. Once you finalize your choices, you receive scheduling instructions. Many technicians appreciate the ability to select time slots that fit around busy work schedules, which often include weekends or early evening times. Preparation is the most crucial aspect of achieving success on an ASE exam. Most candidates study through a combination of hands-on experience, test prep books, and online resources provided by ASE or other reputable publishers. Some choose to form study groups, comparing notes and discussing difficult concepts to solidify their knowledge. Practical experience is often the best teacher, so working on real vehicles, investigating faults, and actively diagnosing problems each day builds a strong foundation for taking the test. Formal training programs, whether offered by community colleges or specialized automotive schools, frequently incorporate ASE test preparation into the curriculum. In these environments, students receive structured guidance from instructors, as well as the benefit of interactive lab sessions and live demonstrations. Such programs often track industry updates to ensure that students are studying the most relevant and timely information. Additionally, many shops encourage their employees to undertake certification, sometimes reimbursing fees for tests that are passed successfully. Time management strategies during test taking are equally vital. Since each test imposes time limits, practicing with timed quizzes can help build efficiency and reduce the stress of test day constraints. Understanding how multiple-choice questions are structured, reading each question carefully, eliminating obviously incorrect answers, and considering the most logical choice based on professional experience, can greatly increase the chances of success. Ultimately, a well-rounded preparation plan involves both theoretical study and practical, real-world application. This dual approach ensures that when presented with a question, a candidate can call upon not just memorized facts but also the experience of having solved similar issues in real life. Combining book knowledge with the daily demands of diagnosing and repairing cars is the best formula for passing an ASE exam and retaining that information for future tasks. Maintaining and renewing ASE certifications. Earning an ASE credential is a significant milestone, but ASE requires recertification every 5 years to ensure technicians stay current. This timeframe reflects the ever-evolving nature of automotive technology, from the integration of advanced safety features to the growing presence of hybrid and electric powertrains. Technicians must demonstrate that they have kept abreast of changes in diagnostic methods, service procedures, and emerging industry standards. Passing a shorter recertification test or the full exam again accomplishes this, revalidating the certification. Continuing education is an ongoing reality for automotive professionals, whether through formal courses or self-guided learning. Workshops organized by manufacturers and technical seminars hosted by industry groups often become regular commitments for serious technicians. By attending these events, professionals not only stay updated but also may discover new approaches for common repair tasks, new tools, and insights into upcoming vehicle technologies. Some shops even have weekly or monthly training sessions to share knowledge across the entire team, fostering a supportive and progressive work environment. Recertification also acts as a motivational tool, reminding technicians that they are part of a field that never stands still. Each new model year can introduce changes in how certain systems function or how components integrate. Without the impetus of retesting, it would be easy for some to rest on their laurels and risk becoming outdated. With recertification as a requirement, technicians remain engaged, exploring service bulletins, training modules, and manufacturer updates. The technology changes faster now than at any point in automotive history, and standards must keep pace. ASE's recertification schedule acknowledges that once a technician masters a skill, it's still subject to re-examination in light of new developments. In turn, the public can trust that when a technician displays their ASE certificate on the wall, it represents a knowledge base that's up to date, relevant, and proven. For those holding multiple certifications across different categories, managing their recertification schedule can be a matter of strategic planning. Some technicians choose to stagger their exams so they are not required to pass all recertification tests at once. Regardless of how they choose to schedule their renewals, the key point remains: ASE's recertification requirement underlines a commitment to ongoing excellence, providing assurance that the credential holds weight throughout a technician's career. Impact on career growth and opportunities. ASE certification serves as a foundation for long-term career growth. A technician just starting out might begin with a single certification, such as A1 engine repair, and then add more as they gain confidence and experience. As they accumulate multiple ASE certifications, their value in the eyes of employers tends to increase, often leading to enhanced job prospects or promotions within their current workplace. Some organizations set internal policies that favor or even require ASE-certified technicians when considering candidates for advancement or specialized roles. In certain settings, ASE certifications can lead to positions beyond the repair bay. For instance, manufacturers often seek certified experts to serve as technical trainers, field representatives, or product developers. In these roles, a deep understanding of automotive systems gleaned from hands-on experience can be invaluable. Likewise, companies that develop diagnostic tools or automotive software often look for ASE-certified professionals to contribute insights that bridge the gap between engineering and real-world application. A robust set of ASE credentials can also be a major asset for those who dream of owning a repair shop or automotive business. Customers frequently look for shops displaying ASE signage, associating it with knowledgeable staff and trustworthy service. Having the certifications might not just attract clients, it can also help secure partnerships with parts suppliers, insurance companies, and other entities looking to collaborate with reputable service providers. Meanwhile, for independent technicians, certifications serve to demonstrate their commitment to best practices and ongoing education, helping them stand out in a crowded marketplace. For professionals with an eye on more specialized areas, the advanced-level ASE tests offer paths to exclusive roles. For instance, an individual with the L1 Advanced Engine Performance Specialist certification might be sought after for diagnosing elusive drivability issues or working on high-performance engine tuning. This distinction can lead to challenging and rewarding tasks that keep a professional engaged and continuously learning. All of these benefits underscore why ASE certifications are often viewed as more than just an academic exercise. Passing each test involves substantial study, practical experience, and a rigorous evaluation of a technician's skill set. In many respects, they are milestones on a career path that can culminate in leadership roles, specialized consulting, or entrepreneurial success. ASE certification is not just an endpoint, it's part of a continuous journey that propels automotive professionals toward new and exciting opportunities. Challenges and common misconceptions. Despite the well-established reputation of ASE certifications, some technicians hesitate to pursue them due to misconceptions. A frequent concern is that the tests are too difficult or that they require memorizing obscure information. While the exams are thorough, they generally focus on topics that competent technicians face in day-to-day work, reinforcing practical knowledge. Anyone with a solid background, whether gained through formal education or extensive on-the-job learning, has a strong foundation to approach the test. Additionally, comprehensive study guides and resources can clarify any weaknesses in a candidate's knowledge before the exam date. Another misconception is that ASE certifications are primarily beneficial only for large shops or dealerships. In truth, small businesses and independent shops value ASE as well, often advertising that they employ ASE-certified technicians to build credibility with customers. In fact, for smaller enterprises that depend heavily on a loyal clientele, having certified staff can make a noticeable difference in repeat business and local reputation. Some technicians assume that once they pass an ASE test, they've reached the pinnacle of their skill. However, ASE, and the industry at large, views certification as part of a continuum. Although passing the exam is a big step, it's just one stage in an ongoing pursuit of mastery. Maintaining and renewing that certification ensures that a technician continues learning, benefiting not only the individual but also their coworkers, customers, and the industry as a whole. Occasionally, there's an idea that certifications do not translate into higher pay. While direct monetary gains can vary based on location, employer policies, and market demand, many employers do recognize the added value of a certified technician, offering better compensation or positions that leverage specialized expertise. Even if immediate financial rewards aren't evident, the long-term career trajectory typically benefits from having ASE credentials, as they open up pathways that might otherwise remain inaccessible. Finally, people sometimes worry that the certification process is time-consuming or bureaucratic. While it does require planning, from the registration step to studying and scheduling the exam, the overall process is streamlined. Modern testing centers offer flexible scheduling options, and ASE provides plenty of guidance to minimize confusion or frustration. When weighed against the potential career advantages, the time invested in preparing for and passing the exams becomes a strategic move to strengthen professional standing. Historical evolution of ASE and its ongoing adaptations. ASE's inception in 1972 responded to widespread concern about inconsistent vehicle repair quality. Over the years, the organization has evolved from offering a handful of tests to a broad array of exams that reflect shifting automotive landscapes. In the 1980s and 1990s, ASE adapted to the rise of electronic engine controls and fuel injection systems. As these components became standard in modern vehicles, corresponding questions and categories were integrated into the certification program. As automotive engineering made strides with hybrid technology and battery electric drivetrains, ASE introduced new exams and updated old ones to incorporate these cutting-edge areas. The advanced level exams, in particular, now include content on systems like regenerative braking and high-voltage powertrains. This commitment to staying contemporary is possible thanks to close collaboration with automakers, educators, and shop owners who serve on ASE's advisory boards. Another area that has seen change over the years is test administration. Initially, ASE exams took place just once or twice a year at physical locations. Now, computer-based testing at authorized centers provides far more scheduling flexibility. This modern approach reduces wait times between registration and actually sitting for an exam, making the certification process more accessible for technicians juggling work and family commitments. ASE also stays active in educational outreach, supporting high school and post-secondary automotive programs that align with industry best practices. Partnerships with these institutions create a pipeline of future professionals who are not just trained mechanically but also prepared for the level of knowledge ASE tests demand. These initiatives help raise the baseline of competency across the entire automotive workforce. The organization's adaptability also extends to public awareness efforts. By promoting the importance of choosing ASE-certified technicians for vehicle repairs, ASE empowers customers to seek service centers that prioritize professionalism and expertise. This alignment of expectations between professionals and clients fosters mutual respect for technical skill. Overall, the evolution of ASE mirrors the evolution of the automotive industry itself, reflecting changes in technology, consumer demands, and global trends toward efficiency and safety. Ethics, professional conduct, and the spirit of excellence. Although ASE is primarily known for its certification tests, it also supports ethical conduct and professionalism in every part of the automotive service process. The organization underscores that true excellence goes beyond mechanical aptitude, encouraging technicians to uphold integrity when interacting with customers and colleagues. This stance is reflected in the way exams frequently include questions on safety procedures, customer communication, and ethical decision-making. Integrity is a vital attribute for a technician who will diagnose and repair potentially life-saving systems, like brakes or airbags. Service excellence demands telling a customer if a repair is unnecessary, discussing cost-effective alternatives, and standing behind one's work with a sense of responsibility. ASE fosters these values by stressing that a truly certified professional doesn't just understand how to fix a vehicle, they also grasp how to communicate with the people who own those vehicles. Beyond the realm of individual conduct, the spirit of excellence promoted by ASE encourages shops to maintain organized, safe workspaces, stay informed about recalls, and address any customer concerns promptly. Such practices reflect a collective goal, to standardize and elevate the quality of automotive care. Shops and technicians who embrace this ethos often enjoy strong reputations in their communities, earn repeat business, and attract motivated, skilled team members. Being an ASE certified technician brings a certain level of accountability. The certificate on the wall symbolizes to colleagues and customers that the individual has made a formal commitment to the industry's best practices. In turn, the broader community of automotive professionals benefits when members hold each other to high standards. This mutual respect and cooperative learning environment helps drive improvements in methods, fosters continuous innovation, and ultimately safeguards public trust. The ethical dimension cannot be overlooked, especially in an industry where consumers frequently lack the technical expertise to judge whether their vehicle has been repaired correctly. ASE certification reassures them that their technician is not only knowledgeable but also conscientious. As technology continues to evolve, so too will the ethical challenges, whether in diagnosing sophisticated software issues or handling sensitive data from connected vehicles. By promoting professional integrity, ASE ensures that the industry remains prepared to navigate these changes responsibly. Concluding insights and next steps. This overview of ASE certification tests highlights their significance for professionals seeking to establish or enhance their credentials in the automotive repair industry. From foundational categories like engine repair and brakes to specialized areas such as collision repair and advanced engine performance, ASE presents a well-structured path for lifelong learning. The exams themselves require a mix of theoretical knowledge and hands-on experience, validated through rigorous, regularly updated content that aligns with modern vehicle systems and technologies. Recertification mechanisms ensure technicians remain current in a field that's defined by rapid innovation. By continually refreshing their knowledge, certified individuals keep pace with evolving diagnostic tools, increasingly complex software systems, and emerging powertrain designs. This ongoing educational journey doesn't just benefit the certified professional, it maintains trust and confidence for shops, employers, and customers. The pursuit of ASE certification also ties in closely with ethical conduct and high professional standards. For anyone stepping into the automotive sphere or looking to advance within it, ASE certification stands as a valuable stepping stone. The tests challenge each candidate to bring forth their best, examining not only what they know but also how they apply that knowledge to real-world situations. The result is a credential that resonates deeply across the industry, signaling that the holder is both skilled and dedicated. Given all these factors, the next steps for any aspiring or current automotive professional are clear. Explore the available certification categories, identify those that align with your career goals, and plan your study approach. Whether you choose a structured educational program or rely on self-study augmented by hands-on practice, aim for holistic learning. Prepare thoroughly, schedule the tests when you feel confident, and embrace the ASE journey as a continual path to excellence. The automotive field needs professionals committed to high standards. ASE certification is one of the best ways to prove you're up to the task. Lesson 2, Basic Automotive Terminology. A brief orientation to essential vehicle vocabulary. Recognizing why terminology matters. Clear, consistent communication underpins every successful automotive project, whether you're discussing a simple oil change with a customer or troubleshooting a complex mechanical issue with coworkers. Understanding the language mechanics use every day helps you bridge gaps in comprehension, which can streamline diagnostic procedures and reduce errors. When you grasp the nuances of terms like chassis, powertrain, and torque, you're able to interpret service manuals more accurately and discuss your findings with precision. Moreover, awareness of these fundamental words builds professional confidence, letting you articulate problems and solutions in a way that resonates with both peers and clients. The relationship between words and function. Automotive terminology isn't simply a collection of random phrases, each term reflects a piece of the overall mechanical puzzle. For instance, if you understand the definition of a drive shaft, you'll also have a sense of how rotational force is transmitted from the engine to the wheels. As a result, knowing the correct vocabulary can actually deepen your functional understanding. Rather than viewing learning terminology as an isolated task, see it as a way to visualize the pathways through which mechanical energy flows. Ultimately, each word you master becomes a tool for capturing and conveying the inner workings of the automobile. Avoiding miscommunication in the shop. Within the fast-paced environment of an auto shop, clarity is critical. Misusing or misunderstanding automotive terms can lead to confusion and even safety hazards, especially in high-stakes scenarios like brake services or advanced electrical diagnostics. If a coworker says, "Check the tie rod," and you confuse that with the control arm, you might examine the wrong component, potentially missing an actual fault. Precise word usage is central to teamwork, ensuring that everyone is on the same page and that vehicles leave the bay in good condition. Keeping these terms clear and consistent fosters better collaboration and reduces time lost to re-explanations. Communicating with customers and stakeholders. Automotive professionals also interact with non-technicians on a regular basis. Customers, managers, and suppliers rely on your understanding of terminology to receive accurate, trustworthy information. For example, if a client complains about a humming noise, you might explain that a worn wheel bearing could be the cause, and you'll reference relevant terms like hub assembly or knuckle. Translating technical words into everyday language shows empathy, but your foundation in the correct terms ensures you don't oversimplify in a way that causes confusion. Mastery of vocabulary allows you to navigate smoothly between technical detail and accessible explanation. Building a lifelong learning mindset. The automotive world never stands still, its vocabulary grows and evolves with technological progress. New systems, advanced materials, and integrated software solutions bring fresh terms into everyday usage. Cultivating a strong foundation in basic terminology isn't a one-time milestone, it's the beginning of an ongoing journey. Each time you learn a new concept or piece of equipment, you add to your dictionary of knowledge, gaining a richer sense of how various vehicle subsystems interact. This continuous refinement of language mirrors the continuous evolution of the automobile itself. Foundational components of an automobile: body and chassis. In common automotive parlance, the body is the exterior shell that shapes the vehicle's appearance and defines passenger and cargo compartments, while the chassis supports the vehicle's critical mechanical components. The chassis includes the frame, which provides structural integrity and balance. On some cars, the body and chassis are two distinct parts. In unibody construction, they are integrated. Understanding these distinctions matters when diagnosing structural damage or deciding on repair approaches after collisions. If the chassis is compromised, the entire vehicle's performance and safety can suffer, making chassis one of the most important terms in automotive vocabulary. Powertrain and drivetrain. Powertrain typically refers to the set of components that generate power and transmit it to the road, including the engine, transmission, and differentials. The term drivetrain sometimes appears interchangeably, but it usually highlights the parts that deliver power to the wheels once it's already been produced by the engine. So, while both terms address power transfer, powertrain often emphasizes the engine's role, and drivetrain focuses on the mechanical path to the tires. This distinction is vital when talking about issues like torque conversion, acceleration, or any performance modifications. Suspension and steering system. Suspension components, like shocks, struts, and control arms, serve to absorb bumps and maintain tire contact with the road. The steering system, which can be hydraulic or electric, allows the driver to direct the vehicle's movement. Collectively, these systems enable smooth handling, minimize wear on other components, and protect passengers from jarring impacts. Recognizing terms like ball joint or rack and pinion helps with diagnosing issues related to alignment and ride quality. By understanding how suspension and steering work together, you'll also grasp how modifications, like sport tuning, can affect overall driving dynamics. Braking assemblies. Brakes are critical for vehicle safety, making proper use of braking terminology a priority for every technician. Common words include rotor, caliper, brake pad, and master cylinder, all describing specific parts of the braking mechanism. Mastering these terms paves the way for diagnosing squeaks, vibrations, or diminished stopping power. Whether you're dealing with a standard disc brake setup, drum brakes on older models, or advanced anti-lock braking systems, a firm grasp of each component's name and function is essential. Electrical and electronic foundations. Today's vehicles rely heavily on electronics, from ignition systems to advanced infotainment. Battery, alternator, ECU, engine control unit, CAN bus, controller area network, and sensor are just a few standard terms in this domain. A basic understanding of these core elements makes it easier to diagnose common electrical issues, like a dead battery or faulty sensor, while also setting the stage for tackling advanced diagnostics on modern cars. Each of these words signals a specific role in the intricate web of wires, circuits, and computerized modules that define contemporary automotive engineering. Engine terminology for beginners. Cylinder block and cylinder head. The cylinder block is the robust metal structure that houses the combustion chambers where pistons move up and down. Attached to the top is the cylinder head, which contains valves, spark plugs, in gasoline engines, and passages for coolant and intake air. When someone refers to a head gasket, they're talking about the seal between these two major components. Familiarity with these terms offers a baseline for grasping how fuel combusts and how energy is generated in an internal combustion engine. Camshaft, crankshaft, and valve train. Essential to the movement of internal engine parts, the crankshaft transforms the linear motion of pistons into rotational power. The camshaft, meanwhile, times the opening and closing of the engine's valves. Combined with the valve train, including lifters and pushrods, in certain designs, these parts choreograph the intake of air-fuel mixture and the expulsion of exhaust gases. Recognizing these terms and their interplay enables you to visualize how engine timing and valve operation directly impact performance. Lubrication systems. Lubrication keeps the engine's internal components from wearing each other down. Key terms here include oil pump, which circulates engine oil through passages, and oil pan, the reservoir that collects oil at the bottom of the engine. Understanding viscosity helps you choose the correct oil type for different climates or driving conditions, ensuring that engine parts don't suffer from excessive friction. This vocabulary also ties into maintenance schedules, as oil changes are among the most frequent services performed to preserve engine health. Cooling systems. Engines produce a large amount of heat during combustion, making the cooling system vital. Words like radiator, thermostat, and water pump often come up when diagnosing overheating or planning preventative maintenance. Additionally, coolant flows through channels in the cylinder block and head, picking up heat and releasing it via the radiator. Knowing these terms gives you a clear picture of how temperature is managed, preventing damage like warped cylinders or blown head gaskets. Intake and exhaust components. For an engine to run efficiently, it needs a balanced flow of air in and waste gases out. Terms like intake manifold, exhaust manifold, O2 sensor, and catalytic converter define the pathways for air and exhaust. A clogged air filter or a faulty oxygen sensor can trigger warning lights and degrade performance. Recognizing these parts and understanding how they function in tandem can help pinpoint issues related to emissions, fuel economy, and engine responsiveness. Transmission and driveline fundamentals. Manual transmission terms. Manual transmissions require the driver to physically shift gears, so terms like clutch, flywheel, and shift fork take center stage. The clutch disc and pressure plate disengage the engine from the transmission when the driver presses the clutch pedal. Once the gear is selected, the components engage again, transferring torque. Clarity on these terms is crucial for diagnosing slipping clutches or troublesome shifts, ensuring timely and accurate repairs. Automatic transmission essentials. In an automatic transmission, gear changes occur without driver intervention. Torque converter, planetary gear set, and valve body are among the core components. The torque converter plays the role of the clutch in a manual setup, allowing the car to idle without stalling and transferring power through hydraulic fluid. By knowing these terms, you can decipher symptoms like delayed shifting or gear slip. The complexity of modern automatics demands a solid grasp of the vocabulary to navigate specialized diagnostic procedures successfully. Differentials and axles. When a vehicle turns, the outside wheel travels a different distance than the inside wheel. The differential accommodates that difference in wheel speed. Terms such as open differential, limited slip differential, and locking differential all highlight variations in how torque is distributed. Meanwhile, axle shafts carry power from the differential to the wheels. Mastering this vocabulary reveals the nuances of how a car or truck handles under various conditions, from tight turns to slippery surfaces. Four-wheel drive and all-wheel drive concepts. Four-wheel drive, 4WD, and all-wheel drive, AWD, systems distribute power to multiple wheels for improved traction. Words like transfer case, drive shaft, and coupling unit are indispensable for discussing how power is routed in these setups. While 4WD is often found in trucks or off-road vehicles, AWD is common in many passenger cars and SUVs. Understanding the correct terms for these systems ensures that you can diagnose traction issues, gear clunks, or fluid leaks promptly and accurately. Maintenance concerns for transmissions. Whether manual or automatic, transmissions require periodic upkeep to avoid costly breakdowns. Phrases like transmission fluid flush and filter replacement often appear on service schedules. Transmission fluid differs from engine oil in composition and properties, and using the wrong type can lead to performance issues. Knowing essential terminology helps you advise customers and stay consistent with recommended intervals, while also troubleshooting common symptoms such as slipping gears or harsh shifts. Fuel, ignition, and emissions terminology. Fuel delivery systems. Modern vehicles primarily use electronic fuel injection systems, which rely on fuel injectors, fuel pump, and a fuel rail to deliver gasoline or diesel to the engine. In older vehicles, you might encounter a carburetor that mixes air and fuel manually. Familiarity with these terms illuminates how engines maintain the correct air-fuel ratio. Issues like clogged injectors or leaky fuel lines often show up as rough idling, reduced power, or decreased fuel efficiency, tying the terminology directly to real-world diagnostics. Spark ignition components. Gasoline engines typically depend on spark ignition, involving spark plugs, ignition coils, and possibly a distributor in older setups. Each spark plug ignites the air-fuel mixture within a cylinder, controlled by the engine's timing. Recognizing how these parts fit together can make it easier to diagnose misfires, which present as shaky acceleration or blinking engine lights. An in-depth understanding of ignition timing further refines your ability to address performance problems. Diesel engine ignition basics. Diesel engines don't use spark plugs. Instead, they rely on compression ignition, where air is compressed in the cylinder, raising its temperature. When diesel fuel is injected into this high-pressure environment, it combusts spontaneously. Terms like glow plugs appear instead of spark plugs, assisting cold starts in frigid temperatures. Since diesel systems differ significantly from gasoline systems, it's essential to keep the correct terminology in mind when diagnosing rough running or starting difficulties. Emission control components. Modern emission standards drive the design of parts like the catalytic converter (EGR) valve, exhaust gas recirculation, and evap system, evaporative emission control. Each component serves to reduce pollutants, like hydrocarbons, carbon monoxide, and nitrogen oxides. For technicians, these terms aren't merely abstract. Faulty emission parts often trigger check engine lights, requiring thorough diagnostic strategies. Knowledge of these devices is critical for compliance with environmental regulations and for ensuring optimal engine efficiency. Onboard diagnostics, OBD, terminology. Today's vehicles contain onboard diagnostic systems that monitor performance and trigger error codes for malfunctions. The widely used OBD2 system provides standardized codes, like P0300 for random misfires or P0420 for catalytic converter inefficiency. Understanding the abbreviations and reading codes with a scan tool is part of everyday life for modern automotive technicians. Learning acronyms such as DTC, Diagnostic Trouble Code, and MIL, Malfunction Indicator Lamp, helps you interpret the data coming from the vehicle's computer. Steering, suspension, and wheels. Common steering mechanisms. In most cars, you'll encounter either a rack and pinion or a recirculating ball steering system. In rack and pinion setups, a circular gear, the pinion, meshes with a linear gear, the rack, to turn the wheels. In recirculating ball systems, ball bearings move inside a worm gear for smoother steering input. Understanding these terms clarifies the differences in steering feel and what might cause steering play or vibration. Suspension terminology. Basic suspension design spans a wide range, from simple, solid axles, to more complex, independent suspensions. Words like coil spring, leaf spring, and control arm define how the vehicle handles bumps. Shocks, or shock absorbers, mitigate bounce, while struts combine shock absorption with structural support. These components differ significantly in design and function, so correct naming ensures accurate repairs. A knowledge base in these terms will also help when diagnosing strange rattles or alignment issues. Wheel and tire vocabulary. Wheels and tires deserve their own category, given the numerous terms involved, rim, bead, tread, and sidewall, among them. In addition, wheel offset and bolt pattern are important for ensuring that aftermarket wheels fit properly. Understanding these words helps you advise on tire rotation, tread wear, and wheel balancing. When used precisely, this terminology supports effective communication about upgrades or replacements, improving ride quality and safety. Alignment and geometry. Alignment concepts, including camber, caster, and toe, describe the angles at which wheels meet the road. If you understand these words, you can predict how a vehicle handles corners, how it responds to bumps, and how quickly tires wear out. For example, excessive negative camber might improve cornering grip but lead to faster inner tire wear. Recognizing the effects of each angle helps you diagnose premature tire damage or pulling sensations while driving. Upgrades and modifications. Suspension and wheel upgrades are common among automotive enthusiasts. Terms like coilovers reference adjustable suspension kits that let drivers alter ride height and damping stiffness. Lowering springs drop the vehicle's center of gravity for improved handling, while performance sway bars reduce body roll. Understanding these words extends beyond the theoretical. It also informs how each modification might affect everyday drivability or load capacity. Solid familiarity ensures you can offer knowledgeable advice on modifications that align with a driver's goals. Bodywork, interior, and safety equipment. Body panels and trims. The external shell of a vehicle includes terms like fender, quarter panel, hood, and trunk lid, each describing distinct areas. Trim elements, like moldings or bumper covers, are more cosmetic but still play roles in aerodynamics and protection. Familiarity with these terms guides you in assessing damage from collisions or routine wear. It also comes in handy when ordering parts, as mismatching body components can lead to improper fitment or compromised aesthetics. Paint and finishes. Paint terms extend from primer to clear coat. The base coat provides color, while the clear coat adds depth and protection. Specialized finishes like metallic or pearlescent alter a vehicle's appearance under different lighting conditions. Understanding these distinctions is crucial for collision repair and refinishing, where precise color matching is often needed. Similarly, knowledge of paint code helps you locate the exact formula for an OEM finish. Interior design and comfort. Inside the cabin, you'll hear phrases like dash panel, center console, headliner, and upholstery. Modern vehicles often integrate infotainment systems, climate controls, and advanced instrument clusters. Knowing these interior terms helps you tackle issues like malfunctioning displays or squeaking trim panels. It also aids communication with customers who might only complain that something rattles near the passenger side. By narrowing down the correct interior component, you'll diagnose more efficiently. Airbags and supplemental restraint safety technology continues to evolve. Beyond the steering wheel airbag, cars often come with side curtain or knee airbags, each specifically designed to protect certain body regions. The acronym SRS, Supplemental Restraint System, encompasses all these devices, along with seatbelt pretensioners. When diagnosing an airbag light on the dashboard, correct knowledge of these terms helps you identify potential sensor faults or wiring issues. With safety systems, precision in terminology translates directly to safer outcomes for occupants. Structural integrity and crash zones. Modern vehicles incorporate crumple zones and reinforced pillars to manage crash forces. These design elements absorb energy in a collision, protecting the passenger compartment. Terms like A-pillar, B-pillar, and C-pillar refer to vertical supports along the body. Understanding these structural features helps you interpret collision repair guidelines, as cutting or welding in certain zones can compromise safety. This vocabulary underscores how advanced automotive engineering aligns with occupant protection. Heating, ventilation, and air conditioning, HVAC, essentials. Basic HVAC overview. Vehicle HVAC systems provide thermal comfort and defogging capabilities. Core components include the heater core, which uses engine coolant to warm cabin air, and the evaporator, which absorbs heat for air conditioning. Recognizing how these parts interact clarifies why you might experience a foggy windshield or insufficient cooling. This vocabulary is foundational when diagnosing climate control complaints like a musty smell or inconsistent temperature. Refrigerant and AC components. Air conditioning relies on a refrigerant circulated by a compressor, passing through a condenser and evaporator. Each component changes the refrigerant state from gas to liquid and back again, effectively removing heat from the cabin. Terms like expansion valve or orifice tube come into play, as they regulate refrigerant flow. Knowing these specific parts ensures you can pinpoint leaks or pressure irregularities, common culprits in weak AC performance. Blower fans and ducts. Inside the dash, the blower motor forces air through ducts toward vents in the dashboard, floor, or defroster. If you understand blend doors, the panels that direct warm or cool air, you can solve problems like uneven heating across the cabin. These words may seem mundane, but they become critical when a customer reports one side of the car blows cold while the other side remains warm. Such complaints often trace back to blend door failures or a worn-out blower motor. Cabin air filters. Cabin air filters remove dust, pollen, and other contaminants before the air reaches occupants. While these small, easily overlooked parts don't carry the mechanical heft of engine or suspension components, they significantly impact air quality and HVAC performance. Knowing the filter's location, often behind the glove box or under the hood, helps you advise vehicle owners about periodic replacements. Failing to replace a clogged cabin air filter can reduce airflow, causing musty odors and decreased effectiveness of both heat and AC. Diagnostics and common issues. HVAC systems are prone to a unique set of failures, from refrigerant leaks to electronic control module glitches. Terms like pressure switch, blend door actuator, and condenser fan appear frequently during diagnostic procedures. In many cases, a systematic approach is essential, verifying refrigerant pressure, checking electrical signals, and inspecting mechanical linkages. Familiarity with HVAC terminology and flow paths allows you to track down faults efficiently, reducing repair times and improving customer satisfaction. Electrical systems, wiring, and diagnostic tools. Fuses, relays, and circuit protection. Automotive circuits require protection from surges or shorts, making fuses and relays indispensable elements. Fuses melt when current exceeds safe levels, while relays allow a low-current circuit to switch a higher current circuit. Understanding the role of each protective device clarifies how headlights, wiper motors, and other electrical accessories remain safe. Technicians regularly consult fuse boxes, sometimes labeled with icons, so precise knowledge of these terms saves time and prevents confusion. Wiring harnesses and connectors. A modern vehicle contains miles of wiring, bundled into organized harnesses that run throughout the chassis. Connectors ensure devices like sensors, modules, and switches communicate effectively. Damaged or corroded connectors often result in intermittent faults, meaning an issue might appear one day and vanish the next. Recognizing these common failure points and using terms like pigtail, terminal, and ground strap helps you pinpoint trouble spots, especially when dealing with complex network wiring. Battery, alternator, and charging systems. While the battery stores electrical energy, the alternator recharges it and powers the vehicle's electrical systems once the engine is running. A voltage regulator ensures that voltage remains within acceptable limits. Understanding how these terms relate clarifies why a failing alternator can lead to dim headlights or a dead battery. Additionally, recognizing cold cranking amps (CCA) helps in advising appropriate battery replacements for different climates or vehicle demands. Sensors, modules, and control units. Vehicles now incorporate an array of sensors, like MAF, mass airflow, MAP, manifold absolute pressure, and TPS, throttle position sensor, to monitor engine performance. Various control modules process this data, adjusting fuel injection, ignition timing, or transmission shifts. If you understand the difference between an engine control module (ECM) and a body control module (BCM, you'll quickly identify which system is responsible for an issue. This knowledge also assists in scanning for trouble codes to isolate faults more effectively. Diagnostic tools and methods. From simple test lights to advanced oscilloscopes, technicians employ a broad range of diagnostic tools. A multimeter measures voltage, current, and resistance, while a scan tool interfaces with the car's onboard computer to retrieve data and error codes. Mastering the words and concepts behind these devices ensures that you choose the right approach for each task. Whether you're chasing a parasitic draw or verifying sensor signals, precise language around your tools and methods streamlines the diagnostic process. Hybrid, electric, and emerging technologies. Hybrid powertrains. Hybrid vehicles combine an internal combustion engine with one or more electric motors. Terms like regenerative braking, battery pack, and inverter describe the heart of this system, where kinetic energy can be converted back into electric charge. Understanding these concepts clarifies how hybrids achieve better fuel efficiency. As more hybrid models enter the market, recognizing the correct terminology ensures you can adapt your skill set for vehicles that blend traditional and modern propulsion methods. Electric Vehicle Basics. Fully electric vehicles, EVs, rely solely on batteries and electric motors, omitting the gas engine altogether. Words like motor controller, charging port, and range anxiety have entered mainstream automotive vocabulary. Technicians must become adept at terms like kilowatt-hour, which measures battery capacity, and DC fast charging, which references higher voltage stations. Mastery of EV terminology positions you for success in a rapidly expanding segment of the automotive world. High-voltage safety. Electric and hybrid vehicles often use high-voltage systems that require specialized safety precautions. Cables marked in bright colors, like orange, indicate high-voltage lines. Understanding the difference between high-voltage disconnects and 12V circuits is critical to avoid electrocution risks. The unique hazards in these vehicles necessitate training in the proper vocabulary, ensuring no mistakes are made during routine services or emergency procedures. Fuel cells and alternative fuels. Beyond hybrids and EVs, some cars use fuel cells powered by hydrogen, generating electricity internally. Terms like fuel cell stack, hydrogen tank, and water exhaust often appear in discussions about zero-emission technologies. Additionally, you might encounter CNG, compressed natural gas, or LPG, liquefied petroleum gas, in certain fleet vehicles. Familiarity with these words helps you navigate evolving energy landscapes, preparing you to service a diverse array of power sources. The future of automotive terminology: as vehicles become more software-driven, terms like over-the-air updates and autonomous driving weave themselves into everyday parlance. While advanced driver assistance systems, ADAS, handle tasks like lane centering or automatic braking, new language emerges to define each feature. Keeping pace with evolving terminology positions you as a resourceful professional, ready to tackle the next wave of automotive innovation. Practical tips for expanding your vocabulary: reference manuals and technical guides. Consistently consulting reference materials helps keep your automotive terminology accurate. Service manuals, parts catalogs, and manufacturer technical bulletins contain official definitions and clear diagrams. Spending time with these resources pays off when you're explaining to a colleague why a certain gasket or sensor must be replaced. Habitual reading also familiarizes you with alternative terms or brand-specific nomenclature, ensuring you're well prepared for different makes and models. Engaging in hands-on learning: nothing cements a term in your memory better than working on the actual component. Reading about a throttle body is helpful, but physically handling one or removing carbon buildup from its valves creates a lasting impression. If possible, shadow experienced technicians and observe how they label parts and procedures in real time. This tangible experience builds a stronger bridge between theory and practice, making each piece of vocabulary come alive. Using technology to your advantage: online forums, video tutorials, and digital apps can expedite your learning process. Some platforms even offer 3D renderings that let you see inside engines or transmissions. While caution is necessary, since online content varies in accuracy, trusted channels can significantly boost your vocabulary. Cross-referencing multiple sources helps confirm that you're adopting the right terms and the correct context for each word. Asking questions and seeking clarification: in a fast-paced shop, it's easy to gloss over words you don't fully grasp. However, asking a colleague to explain or offering a quick, "just to clarify," fosters an environment of shared growth. Most seasoned professionals appreciate curiosity and will take a moment to ensure you understand. Over time, these dialogues create a community of knowledge, reducing errors and reinforcing professional standards in communication. Building a personal glossary: many technicians keep a small notebook or digital document to compile new terms. It might include definitions, diagrams, or notes on how a specific part interacts with other components. Regularly revisiting your personal glossary helps embed the words in long-term memory. Over time, this reference can evolve into a robust, specialized dictionary, representing your unique journey through the automotive world. Final reflections and looking forward: integrating terminology into daily tasks. The ultimate goal of mastering automotive terminology is to weave it seamlessly into your day-to-day responsibilities. From writing repair orders to explaining a complex repair estimate, clear language reflects competence and attention to detail. Your words help unify a team's efforts, reassure customers, and foster trust in your expertise. By making precise vocabulary an everyday habit, you elevate the overall standard of service within any shop or dealership. Enhancing customer satisfaction through clarity: customers often feel overwhelmed by jargon. With an extensive vocabulary at your disposal, you can tailor your explanations to what they genuinely need to know. This is not about dumbing things down, it's about selecting the right level of detail to convey confidence, empathy, and understanding. A customer who leaves feeling informed and respected is more likely to return and refer others, underscoring the tangible benefits of communication skills. Consistency and accuracy: using the correct terms consistently prevents confusion, whether you're diagnosing a problem, logging it into a digital system, or ordering parts. When shops adopt a uniform vocabulary, every team member benefits. Technicians can switch tasks or shift schedules without losing context, and management can trace repairs or revisit past jobs more efficiently. This consistency in terminology also contributes to more reliable record-keeping and data analysis, which can shape future service improvements. The ongoing nature of learning automotive technology never stands still, and neither should your vocabulary. From the next iteration of electric propulsion to breakthroughs in alternative fuels, each advancement brings fresh concepts and language. Embracing this reality keeps your mind agile and your skills relevant. The deeper your knowledge becomes, the more effectively you'll troubleshoot, adapt, and innovate, forging a long, successful career in a dynamic field. Translating knowledge into leadership. Once you've established yourself as a terminology-savvy technician, you can mentor younger or less experienced colleagues. Sharing knowledge fosters an atmosphere of learning that benefits the entire team. Over time, you may transition into roles like service manager, trainer, or even automotive educator, where your command of language will continue to be a critical asset. In many respects, clarity in speech and writing paves the way for leadership opportunities. By understanding the extensive range of automotive terminology, from basic vehicle structures and engine components to modern hybrid systems and safety features, you build a solid foundation for your entire career. This vocabulary not only streamlines technical tasks but also enhances teamwork and customer relationships. Whether you're adjusting a manual transmission, interpreting onboard diagnostic codes, or explaining cutting-edge electric drivetrains, precise word usage supports accuracy, boosts professionalism, and fosters ongoing growth. Your journey into automotive expertise begins with words, but it certainly doesn't end there. Keep exploring, keep asking questions, and let each new term deepen your grasp of this ever-evolving industry. Lesson 3. Workshop Safety Procedures and OSHA Standards. Creating a culture of safety. The importance of consistent safety protocols. A well-structured safety program in an automotive workshop is far more than just a list of rules posted on a wall. It's a set of beliefs and behaviors embedded into the daily routine of every technician, apprentice, and manager. When people understand safety as a core value rather than a burdensome set of restrictions, the entire shop functions more smoothly. For instance, simple habits like storing tools correctly, wiping up fluid spills immediately, and wearing proper personal protective equipment, PPE, all contribute to an atmosphere where risk is minimized. Over time, these consistent practices become second nature, reinforcing a proactive safety culture. Not only does this reduce the likelihood of accidents, but it also fosters mutual respect and teamwork among staff, who can trust one another to uphold common safety standards. The role of leadership in safety enforcement. Shop owners, managers, and lead technicians occupy critical positions when it comes to shaping a culture of safety. By modeling proper behavior, always wearing safety gear, following lockout/tagout procedures, and using tools as intended, they set a tone that newer or less experienced employees follow. Leadership that neglects or downplays safety signals to everyone else that shortcuts are acceptable. Conversely, when managers praise safe work habits, promptly address unsafe behaviors, and invest in ongoing safety training, they demonstrate genuine commitment to well-being. This kind of positive leadership has a ripple effect, strengthening morale and encouraging even the most seasoned technicians to stay vigilant. Balancing productivity with worker well-being. In busy workshops, productivity and efficiency often drive operational decisions. Deadlines, customer expectations, and revenue goals can create pressure to push beyond comfortable limits. Yet, a truly successful environment balances speed and quality work with the imperative of keeping everyone safe. It's vital to remember that injuries, accidents, and rushed jobs can harm long-term productivity more than they help short-term output. Safety must be seen as an investment. Fewer injuries mean less downtime, fewer lawsuits or workers' compensation claims, and improved staff retention. By embedding protective procedures into daily operations, shops avoid false choices between speed and security. Both can coexist when approached methodically. Consequences of ignoring safety. Failure to maintain safe working conditions can lead to more than physical harm. Financial ramifications, such as fines from regulatory bodies or expensive legal settlements, can cripple a small business. Even a single severe injury can disrupt workflow and tarnish a shop's reputation if customers perceive it as irresponsible or negligent. Moreover, workplace injuries can hamper a technician's entire career. A back strain or eye injury might limit the jobs they can do going forward, or reduce their earning potential. In the worst cases, ignoring safety procedures results in life-altering injuries or fatalities, an outcome no shop can afford to risk. The value of ongoing training and refresher safety isn't something you learn once and never revisit. Automotive technologies, tools, and chemicals evolve, and so do the potential hazards that accompany them. Regular refresher training, whether through monthly safety briefings or annual workshops, helps keep everyone updated on new regulations, new equipment, and emerging best practices. Moreover, rotating training topics keeps employees engaged, preventing complacency. This continuous approach ensures that safety habits remain top of mind, from the newest apprentice to the most seasoned shop veteran. Commitment to ongoing education not only maintains compliance with regulations but also cultivates a community of professionals who look out for each other. Understanding OSHA and its relevance to automotive shops. An overview of OSHA's mission. The Occupational Safety and Health Administration, OSHA, operates under the umbrella of the U.S. Department of Labor, aiming to ensure safe and healthful working conditions for employees across all industries. Within the automotive sector, OSHA sets standards that address everything from machine guarding to hazardous chemical handling. By imposing guidelines, performing inspections, and issuing citations for non-compliance, OSHA helps to reduce workplace incidents nationwide. Automotive shops that understand OSHA's mission recognize that these regulations are not arbitrary barriers, but practical measures designed to protect employees and customers. Key OSHA standards for automotive settings. Although OSHA publishes numerous regulations, certain standards apply particularly to automotive workshops. For example, guidelines about the proper use and maintenance of lifting equipment, like hydraulic lifts or hoists, fall under OSHA's machine guarding and general safety requirements. Hazard communication, HAZCOM, standards address the proper labeling and handling of automotive chemicals, while standards related to personal protective equipment, PPE, ensure technicians use gloves, goggles, and respirators when required. The Walking Working Surfaces regulations, which address slip and trip hazards, also hold significant relevance in shops prone to spills or loose cords. OSHA's inspection and enforcement powers. OSHA enforces its standards through scheduled and surprise inspections, typically triggered by worker complaints, reported incidents, or industry-specific targeting. During an inspection, an OSHA officer might examine records, interview employees, and review training logs. If violations are found, like uncovered machinery, blocked exits, or unmarked chemicals, the agency can issue fines, demand immediate corrective actions, or mandate more extensive overhauls of a shop's safety program. For shops, the best approach is to maintain compliance at all times, rather than scrambling to fix issues after an inspector arrives. Whistleblower protections and employee rights. Employees who spot safety hazards sometimes fear retaliation if they report them. OSHA's whistleblower protections aim to alleviate these concerns by safeguarding the rights of workers who come forward. Technicians who file complaints about insufficient PPE or hazardous waste disposal practices cannot legally be punished, demoted, or fired for voicing those concerns. Recognizing these protections encourages open communication, allowing potential problems to surface before they escalate. A culture where workers can freely raise red flags benefits everyone, reducing the chance of serious accidents. Leveraging OSHA resources for continuous improvement. OSHA offers an array of free resources that can aid shops in boosting their safety strategies. Online tools, webinars, and consultation services help managers identify potential hazards, develop customized safety programs, and stay informed about regulatory updates. By voluntarily engaging with these resources, automotive businesses can preemptively address issues, turning compliance into a consistent practice rather than a last-minute scramble. Moreover, many insurance providers look favorably upon shops that actively utilize OSHA's guidelines, potentially lowering the cost of business insurance policies and underscoring the financial benefits of proactive safety measures. Personal protective equipment, PPE, in the shop. The logic behind protective gear. PPE acts as the final layer of defense when administrative and engineering controls can't eliminate hazards entirely. From goggles that shield eyes against flying metal fragments to steel-toed boots that guard against dropped parts, each piece of equipment addresses a specific threat. The logic is straightforward. While tools and machines may include safety features, small oversights still occur. A technician welding without a proper face shield risks burns, while someone working with volatile chemicals without gloves might suffer severe skin irritations. PPE ensures that even if an error happens, the body remains protected. Eye and face protection in an automotive setting, the risk of airborne debris is practically constant. Grinding brake rotors, cutting metal exhaust tubing, or even working under a pressurized fluid system can launch tiny particles toward the face. Safety glasses, goggles, and face shields come in multiple forms, each suited to different tasks. For instance, goggles provide a seal around the eyes and are ideal for tasks involving chemicals, whereas a clear face shield can protect the entire face from sparks during grinding. Technicians should select equipment rated by recognized standards, ensuring durability and clarity. Hand and skin protection. The hands often do the most intricate work, so they need robust protection. Different tasks demand different gloves. Nitrile or latex gloves work best for light chemical exposure or small hardware handling, while heavy-duty mechanics gloves protect against cuts, abrasions, and heat. Additionally, barrier creams or specialized sleeves can safeguard forearms when dealing with corrosive substances. By investing in suitable hand protection, technicians reduce the likelihood of lacerations, chemical burns, and chronic issues like dermatitis, ultimately maintaining nimble, pain-free hands necessary for skilled workmanship. Respiratory safety and air quality. Modern vehicles house various chemicals and complex fluids. The painting and refinishing process also introduce hazardous vapors and particles. Respiratory protection might be as simple as a disposable dust mask for sanding tasks or as sophisticated as a supplied air respirator in paint booths. Shops must assess the air quality during tasks like brake cleaning, where asbestos can still occasionally be encountered, or when welding metals that emit harmful fumes. By equipping technicians with respirators fitted to their faces and job requirements, shops minimize the risk of respiratory diseases, which can develop gradually over years of unprotected exposure. Footwear and protective clothing. Heavy components, rolling carts, and dropped tools pose constant foot hazards. Steel-toed boots or shoes with composite toe caps help cushion an accidental impact. Slip-resistant soles are equally vital in a workshop prone to oil spills and wet floors. Protective clothing, like coveralls or shop coats, keeps regular attire clean while offering an additional barrier against chemicals and sparks. When clothing is flame-resistant, (FR), it becomes even more useful during welding or tasks involving open flames. These items might seem inconvenient, but they minimize injuries that can sideline a technician for days or weeks. Safe use of tools and equipment. Proper handling of hand tools. Screwdrivers, wrenches, and pliers appear benign compared to towering machinery, yet they cause numerous minor injuries when misused. Handles that are cracked or loose can slip mid-turn, leading to cuts or bruised knuckles. Tools used for tasks they weren't designed for, like using a screwdriver as a chisel, may break and send shrapnel flying. Appropriate usage, coupled with routine inspections and replacements, keeps hand tools in optimal shape. While it may seem basic, ensuring the right tool is used for each job fosters safer, more efficient repairs. Power tools and Corsair-powered ratchets, electric drills, and angle grinders expedite tasks but bring added dangers. Loose clothing or hair can become entangled in rotating components, while damaged cords pose electrocution risks. Extension cords scattered on the floor introduce trip hazards, especially if they thread across busy walkways. To mitigate these risks, technicians must check cords for fraying, use grounded outlets, and keep cords organized away from main thoroughfares. Additionally, conscientious power tool operation, like waiting for the grinder wheel to stop spinning before setting it down, prevents accidents from happening in an idle moment. Lifting and hoisting equipment from floor jacks to two-post lifts. Automotive workshops rely on equipment that raises vehicles or heavy components for better access. If a lift fails or is used improperly, the consequences can be catastrophic. Proper training on each piece of lifting equipment is essential, including understanding weight capacities and the correct contact points on a vehicle's chassis. Regular inspection ensures that mechanical parts, hydraulic systems, and safety locks are in good condition. Ground conditions, like even, level floors, matter as well. By adhering to manufacturer guidelines and never exceeding the rated load limits, shops can prevent disastrous collapses. Lockout/tagout for hazardous energy sources, electrical, hydraulic, or pneumatic, pose hidden threats when performing service or maintenance on equipment. Lockout/tagout, LOTO, procedures lock those energy sources in the off or neutral position, preventing unexpected startups. In a busy environment, it's easy for someone to flip a switch without realizing another technician is working on the machine. With a lock and tag in place, everyone knows the machine is under repair and cannot be energized. This system drastically reduces the risk of accidents, ensuring that each technician maintains control over machinery during critical repairs. Safe tool storage and organization. A disorganized workshop is inherently more dangerous. Tools left on bench tops can roll off and fall onto someone's foot. Cluttered floors encourage trips and slips. Proper storage, whether in a shadow board, a labeled drawer, or a specialized rack, makes finding the right tool straightforward and ensures it's returned when done. This systematic approach saves time and reduces frustration while also minimizing stray hazards. Over the long term, a neat environment fosters professional pride in both the workspace and the craft, benefiting productivity and safety alike. Chemical handling and hazard communication. Importance of the Hazard Communication Standard. The Hazard Communication Standard, often referred to as HAZCOM, is an OSHA framework that ensures employees know about the chemicals they handle. This includes labeling requirements, safety data sheets, SDS, and training on potential health risks. Automotive technicians frequently encounter substances like solvents, brake cleaner, and battery acid, each carrying unique hazards. A well-executed HAZCOM program demystifies these chemicals, teaching employees how to store, dispense, and dispose of them safely. When everyone grasps the nature of potential exposures, they're better equipped to protect themselves. Interpreting safety data sheets, SDS. An SDS offers comprehensive information about a chemical, detailing its properties, potential health effects, first aid measures, and recommended protective equipment. Yet, reading one can be daunting without training. It's essential to know how to find relevant sections quickly, such as how to handle leaks and spills or recommended PPE. For technicians, key points might include flash points, safe storage temperatures, or the chemical's reactivity with other substances. Workshops that teach employees to interpret SDS information foster greater confidence when dealing with unfamiliar or highly toxic chemicals. Correct labeling of containers. A ubiquitous violation in automotive shops is transferring chemicals into secondary containers, such as spray bottles, without proper labeling. This practice can lead to dangerous mix-ups, where a technician might assume a bottle contains water when it's actually a solvent. Ensuring every container bears a clear, standardized label, including hazard warnings, is a fundamental step in hazard communication. Even if a fluid is common or used daily, lacking the proper label can cause confusion, particularly for new employees or visitors, ultimately increasing the chance of mishaps. Safe storage and spill response. Chemicals must be stored in cabinets or areas designed for their specific hazards, flammable liquids in a fire-resistant cabinet, corrosives in dedicated shelving, and so forth. In addition, keeping incompatible chemicals separated is crucial. Mixing an acid with a base can cause violent reactions. An organized storage system includes designated areas for oil, coolants, and other commonly used products, along with clear signage. On the event of a spill, immediate containment and cleanup procedures become critical. Absorbent pads, neutralizing agents, and proper disposal methods should be readily available, and all technicians should know exactly how to employ them. Personal hygiene and decontamination. Technicians often work hands-on with oils, greases, and solvents that can be harmful if ingested or absorbed through the skin. Simple practices like washing hands thoroughly before meals or using protective barrier creams help prevent chemical exposure. Shops should maintain well-stocked washing stations with running water, soap, and, ideally, eye-wash stations in case of accidental splashes. Changing out of contaminated clothing before heading home also protects families from indirect exposure. By prioritizing personal hygiene and decontamination, technicians reduce the cumulative impact of chemical contact, preserving long-term health and well-being. Fire prevention and emergency preparedness. Identifying fire hazards. An automotive shop contains multiple potential fire starters, flammable aerosols, oily rags, welding sparks, and electrical wiring. Locating these hazards is a proactive measure that reduces the likelihood of ignition. Simple tasks like keeping oily rags in sealed metal containers, ensuring extension cords aren't overloaded, and storing flammable chemicals properly can drastically lower fire risk. Technicians who remain vigilant for anything that generates heat, flames, or friction are more likely to catch problems early. Proper use of fire extinguishers. Fire extinguishers come in different classes, A, B, C, D, targeting specific fire types, such as ordinary combustibles, flammable liquids, or electrical fires. In many automotive contexts, a multi-class extinguisher, often labeled ABC, is essential. Knowing how to use one properly involves memorizing the pass method: pull, aim, squeeze, and sweep. Regular training drills ensure that in a high-stress situation, technicians won't hesitate or misuse the equipment. Additionally, shops must keep their extinguishers serviced, checking pressure gauges and seals to guarantee functionality. Evacuation plans and routes. Even with preventative measures in place, fires can happen. Therefore, having clear evacuation procedures is a must. Evacuation maps showing exits, safe meeting points, and alternate routes should be posted prominently. Technicians need to know how to shut off critical machinery and power sources quickly if time allows. During drills, employees practice moving to designated assembly areas so supervisors can account for everyone. A clear and well-rehearsed evacuation plan can be the difference between a manageable incident and a tragic outcome. Fire suppression systems and alarms. Larger shops or those handling significant volumes of flammable materials may benefit from sprinkler systems, which automatically engage when heat reaches a certain threshold. Smoke or heat detectors can alert occupants well before flames spread, allowing precious time to extinguish the fire or evacuate. Regular maintenance of these systems is crucial. A malfunctioning alarm or clogged sprinkler head can offer a false sense of security. By testing alarms periodically and conducting mock scenarios, shops confirm that their systems function effectively. Contingency plans for other emergencies. While fires are a primary concern, emergencies like chemical spills, severe weather events, or medical crises also require preparedness. A robust emergency action plan delineates roles: who calls 911, who administers first aid, and who seals off hazardous areas. Clear communication channels, such as a designated alert system or radio channel, help coordinate quick responses. In some cases, shelters or designated safe rooms may be appropriate. Regularly updating and practicing these plans prepares everyone to handle various crises calmly and effectively. Ergonomics and physical well-being. Common automotive-related strains and injuries. In a workshop, technicians lift heavy parts, bend under dashboards, and strain to loosen rusted bolts. Over time, these repetitive motions can cause musculoskeletal disorders, back pain, tendinitis, or carpal tunnel syndrome. Often, these ailments develop slowly, making them easy to overlook until they become serious. Recognizing early signs, like consistent stiffness or mild aches, can prompt changes in posture, tools, or routines. By acknowledging these risks, shops can address and reduce them, preventing chronic issues. Proper lifting techniques. A straightforward way to avoid back and shoulder injuries is by using correct lifting methods. This involves bending at the knees, keeping the load close to the body, and using leg muscles rather than the lower back. Whenever possible, technicians should use mechanical aids, hoists, dollies, or lifts, rather than relying solely on brute force. Overextending or twisting while carrying heavy loads is a common mistake that leads to acute injuries, reinforcing the need for consistent training and reminders on proper form. Tool selection for improved ergonomics. The right tool can reduce strain. Ergonomically designed handles, lightweight materials, and angled grips help keep wrists and arms in neutral positions. Even the length of a ratchet handle can impact torque application, requiring less physical exertion. Shops that invest in ergonomic alternatives, such as well-designed creepers or adjustable height workbenches, see benefits in reduced worker fatigue and fewer repetitive strain injuries. Over time, these subtle improvements can dramatically enhance comfort and productivity. Stretching and micro-breaks. Simple stretches or short breaks can seem inconsequential, but they can have a substantial impact on muscle health. Periodically pausing to stretch shoulders, wrists, and lower backs can alleviate tension before it leads to injury. Encouraging a few minutes of break time every couple of hours not only revives focus but also gives the body a moment to recover from repeated motions. Some shops go as far as introducing group stretch sessions at the start of shifts, an approach that might feel unusual initially but proves invaluable in the long run. Workplace adjustments for long-term sustainability. Ergonomics is an ongoing initiative rather than a one-time fix. As tasks evolve and new equipment arrives, work processes should be revisited. For instance, reorganizing the layout to keep commonly used parts within easy reach can prevent excessive reaching or twisting. Similarly, rotating tasks among technicians can avoid overburdening one person with a particularly demanding job. By remaining flexible and open to adjustments, shops promote longevity among their workforce, keeping experienced technicians healthy and able to work comfortably for many years. Safe handling of batteries and electrical systems. Recognizing battery hazards. Automotive batteries hold significant amounts of electrical energy and often contain sulfuric acid. Improper handling or shorting the terminals can cause sparks, leading to burns or even explosions. Cracked battery cases can leak acid, creating chemical burn risks. That's why wearing eye protection and gloves whenever handling a battery is paramount. If the battery is an AGM, absorbent glass mat, or lithium-ion type, as found in hybrid or electric vehicles, technicians must also understand specialized procedures, as these newer designs pose different risk profiles. Disconnecting and reconnecting batteries. A vital safety tip involves disconnecting the negative cable first to minimize the chance of a short circuit. Reconnecting follows the reverse order, connecting the positive cable first. Technicians who bypass this method sometimes create accidental sparks if a metal tool contacts the chassis while the battery remains fully connected. Equally important is consulting the vehicle's manufacturer guidelines, especially in modern cars where the battery's removal might reset certain electronic systems. Knowledgeable handling avoids damage to sensitive modules while preventing personal injury. Jump-starting and charging precautions. When a vehicle's battery is dead, jump-starting or using a charger is common. However, connecting jumper cables incorrectly can cause dangerous voltage spikes. Proper procedure includes verifying cable color codes, red to positive, black to negative, and ensuring the donor vehicle's alternator can handle the load. Standing back when making the final connection is wise, as sparks are possible. After the successful jump, removing cables safely in the reverse order prevents accidental short circuits. Taking these precautions reduces the risk of arcs that can injure a person or fry sensitive electronics. Hybrid and electric vehicle. High-voltage systems. Hybrids and fully electric vehicles, EVs, often use high-voltage battery packs capable of delivering lethal shocks. Technicians working on these systems must follow strict protocols to power them down before commencing repairs. Specialized training covers the use of insulated tools and the importance of wearing Class 0 rubber gloves rated for high-voltage tasks. Additionally, some designs feature orange-colored cables indicating high-voltage lines, a visual cue demanding caution. Understanding these distinctions is crucial because conventional automotive skill sets do not automatically equip technicians to handle high-voltage components safely. Battery disposal and recycling. Automotive batteries are not standard waste. Lead-acid varieties must be recycled or disposed of at certified facilities due to their toxic materials. Similarly, lithium-ion packs require specialized handling, as improper disposal can lead to fires or environmental harm. Shops should partner with authorized recyclers who ensure toxic substances are contained, preventing soil or water contamination. Adhering to legal disposal rules also avoids potential penalties. Beyond compliance, responsible recycling underscores a shop's commitment to environmental stewardship, important for both community relations and the planet's well-being. Protecting hearing and managing noise. Common noise sources in an automotive shop, from roaring engines to pneumatic tools and metal-on-metal contact. The automotive environment can be extremely loud. Over time, repeated exposure to high decibel sound leads to permanent hearing loss, a risk that often goes unnoticed until it's too late. Technicians who spend entire shifts in these surroundings face a significant cumulative impact, so it's imperative to identify specific tasks or areas with elevated sound levels. Noise monitoring devices or simple decibel meters can help measure these spots, enabling proactive action. Selecting appropriate hearing protection. Earplugs and earmuffs represent the most common forms of hearing protection. Earplugs fit inside the ear canal, while earmuffs fit over the entire ear. Each type is rated with a noise reduction rating, NR. By matching the decibel level of the environment with the correct NRR, technicians can achieve adequate protection. Some tasks may only need foam earplugs, while extended grinding or metalwork sessions might call for higher-grade earmuffs. Overprotection can also be a concern if verbal communication is compromised, so choosing the right balance is key. Implementing quiet zones and barriers. Not all tasks require the same level of noise. If possible, segregating particularly loud activities, like metal cutting or using impact tools, into designated areas reduces overall shop-wide noise. Installing barriers, acoustic curtains, or sound-dampening materials can also help contain decibels. For instance, a welding booth might be lined with fireproof, sound-absorbing panels. These structural solutions minimize the radius of noise pollution, offering quieter zones for other technicians to hold conversations or perform less noisy tasks without risking hearing damage. Rotating tasks to minimize exposure. Prolonged exposure amplifies hearing damage risk. One strategy is rotating technicians between noisy tasks and quieter responsibilities, distributing the decibel load more evenly. For example, a single individual doesn't have to handle all the hammering or compressed air drilling throughout the day. This rotation not only benefits hearing conservation but also provides cross-training opportunities, diversifying skill sets among the team. Planning these rotations effectively requires coordination from shop management, ensuring that productivity remains consistent while protecting employees' ears. Early detection and periodic hearing tests. Beyond protective gear and organizational measures, consistent hearing evaluations help catch early signs of damage. Annual or biannual hearing tests, often arranged through occupational health clinics, establish baselines and detect changes in auditory thresholds over time. If a technician shows a decline in hearing, interventions can be adjusted, perhaps upgrading hearing protection or reducing exposure. Identifying shifts early can be a wake-up call for both the individual and shop management to reassess noise control measures. Housekeeping, orderliness, and accident prevention. The connection between cleanliness and safety. Slips, trips, and falls rank high among workplace accidents, and many stem from clutter or poorly maintained floors. A tidy environment not only looks professional but also significantly reduces the likelihood of mishaps. Keeping walkways clear, cleaning up oil or coolant spills promptly, and returning tools to their storage spots all matter. Often, the root cause of a slip is something as trivial as a stray rag or an unnoticed spill. Simple housekeeping measures can prevent these scenarios from ever arising. Waste management and recycling protocol. Shops generate various waste streams: used oil, metal shavings, plastic containers, and more. Some of these items, like oily rags or used solvents, qualify as hazardous waste. Proper disposal requires placing them in specified bins and, if necessary, working with certified haulers. Recycling common materials, cardboard, metal cans, scrap parts, also keeps the workspace orderly and helps fulfill environmental obligations. By creating labeled collection points, shops make it easy for technicians to separate trash from recyclables, reducing the chance of hazardous cross-contamination. Organized workstations and benchtops. When a workstation is piled high with random tools and parts, the risk of injury rises. A cluttered bench can hide sharp objects or lead to accidental contact with hot surfaces. Organizing frequently used tools within easy reach, possibly using a pegboard or modular storage trays, avoids the chaotic rummaging that wastes time and creates hazards. Additionally, color coding or labeling helps technicians quickly spot the correct tool without rummaging through a cluttered drawer. This streamlined approach boosts efficiency and safety, demonstrating a high level of craftsmanship. Floor maintenance and slip resistance. Concrete floors can become dangerously slick if coated in oil, coolant, or water. Regular mopping or scrubbing with appropriate cleaning agents prevents residue buildup. Installing non-skid mats in particularly high-traffic or spill-prone areas, like around parts washers, adds an extra layer of protection. Inspecting drain systems and ensuring they function properly can further minimize puddling. By integrating these steps into daily or weekly routines, shops maintain traction and reduce the chance of slip and fall incidents. The role of signage and visual cues, such as hazard signs, floor markings, or color-coded bins, provide instant guidance and reminders. For instance, painting a yellow line around a designated walkway clearly indicates that no tools or materials should obstruct that zone. Signs near chemical storage areas can alert technicians to wear specific PPE. Even simple reminders, like a poster saying, "Report spills immediately," reinforce good habits. These visual elements complement verbal communication, ensuring crucial information is readily available, especially for newcomers or visitors. Cultivating a mindset of continuous safety improvement. Incident reporting and root cause analysis. No matter how well prepared a workshop may be, near misses or minor incidents can still occur. Reporting these events promptly allows the team to analyze what happened and why. A structured root cause analysis goes beyond blaming a single individual, aiming to uncover systemic flaws, like outdated equipment, confusing instructions, or unrecognized hazards. By addressing these underlying problems, the workshop evolves into a safer, more resilient environment. This approach transforms mistakes into learning opportunities, preventing repetition. Learning from other industries. While the automotive field has its unique hazards, best practices from other sectors, like manufacturing, construction, or aviation, can offer fresh insights. For example, lean principles from manufacturing might inspire an optimized shop layout. Structured shift handovers common in healthcare could improve communication between technicians at shift changes. Embracing a cross-industry perspective broadens the scope of potential safety solutions, ensuring that automotive shops aren't confined to a narrow set of ideas. Employee empowerment and participation. A top-down approach where only managers make safety decisions can overlook crucial observations from frontline staff. Empowering technicians to voice concerns, offer suggestions, or conduct peer audits encourages collective responsibility. If a new technician spots a snagging hazard on a rarely used piece of equipment, they should feel safe to raise the alarm. Involving employees in safety committees or giving them the authority to halt a job if they see an imminent risk fosters a sense of shared stewardship. Recognition and rewards for safe behavior. Humans respond to reinforcement. Acknowledging employees who consistently adhere to safety protocols or who propose effective improvements fosters a positive cycle. Whether it's a simple safety star, bulletin board, a gift card, or a formal award ceremony, recognition underscores that the shop values diligence and initiative. This communal appreciation fosters a supportive atmosphere where individuals strive to maintain safe practices not just because they have to, but because it is recognized and celebrated. Adapting to technological advancements. As automotive technology advances, ranging from advanced driver assistance systems, ADAS, calibration to electric vehicle battery maintenance, new risks and required precautions emerge. Continuous safety improvement hinges on staying informed about these changes. Investing in updated tools, specialized PPE, and advanced training paves the way for a modern and secure workspace. Technological evolution is relentless, and shops that adapt promptly reduce both operational risk and the potential for catastrophic incidents tied to unfamiliar equipment. Final thoughts on safety as a cornerstone of professional excellence. The human element of risk management. It's easy to view shop safety solely through the lens of regulations and protocols. Yet, every rule exists because real people have been hurt or killed by ignoring it. Understanding the gravity of that truth fosters compassion and vigilance. A well-run safety program isn't just about checking boxes, it's about ensuring your fellow workers return home healthy every day. Keeping that human perspective front and center makes safety feel personal and encourages technicians to look out for one another. Enhancing customer confidence. Customers rarely see the back of shop procedures, but they feel reassured when they see a neat, orderly environment and staff wearing appropriate PPE. An accident-prone workshop can tarnish customer trust, as it implies a lack of professionalism that might extend to the quality of repairs. By diligently upholding OSHA standards and best practices, shops indirectly enhance their public image, often leading to better word-of-mouth referrals and loyal repeat business. A safe shop is a shop people want to patronize. Linking safety to quality. Safe behavior aligns with methodical, detail-oriented work practices. For instance, a technician mindful of personal protective equipment is also more likely to double-check torque specs or verify proper part fitment. Conversely, a shop that tolerates shortcuts in safety might also cut corners in repairs, risking poor outcomes or customer dissatisfaction. Emphasizing safety naturally cultivates thoroughness, elevating the overall quality of work and reducing the incidence of mistakes. The evolving landscape of compliance. Safety regulations are not static, governing bodies amend rules to address emerging threats or new technologies. Automotive shops that stay informed through trade associations, workshops, and OSHA bulletins can anticipate changes rather than scramble retroactively. This proactive stance enables a smoother transition whenever new rules arise, be it a requirement for advanced respirator fit testing or updated guidelines for electric vehicle battery handling. Preparedness in meeting evolving standards serves as a competitive advantage, signaling a shop's adaptability and professionalism. Commitment to lifelong learning. Safety knowledge, like automotive technology knowledge, requires periodic refreshment. As new tools, vehicles, and processes appear, old assumptions become outdated. In a truly progressive environment, every technician, regardless of experience, remains a learner. Encouraging questions, exploring alternative safety methods, and attending specialized training sessions promote an ethos that embraces continuous improvement. This learning culture, grounded in safety, positions a workshop at the forefront of industry best practices and ensures staff remain engaged, prepared, and confident in their daily tasks. By integrating these principles, ranging from personal protective equipment choices to OSHA-driven procedural compliance, an automotive workshop can foster an environment where safety is second nature. This focus not only protects individual technicians but also boosts the collective efficiency and reputation of the business. As you continue learning about automotive technology, never lose sight of the fact that a safe workshop underpins every successful repair. Ingraining robust safety habits early on lays the groundwork for a long, successful, and hazard-free career in the automotive industry. Lesson 4: Hand tools, power tools, and equipment maintenance. Automotive professionals rely on a broad range of tools and equipment to effectively diagnose, repair, and maintain vehicles. From trusty hand tools like wrenches and screwdrivers to advanced power tools such as impact drivers and pneumatic ratchets, each item plays a specific role in streamlining tasks. At the same time, equipment maintenance is a cornerstone of shop efficiency and safety, ensuring every job can be done without unnecessary hazards or delays. This lesson explores the key aspects of selecting, using, and caring for the tools and machinery that form the backbone of automotive service work. By the end, you will understand how proper handling and upkeep lead not only to better outcomes on individual repairs but also to improved workflow, safety, and longevity for your entire arsenal of equipment. The essential role of hand tools. Choosing the right hand tool for the job. Automotive hand tools are designed with specific tasks in mind. Selecting the appropriate tool can mean the difference between a swift repair and a frustrating battle with stubborn components. For example, a standard wrench and a socket wrench both tighten bolts, yet each excels under different conditions. Standard wrenches offer quick accessibility in tight spaces, whereas socket wrenches provide greater leverage for removing stuck fasteners. Proper tool selection reduces the risk of injury, protects vehicle parts from damage, and promotes a more efficient workflow. When you're confronted with diverse automotive repairs, ranging from brakes to suspension components, taking the extra moment to choose the right hand tool saves time, conserves energy, and ensures a professional standard of craftsmanship. Proper grip and handling techniques. Mastering the way you hold and maneuver hand tools is a subtle but crucial skill. A secure, purposeful grip prevents the tool from slipping and potentially causing accidents. Additionally, correct hand posture minimizes fatigue, letting you work comfortably over extended periods. Always keep your wrists aligned with your forearms to prevent strain, and engage your upper body rather than just your wrists when applying force. If you find yourself forcing a tool beyond its normal range, it's often an indication that an alternative approach or tool might be needed. Practicing these handling techniques every day reinforces safe habits and ensures you get the most out of each tool you use. Preventing tool damage and wear. No matter how well made a wrench, screwdriver, or plier set may be, improper use leads to premature wear or even breakage. Pushing a screwdriver to pry something not meant for prying can bend the shaft or warp the tip. Similarly, using pliers to tighten bolts instead of a correctly sized wrench can round off both the fastener and the tool's jaws. By respecting each hand tool's design limits, you extend its lifespan and avoid the frustration of a stripped screw or broken handle in the middle of a critical repair. In many shops, it's standard practice to do a quick inspection of tools after a job. If a handle is loose or a tip is worn, making timely replacements or repairs prevents bigger headaches down the road. Organizing hand tools for efficiency. Keeping hand tools neatly arranged in a designated toolbox, tool chest, or pegboard system not only boosts efficiency but also helps maintain a safer workspace. When you know exactly where each tool goes, you spend less time searching and reduce the risk of accidentally leaving tools inside an engine bay or footpath. Additionally, systematically returning each tool to its rightful place after use becomes a form of discipline that benefits the entire shop. Other technicians can quickly find the tools they need, and there's less clutter to trip over. Over time, a well-organized tool system becomes second nature, fostering an environment where every team member operates in sync, sharing resources and respecting each other's space. When to invest in upgrades or replacements. Hand tools aren't meant to last forever if they're subjected to heavy daily use. Even the most durable chrome vanadium sets can accumulate fatigue or rust spots over years of exposure to moisture, chemicals, and torque. Knowing when to replace tools or invest in higher quality upgrades is vital for maintaining professional standards. Sometimes, purchasing premium tools with advanced features, such as ergonomic grips or specialized coatings, pays dividends in the form of improved comfort and longer lifespans. Weigh factors like overall usage frequency, the cost of constant replacements, and potential safety risks. Spending a bit more for a high-quality ratchet set might save you from repeated downtime, ensuring consistent performance for crucial vehicle repairs. Diverse categories of hand tools. Wrenches and their applications. Wrenches form the backbone of automotive hand tools, designed to grip and turn fasteners without stripping threads or damaging heads. Combination wrenches, which feature an open end on one side and a box end on the other, give mechanics two gripping options in one tool. Meanwhile, adjustable wrenches, though versatile, can sometimes slip and are best used as a stopgap until the correct size is located. There are also specialized wrenches, like flare nut wrenches for brake line fittings, that reduce the chance of rounding off delicate hex shapes. Recognizing these differences lets you adapt to a wide range of tasks, from simple oil changes to intricate engine rebuilds. Screwdrivers, bits, and driver set screwdrivers come in various shapes and sizes, each tailored to a particular screw head. Phillips and flathead are classics, but many automotive applications also use Torx, hex, or positive screws that demand specific driver bits. Understanding the nuanced differences allows a snug fit, preventing slippage that can strip threads or heads. For professional shops, a comprehensive driver set is invaluable, covering everything from small dashboard fasteners to heavier-duty screws on engine components. Using the correct driver bit not only speeds up your work but also helps maintain the integrity of the vehicle's hardware. Pliers and clamping tools. Pliers provide gripping power and come in various forms: needle nose, slip joint, locking, and cutting pliers, to name a few. Each design focuses on different functionalities. Needle nose pliers excel in tight or recessed areas, while cutting pliers handle wires or small fasteners. Locking pliers, sometimes referred to as vice grips, clamp onto an object and hold it firmly, freeing your hands for other tasks. However, these tools must be used judiciously to avoid deforming parts or leaving deep bite marks. By knowing the strengths and limits of each plier style, you gain greater control over intricate tasks like wiring or clamp removal. Hammers, punches, and chisels. While they might appear as crude implements, hammers, punches, and chisels are integral to certain automotive repairs. A ball-peen hammer is commonly used for shaping metal or striking punches and chisels, whereas rubber or plastic mallets help avoid damaging delicate surfaces. Punches assist in driving out pins or aligning bolt holes, and chisels can cut through corroded fasteners or separate components fused together by rust. Precision and caution are paramount. Striking too hard can cause damage or injuries. Using the correct hammer face and pairing it with the right punch or chisel for the job is the surest path to accuracy and safety. Measuring and marking tools. Automotive tasks often require precise measurements to ensure exact tolerances, especially for engine or transmission work. Calipers, micrometers, tape measures, and dial indicators help you confirm whether components are within manufacturer specifications. Marking tools, such as scribes or paint markers, can highlight alignment points or reference marks on belts and pulleys during disassembly. Even routine jobs like brake rotor measurements rely on measuring tools to check thickness, so that you can determine whether machining or replacement is appropriate. Maintaining calibration and proper storage for these instruments preserves accuracy and reliability. Introduction to power tools. The benefits of power tools in automotive work. Power tools speed up repairs and reduce physical strain by providing automated torque, cutting, or drilling capabilities. Whether it's using an impact wrench to remove lug nuts effortlessly or an electric drill to create precise holes, these advanced tools consistently outperform hand tools in tasks requiring repetitive motion or higher power. By reducing the time spent on each job, power tools often lead to higher productivity and increased customer satisfaction. Additionally, consistent torque delivery from power wrenches lessens the likelihood of under- or over-tightening fasteners, preserving the vehicle's mechanical integrity. However, they require more caution than hand tools due to their higher operating forces. Electric versus pneumatic power tools. In many professional shops, air-powered, pneumatic tools have long been the norm due to their reliability and power-to-weight ratio. Pneumatic impacts, ratchets, and grinders remain popular for jobs that demand substantial torque. On the other hand, electric or cordless power tools have gained ground thanks to improvements in battery technology. Cordless impacts and drills offer the advantage of mobility, eliminating the need for hoses or cords that can clutter the floor. Deciding between pneumatic and electric often depends on shop setup, budget, and frequency of use. An established workshop might lean towards an air system, whereas a mobile mechanic might favor cordless solutions. Safety precautions when using power tools. Despite their convenience, power tools pose substantial risks if used incorrectly. High rotation speeds or torque can cause sudden shifts, leading to wrist injuries or lost control. Loose clothing, long hair, or jewelry can get entangled in rotating parts, causing severe harm. Additionally, many power tools create loud noises, making hearing protection essential. Training is crucial to ensure that each technician understands the controls, such as the trigger locks or direction switches on a power drill, before operating it. Adding proper PPE, like eye protection, gloves, and earplugs, completes a safety routine that drastically lowers the chances of accidents or long-term health issues. Balancing speed and precision. One of the greatest advantages of power tools is their ability to perform tasks quickly. However, faster isn't always better if it comes at the expense of precision. A novice might inadvertently strip threads or snap bolts by applying excessive force with an impact driver. Skilled professionals learn to modulate trigger pressure, apply intermittent bursts of torque, or use adjustable settings for tasks that require delicate handling. Balancing speed and accuracy is an art. Knowing when a fast approach is beneficial and when a controlled approach is paramount ensures high-quality workmanship without wasted time or unnecessary rework. Maintenance and care for power tools. Just like vehicles, power tools need regular attention to operate at peak performance. For pneumatic tools, draining the air compressor's moisture traps, lubricating moving parts, and checking hose connections prevent rust and performance dips. Electric tools demand battery checks, cord inspections, and motor cleaning to keep them in top shape. Dust or debris buildup can also reduce efficiency or cause overheating, so wiping down tools and storing them in clean, dry areas is recommended. While these upkeep tasks may seem minor, they significantly extend tool life, saving money and averting costly replacements or repairs. Proactive maintenance is an investment that pays off in a more reliable, productive workspace. Exploring different types of power tools. Impact wrenches and their uses. Impact wrenches deliver high torque through a rotational hammering mechanism, making them perfect for loosening or tightening heavy-duty fasteners like lug nuts or suspension bolts. There are subvariations: air impact wrenches typically used in commercial garages, and cordless impacts favored by mobile mechanics or when hoses are inconvenient. Knowing how to adjust torque levels is critical to avoid damaging threads or wheels. When used with quality sockets, an impact wrench can dramatically speed up wheel removals, brake jobs, and other repetitive fastener tasks. Mastering this tool's power ensures quick, reliable work without the risk of overtorque or stripped hardware. Drills, drivers, and their attachments. Automotive tasks often involve drilling holes in sheet metal, plastic components, or even tough steel. A drill's versatility expands significantly with the right attachments, from step drill bits for enlarging existing holes to wire brush attachments for cleaning rusted surfaces. Cordless drivers may be smaller in size but excel at tasks that require rapid screw or bolt insertion and removal. Equipping them with the correct bits or adapters is essential for a perfect fit. Thorough knowledge of the motor's speed settings, clutch adjustments, and forward/reverse options allows for safe and precise operation, whether you're installing interior panels or fastening license plates. Pneumatic ratchets and their advantages. Pneumatic ratchets are essentially air-driven wrenches that excel in locations where a hand ratchet could become tiresome or space is restricted. Their compact head design can fit into tight engine bays, speeding up tasks like removing timing cover bolts or intake manifolds. However, one must be mindful of torque limitations. A pneumatic ratchet typically exerts less force than a full-sized impact wrench and can stall on stubborn fasteners. On the plus side, it eliminates repetitive wrist action, reducing strain during long hours of disassembly. Technicians who appreciate efficient, clutter-free operation often keep a pneumatic ratchet close at hand. Grinders, sanders, and polishers. Surface preparation and finishing are vital parts of many automotive tasks, from bodywork to brake rotor resurfacing. Grinders remove rust or old paint, while sanders smooth out surfaces before repainting or refinishing. Polishers help restore gloss to body panels, headlight lenses, and other surfaces. It's crucial to use the correct abrasive or polishing pad for the job. Coarse abrasives are effective at removing material quickly but can leave scratch marks, while fine abrasives and polishing pads produce a cleaner finish. Always secure the workpiece or vehicle part and wear protective eyewear, as flying debris or abrasive particles can be particularly hazardous. Specialty power tools in automotive settings. Beyond the conventional drills and impacts, shops employ a variety of specialized power tools. For instance, a power brake bleeder can streamline brake fluid changes, reducing both time and the margin for error. Heat guns can loosen adhesives or help form thermoplastic materials. Electric cut-off wheels or reciprocating saws tackle exhaust work or metal trimming needs. Each specialized tool targets a specific set of tasks, improving precision and reducing manual labor. While these devices can be a bigger investment, they often pay for themselves by saving labor hours and improving results, especially in high-volume or specialized service environments. Fundamentals of equipment maintenance. The significance of scheduled maintenance. Whether it's a hydraulic press, an air compressor, or a tire mounting machine, automotive workshop equipment faces ongoing mechanical stress. Scheduled maintenance is crucial to detect wear, replace worn parts, and verify safe operation. Neglecting these tasks can lead to breakdowns at the worst times, such as a busy weekend or a deadline for an important client. Preventive measures, including lubricating bearings, replacing seals, and checking fluid levels, keep equipment running smoothly and reduce the risk of abrupt failures. Additionally, a machine that's consistently cared for will operate more efficiently, saving energy and extending the overall service life of your investment. Cleaning and lubrication essentials. Dust, dirt, and fluids are inevitable in an automotive environment. Over time, these contaminants can build up within machinery, affecting delicate parts such as switches, gears, or pneumatic valves. Regular cleaning, using compressed air or specialized solvents, removes grime, while proper lubrication ensures moving components remain friction-free. Each piece of equipment typically has a manufacturer's guide specifying recommended cleaning agents and lubricants. Adhering to these guidelines not only preserves performance but also avoids compatibility issues that could degrade rubber seals or corrode metal surfaces. A meticulously cared-for piece of equipment will show fewer signs of wear, generate more consistent results, and be safer to operate. Inspecting for wear and potential failures. Technicians familiar with day-to-day equipment usage are often the first line of defense in spotting early warning signs. Loose belts, frayed hoses, unusual vibrations, or burnt odors can indicate impending failures. Conducting routine inspections, whether weekly or monthly, helps catch such problems before they escalate into costly repairs or dangerous accidents. Tools like thermal imaging devices or vibration analysis can be employed to identify hidden trouble spots. While some workshops rely on specialized maintenance crews, every technician should cultivate a habit of reporting anomalies quickly. Addressing minor issues early is far cheaper and safer than dealing with a catastrophic breakdown after it has caused collateral damage. Replacing worn components. No matter how robust a machine is, parts inevitably reach the end of their service life. A hydraulic lift might need new seals every couple of years, while a tire balancer belt can show cracks after extended use. Neglecting timely replacements leads to subpar performance and potential safety hazards. Sourcing quality replacement parts that match the manufacturer's specifications is key. Cheap imitations might fit initially, but they often fail prematurely or jeopardize system integrity. Technicians should track part numbers, keep an inventory of critical spares, and document replacement dates for easy reference. By managing wear parts proactively, shops ensure their machinery runs smoothly, day in and day out. Record-keeping and maintenance logs. Accurate record-keeping underpins every successful maintenance program. Logs detailing inspection dates, replacement parts, adjustments, and any unusual incidents serve multiple purposes. First, they provide a historical account that can reveal recurring issues or patterns. Second, they're invaluable for compliance with safety regulations or manufacturer warranties. If an inspector asks when a lift was last serviced, a well-maintained log eliminates guesswork. Likewise, technicians can consult these records to determine whether a piece of equipment is due for an overhaul or if it still has service life left. This organized approach fosters accountability, ensures consistent standards, and helps the entire shop function at a professional level. Specific automotive equipment and their care vehicle lifts and hoists. Vehicle lifts are central to most automotive shops, giving technicians full access to a car's underside. Different styles exist, such as 2-post lifts, 4-post lifts, and scissor lifts. Regardless of design, regular load testing, lubrication of posts or hinges, and inspection of locking mechanisms are critical. Hydraulic fluid must be changed and monitored, as contamination can reduce lift performance. Safety features, like autolock systems, should always be tested before hoisting a vehicle. A disciplined routine that includes cleaning the lift area, checking for leaks, and verifying anchor bolts ensures technicians can work beneath elevated vehicles with confidence and minimal risk. Air compressors and air distribution. For shops relying on pneumatic tools, the air compressor serves as the heartbeat of operations. Compressors should be sized appropriately to handle the cumulative demands of multiple tools running simultaneously. Regular maintenance includes draining condensation from the tank, replacing air filters, and checking belts or direct drive couplings. Maintaining the correct oil level, if it's an oil-lubricated unit, is also essential for cooling and sealing. Moreover, the distribution system, hoses, fittings, and couplers, must be checked for leaks or wear. A small air leak might seem insignificant, but over time it wastes energy, reduces tool efficiency, and can degrade compressor longevity due to constant cycling. Tire and wheel service machinery. Tire changers and wheel balancers play a pivotal role in any busy shop that handles tire rotations or replacements. A well-calibrated tire machine can demount and mount tires without harming the bead or rim. Balancers ensure smooth operation on the road by detecting imbalance and guiding you on the correct placement of weights. These machines require routine calibration checks and cleaning, as tire dust or debris can interfere with sensors. Worn plastic protectors should be replaced to avoid scratching expensive alloy wheels. Neglect leads to reduced precision, which can trigger customer complaints and rework, undermining a shop's reputation for quality tire service. Battery chargers and testing stations. Battery chargers come in many forms: simple trickle chargers, fast chargers, and advanced diagnostic units that test battery health. Maintaining these devices goes beyond checking cables for frays. Circuits and internal components can degrade over time, especially in high-usage environments. If your shop uses advanced battery diagnostic stations, firmware updates may be necessary to keep pace with new battery technologies. Periodically cleaning the clamps with a wire brush prevents poor electrical contact, while ensuring the device's cooling fan is unobstructed prevents overheating. Properly maintained battery service equipment leads to more accurate testing, fewer misdiagnoses, and extended battery life for customers' vehicles. Alignment racks and measuring systems. Computerized alignment systems rely on cameras, sensors, and precision racks to measure wheel angles relative to the vehicle's suspension. Any misalignment in the alignment equipment itself can lead to flawed readings and compromised drivability. Keeping the cameras or sensors clean and free of obstructions is a priority. Regular calibration ensures readings remain accurate, requiring specialized procedures typically outlined by the equipment manufacturer. The rack, too, needs maintenance. Hydraulic lines, locking pins, and drive-on ramps should be inspected for wear or leakage. With consistent care, alignment systems deliver consistent, accurate results, bolstering a shop's reputation for top-tier steering and suspension service. Safe operation and storage strategies. Designing a tool and equipment layout. A thoughtful workspace layout reduces steps, prevents congestion, and lowers accident risks. Positioning large equipment like lifts, tire machines, and alignment racks in strategic spots ensures smooth flow from one area to another. Tools frequently used in conjunction, like wheel balancers near tire changers, should be placed close by. This arrangement minimizes carrying heavy parts across the shop floor. Additionally, wide, clear pathways let technicians move freely without stumbling over cords or clutter. When planning an optimal layout, consult with the entire team to learn about their daily workflow and ensure that each station supports their needs. Storing hazardous or specialized tools. Certain automotive tools involve hazardous materials, such as refrigerant recovery machines or specialized cutting tools. Storing them demands extra precautions to protect both the equipment and the user. Flammable or pressurized products, for example, may require cabinets that meet fire code regulations. Electrical or electronic devices might need protective covers to shield them from dust or moisture. Labeling storage areas with hazard warnings clarifies the nature of what's inside, discouraging unauthorized or casual access. This disciplined approach not only enhances safety but also prolongs the life of specialized or sensitive equipment, ensuring it functions reliably when called into service. Lockout/tagout for inactive equipment. Lockout/tagout, LOTO, procedures aren't just for large industrial plants, they apply to automotive shops as well. When a machine is under repair or maintenance, isolating its energy sources is critical to avoid accidental startups that could injure a technician. Applying a physical lock on the power switch or air supply line prevents anyone from energizing the equipment. A tag attached to the lock indicates who is working on it and why. This system fosters clear communication. Other staff members can immediately see that the tool or machine is off limits. Adhering to LOTO practices underscores a serious commitment to workplace safety and eliminates costly mistakes that can occur when multiple people work on shared resources. Handling large or heavy components. Transmissions, cylinder heads, and entire engine blocks are heavy items that require mechanical assistance for safe handling. Overhead hoists, engine cranes, or specialized lifting jacks keep the technician's body safe from strain or injury. Rolling these components on carts or dollies rather than manually lifting them reduces the risk of slipped discs or muscle tears. When aligning an engine to transmission or setting it onto an engine stand, carefully plan the sequence to avoid sudden shifts in weight. Using the correct rigging points and ensuring the crane or hoist is rated for the weight promotes safe, damage-free movement of large automotive assemblies. Seasonal considerations for storage and use. Climate conditions can influence how you store and operate certain equipment. High humidity environments may lead to rust on metal parts if not stored properly, while freezing conditions can thicken lubricants or crack plastic components. Storing power tools in a stable temperature area prevents damage to batteries and electronics. Equipment reliant on hydraulic fluid can exhibit sluggish movement in cold weather, necessitating a seasonal change to a lighter-grade fluid or a warm-up routine. By anticipating weather-induced wear, shops can adapt their maintenance schedule to maintain consistent performance throughout the year, guaranteeing reliable service in any season. Extending tool and equipment lifespan. Routine calibration of precision instruments. Torque wrenches, alignment sensors, and tire pressure gauges all need periodic calibration to ensure they remain accurate. Even a slight deviation in torque readings can lead to under- or over-tightening critical components, risking safety on the road. Calibration labs or manufacturer-authorized centers can verify the measurements against a known standard, adjusting if necessary. Documenting calibration results in a log clarifies when the next check should happen. The cost of calibration is minor compared to the potential liability of a faulty tool leading to mechanical failures. Committing to a calibration schedule not only extends the usable life of precision equipment but also fortifies a shop's reputation for reliable, detail-oriented service. Protective covers and cases. Dust, moisture, and physical impacts can degrade sensitive tools. Utilizing protective covers or cases for items like diagnostic scanners, digital multimeters, or advanced battery testers is a simple way to shield them from harm. Many tools ship with custom-fit cases that cradle them snugly, reducing the jostling that can misalign delicate internal components. Even large equipment may have fitted covers to keep off dirt during off-peak hours. This practice preserves the cosmetic and functional aspects of the equipment, sparing technicians from frustrating malfunctions during critical jobs. Over time, these protective measures help every piece of gear remain in prime working condition, enhancing its overall longevity. Staff training and correct usage. Even if a shop invests in top-of-the-line equipment, untrained or careless usage can compromise durability. Staff training ensures everyone understands not just the fundamentals of operation, but also the subtleties that preserve the machine's health, like not forcing a lift to raise a vehicle over its rated capacity or never running a tire balancer without securing the wheel properly. Regular refresher sessions and open forums where technicians can ask questions about usage help maintain consistency. This holistic approach promotes respect for the shop's assets and encourages personal accountability. When every individual treats tools and equipment as communal property that deserves meticulous care, both productivity and tool lifespan rise significantly. Keeping replacement parts on hand. Minimizing downtime often involves storing essential replacement parts for frequently used tools and equipment. Items like drive belts, O-rings, or standard gaskets have a finite service life and can fail unexpectedly. Having backups readily available means you can fix a minor issue and get back to work without waiting days for shipments. Storing these parts in labeled bins or cabinets expedites the repair process, especially when the failure occurs during peak business hours. By systematically auditing spare part usage, shops can predict future demand and replenish stock accordingly, keeping operations smooth and limiting disruptions. Monitoring performance over time. Wear and tear on tools and machines can be slow and insidious, with performance deficits creeping in almost unnoticed. Setting benchmarks, such as how long an air compressor takes to fill the tank or how accurately a wheel balancer measures repeated spins, allows you to monitor any decline in function. Subtle dips might hint at internal leaks, motor inefficiencies, or software calibration drifts. By capturing these metrics, technicians can take action before a tool crosses the line from slightly worn to major breakdown. This proactive mindset not only extends operational life but also supports a continuous improvement philosophy, where each incremental fix contributes to a more seamless, efficient workflow. Troubleshooting common equipment problems. Diagnosing power loss and electrical issues for power tools. Sudden drops in performance often point to electrical troubles. A cordless drill may drain its battery unusually fast due to failing cells, or a wired device might show intermittent power if the cord or plug is damaged. Starting with the simplest checks, like ensuring outlets have correct voltage or verifying extension cords aren't overly long, can save time. Inspect the tool's internal connections for corrosion or loose wires. Sometimes, a minor fix like replacing brushes in an electric motor resolves a seemingly big performance issue. Systematic diagnostics, guided by user manuals or technical schematics, keep you from blindly guessing and help pinpoint the root cause efficiently. Hydraulic and pneumatic leaks. Oil puddles under a hydraulic lift or a noticeable hiss of escaping air from a pneumatic tool are red flags of leaks. Identifying the source might involve applying a soapy water solution to suspect joints or checking hoses for cracks. Whether it's an O-ring that has hardened or a loose fitting that needs tightening, addressing leaks promptly prevents fluid wastage, maintains consistent pressure, and reduces the risk of machinery damage. Unchecked hydraulic or pneumatic leaks can escalate into more significant mechanical failures, so a quick response not only protects the equipment but also ensures technicians can continue working without disruptive downtime. Excessive vibration or unusual noises. Equipment that starts vibrating more than usual or producing grinding, squeaking, or knocking noises could be warning you about misalignment, worn bearings, or damaged internal components. While some vibrations are normal, especially in rotating machinery, excessive shaking indicates a potential imbalance in the motor or a bent shaft. Listening closely can help differentiate between a minor alignment issue and a severe internal breakdown. Turning the machine off immediately to investigate can avert catastrophic damage. In many cases, tightening a set screw or replacing a simple bearing eliminates the disturbance. Documenting these fixes ensures the problem doesn't reoccur or remain hidden. Overheating concerns. Motors, compressors, and pumps rely on proper cooling to operate within safe temperature ranges. Overheating might manifest as a burning smell, a tripped breaker, or unexpectedly frequent cycling. Causes range from clogged air intakes to insufficient lubrication. Sometimes, a cooling fan fails, or a protective shroud is missing. Keeping vents clear of dust, cleaning filters, and verifying fluid levels reduce the chance of temperature spikes. Continual overheating will degrade seals, warp internal parts, and significantly shorten the equipment's life. Resolving the issue at its earliest sign is crucial to prevent costly repairs or permanent damage. Software and calibration glitches. Modern automotive equipment often includes computerized interfaces that streamline tasks like alignments, diagnostics, or balancing. Software bugs, glitchy sensors, or corrupted calibration data can lead to erroneous readings. The system might freeze mid-operation or produce obviously wrong measurements. Checking for available firmware updates, verifying sensor connections, and recalibrating the system following manufacturer guidelines are first steps. If the problem persists, consulting technical support or certified repair services is advisable. Ignoring these digital issues risks providing inaccurate results to customers, undermining confidence and potentially causing mechanical problems if the misguided data is used to make vehicle adjustments. Economic and professional impact of proper tool management. The financial benefits of well-maintained equipment, tools and machinery are significant investments, and their maintenance influences your bottom line. Proactive care extends the functional lifespan, delaying or even preventing expensive replacements. Additionally, well-maintained tools often perform tasks more efficiently, reducing labor hours and energy consumption. The cost of routine lubrication or part replacements is minor compared to the potential loss of business if a key piece of equipment fails mid-job. Over time, the cumulative savings manifest in healthier profit margins and a more stable business outlook, proving that good stewardship of tools is as vital as any marketing or sales strategy. Enhanced workshop reputation and customer trust. Customers notice when a shop is organized and uses equipment that appears clean, modern, and functional. This visual cue often correlates with perceived quality and professionalism. A shop that invests in premium tools and diligently maintains them sends a message of seriousness about craft and attention to detail. That impression can translate into repeat business, as customers feel confident their vehicles are being handled with care. On the other hand, a disorganized shop with outdated, poorly maintained tools might suggest corner cutting and inattention to detail, potentially pushing customers to seek service elsewhere. Reducing downtime and increasing productivity. Equipment breakdowns or missing tools stall workflow and create backlogs that frustrate both employees and clients. Swift, on-time repairs become harder to achieve if the right tool is broken or a critical machine is offline. By implementing regular inspections, prompt part replacements, and thorough training on correct operation, shops minimize these setbacks. The result is a smoother schedule, more vehicles serviced per day, and happier clients. In a competitive automotive environment, consistent uptime can be a deciding factor that sets a shop apart from competitors who struggle with unexpected interruptions. Employee satisfaction and skill development. Technicians value an environment where they have reliable tools and clear processes for equipment upkeep. It boosts morale, fosters a sense of pride, and encourages them to refine their expertise. When employees trust that a lift won't malfunction or a pneumatic tool won't fail mid-task, they can focus their energy on delivering quality repairs. Moreover, offering opportunities to learn advanced tool operation or be involved in maintenance builds a sense of ownership. This collaborative setting helps retain skilled technicians who appreciate both the efficiency and the respect for safe, well-equipped working conditions. Long-term career advantages for technicians. Mastering not only the usage of hand and power tools but also the principles of equipment care can shape a technician's career trajectory. Employers across the industry seek individuals who uphold best practices in tool management, viewing them as reliable and detail-oriented professionals. Technicians who cultivate these habits might advance to lead roles, overseeing shop operations or training new hires. Even if one transitions to another shop or starts an independent service, the reputation for excellence in tool stewardship remains a valuable asset. Building these solid habits early on supports a lifetime of safe, productive, and respected automotive work. fostering a culture of continuous improvement, team-based training and knowledge sharing, encouraging open dialogue about tool usage and maintenance fosters a collaborative atmosphere. Veteran technicians can pass along tips about efficient ways to handle specialized equipment or subtle signs that a part is about to fail. Scheduled training sessions, where staff can practice or revisit tool operation under supervision, reinforce best practices. This approach not only promotes consistency but also uplifts newer team members who might feel overwhelmed by the sheer variety of tools. By regularly pooling insights, everyone grows, and the shop as a whole benefits from reduced mistakes and faster task completion. Implementing standard operating procedures, SOPs, written SOPs offer a roadmap for consistent results. Rather than relying on memory or hearsay, every technician can consult a concise document for tasks like calibrating the alignment rack or cleaning the brake lathe. These step-by-step guides detail the tools needed, safety precautions, and recommended sequences of operation. SOPs reduce the learning curve for new hires and serve as a checkpoint for seasoned employees to confirm their following current methods. Periodically reviewing and updating SOPs in line with new technology or lessons learned in the shop ensures that they remain living documents, always reflecting the best way to handle a particular process or piece of machinery. Monitoring trends and technology, staying current with emerging innovations, be it in hand tool materials, cordless battery improvements, or advanced diagnostic equipment, keeps a shop competitive. Technicians who keep an eye on new features, such as brushless motors in power tools or improved torque-limiting technology, can recommend strategic upgrades. These investments may initially seem expensive, but they often pay off through faster repairs, lower maintenance demands, and better user safety. Attending industry expos or reading trade magazines can spark new ideas and help spot beneficial trends. Continual evolution in tooling and processes underscores a shop's forward-thinking mindset, appealing to both clients and potential hires. Open feedback loops and suggestion systems. Mechanics on the front lines often notice small inefficiencies or vulnerabilities in the workflow. Creating a formal channel, like a suggestion box or digital form, makes it easier for them to highlight needed repairs, propose layout changes, or recommend new tools. Management can then evaluate these suggestions, prioritizing changes that yield the greatest benefit. Recognizing and acting on employee feedback not only solves daily irritations but also demonstrates respect for their expertise, boosting morale. Over time, this collective effort refines tool management, organization, and maintenance strategies until they run like clockwork. Celebrating improvements and benchmarks. Shifting a shop's culture toward meticulous tool and equipment care doesn't happen overnight. Celebrating milestones, whether it's going a certain number of days without a tool-related accident or successfully implementing a new maintenance schedule, helps reinforce the positive behaviors that led to those results. It could be as simple as a morning shout-out in a team huddle or a small reward, but public acknowledgement of improvements cements the idea that careful stewardship matters. Gradually, this recognition fosters a work environment where everyone takes pride in both their skill set and the well-maintained arsenal of tools at their disposal. By thoroughly understanding how to choose, use, and maintain hand tools, power tools, and essential shop equipment, automotive professionals secure smoother operations and heightened safety. Rather than viewing tools as mere objects, treating them as investments, worthy of methodical inspection, cleaning, and upkeep, creates a positive ripple effect. Tasks become more efficient, repairs yield more consistent results, and overall job satisfaction climbs. Balancing performance with longevity ensures that every socket, lift, or specialized device contributes to the workshop's success for years to come. Embracing continuous learning and adopting a preventive, rather than reactive, stance on equipment management ultimately sets the stage for a thriving automotive career in a reputable shop environment. Lesson 5: Fasteners, Gaskets, and Sealants. An overall understanding of why fasteners, gaskets, and sealants matter in automotive work. Automotive systems are intricately assembled from thousands of parts, and the success of any repair or maintenance project relies heavily on small components such as fasteners, gaskets, and sealants. Despite their size, they play oversized roles in ensuring integrity, reliability, and durability. Whether it's a bolt holding a suspension component together or a gasket sealing an engine's oil pan, these elements protect against leaks, vibrations, and structural shifts. Mastering their selection and application paves the way for seamless mechanical performance and minimizes the risk of rework caused by preventable failures. It's easy to overlook these details, yet a loose fastener or a leaking gasket can erode customer trust and endanger a vehicle's safety. Some automotive repairs can appear straightforward until a corroded bolt snaps or a gasket disintegrates upon removal. In these stressful scenarios, knowledge of how different metals, elastomers, and sealing compounds behave proves vital. When you're standing in front of a complex assembly, being able to identify and properly handle the correct hardware can save hours of frustration and potential reassembly errors. More than just parts that hold or seal, they represent the backbone of automotive craftsmanship and professional pride. Another aspect that underscores their importance is cost-effectiveness. While fasteners, gaskets, and sealants themselves are typically low-cost items, misapplications can lead to expensive damage or downtime. A poorly chosen sealer might gum up crucial oil passages, or the wrong bolt grade might stretch under load. It's far more efficient and economical to do it right the first time, investing in the correct hardware and sealants from the onset. Workshops that emphasize this understanding tend to develop strong reputations for reliable, high-quality repairs. Most vehicle manufacturers provide detailed service information about recommended fastener torque values, gasket material types, and sealant applications for each subsystem. These specifications aren't random, they come from engineering trials and rigorous testing under extreme conditions. Adhering to them results in vehicles that run closer to factory standards, showcasing the synergy between engineering precision and proper technician practices. Where flexibility is allowed, technicians must then rely on their knowledge of materials and design principles to make confident choices. Finally, growing environmental and regulatory awareness has put a spotlight on even these small components. Certain sealants emit volatile organic compounds, and specific gasket materials might not be suitable for all markets or emission standards. Being aware of these evolving regulations helps technicians and shop owners maintain compliance while still delivering robust, reliable vehicle service. As vehicles become more sophisticated, the significance of advanced fasteners, specialized gaskets, and eco-friendly sealants will only continue to expand. Fundamental types of fasteners used in automotive applications. Cars feature myriad fasteners, each type tailored to specific demands. Bolts, for instance, come in countless styles, from hex head bolts for engine mounts to specialized shoulder bolts that maintain precise clearances. In many assemblies, you'll also find studs, which are threaded rods anchored on one end to a housing, leaving the opposite end available for a nut. Studs help secure components like exhaust manifolds, especially in areas with high heat where repeated removal of a bolt might wear threads in the engine head. Appreciating these variations helps avoid the mistake of forcing the wrong type of threaded fastener into a hole. Nuts complement bolts and studs. Lock nuts, castle nuts, and flange nuts each address unique mechanical challenges. Lock nuts, for example, have nylon inserts or deformed threads that resist loosening under vibration, helpful in steering and suspension setups. Castle nuts pair with cotter pins to keep rotating parts in place, preventing them from backing off unexpectedly. Flange nuts spread the load over a broader surface area, often eliminating the need for a separate washer. Knowing which nut to use is crucial for matching torque stability with disassembly convenience. Beyond the typical bolt and nut combination, automotive environments also rely on self-tapping and sheet metal screws. These fasteners can create or maintain threads in thinner materials, like engine covers, interior panels, or brackets. The difference in their thread profiles allows them to bite effectively into softer metals or plastics. Careful handling is mandatory. Over-tightening a self-tapping screw can strip out the newly formed threads, leading to a loose assembly. Always match the screw size and pitch to the application to ensure reliable holding power. Threaded inserts, sometimes referred to as helicoils or timeserts, fix worn or damaged threads. By tapping a larger hole and installing a coiled or solid insert, you essentially recreate the original thread size. It's a lifesaver when a stripped spark plug hole threatens to ruin an entire cylinder head. Though these inserts represent a secondary solution, they still require attention to detail for a proper fit. Using them demands accurate drilling, tapping, and alignment to guarantee robust results. Rivets and special automotive clips complete the array of common fasteners. Blind rivets require access from only one side, making them useful for areas where a bolt/nut combo is impractical. They're often used in body repairs or specialized bracket mounting. Plastic push-type clips secure interior trim pieces or splash shields in engine bays. These tiny clips might seem trivial, but incorrect replacements can lead to panels rattling or water intrusion. Recognizing their design, whether tree-type, expanding, or barbed, helps technicians reinstall them properly during routine maintenance or collision repairs. The metals and strength ratings behind fasteners. Automotive fasteners are commonly manufactured from steel, though other materials like aluminum, stainless steel, or titanium make appearances in specialized settings. Steel alloys vary in carbon content and heat treatment, altering tensile strength and ductility. Grade markings on bolt heads, such as 8, 10, 9, or 12. 9 in metric applications, or grade 5 or grade 8 in SAE, reflect these mechanical properties. The higher the grade, the stronger the bolt, but also the more rigid it can be, meaning it may snap instead of bend under extreme conditions. Recognizing these markings helps ensure that the correct bolt is selected for a job, balancing both yield strength and elasticity. Coatings and surface treatments protect fasteners from corrosion. Zinc plating, galvanized finishes, and specially formulated coatings like Dacrymet offer degrees of rust resistance. In harsh environments, like exhaust systems or coastal regions with salty air, higher corrosion protection can be essential to prevent seized threads or structural weakening over time. Technicians should also note that changing a fastener's coating might alter torque requirements, as lubricity and friction coefficients vary. Stainless steel fasteners, especially those made from 304 or 316 alloys, resist rust effectively. However, stainless steel can gall under heavy torque if used without lubrication, causing the threads to bind. Careful consideration of torque specs and anti-seize usage is crucial, especially in high-temperature contexts like brake or exhaust assemblies. The choice to use stainless steel often centers on the desire for rust-free performance, but it requires an understanding of how to mitigate thread galling and potential galvanic corrosion when paired with dissimilar metals. Aluminum fasteners crop up in certain lightweight components, especially in motorsports or performance-driven vehicles. While these reduce weight, they cannot handle as much load as steel. Torque values must be carefully managed to avoid stripping. Additionally, aluminum can corrode when directly contacting stainless steel or other dissimilar metals. A protective layer or suitable washers might be needed to isolate the materials. For technicians, recognizing aluminum's softness is key. Never assume it can match the same service environment as a standard steel bolt. In extreme performance settings, titanium fasteners sometimes replace steel to save even more weight without sacrificing too much strength. However, the cost is significantly higher, and specialized torquing procedures and lubrication can be necessary. Titanium threads can also gall or seize if not treated properly. For most general automotive work, they're an overkill, but in specialized racing or high-end sports cars, they illustrate the leading edge of fastener technology. Even so, a technician must remain mindful that the principles of correct torque, corrosion considerations, and alignment remain vital, no matter how exotic the metal. Gasket fundamentals and their critical functions. Gaskets serve as essential sealing interfaces between two surfaces, such as an engine block and its cylinder head, or a transmission case and its oil pan. They account for microimperfections on mating surfaces by compressing to fill gaps, preventing fluids or gases from escaping. Even the most precisely machined components aren't perfectly smooth, so gaskets provide a forgiving yet robust barrier. Their role is pivotal. A compromised gasket often leads to coolant leaks, oil seepage, or reduced compression, each with its own potential for causing engine damage or reliability issues. The simplest gaskets are flat, cut from sheet materials such as paper, cork, or rubber. While these seem basic, they're selected for specific environments. Cork gaskets, for example, can handle moderate temperatures and have an inherent resilience that helps in irregular flanges, though they may degrade over time with oil exposure. Paper gaskets, sometimes impregnated with resin or other sealants, are cost-effective but not suitable for extreme temperatures or high pressures. Their success depends heavily on the evenness of surface clamping and the correct application of torque. Complex gaskets may feature multiple layers, metal reinforcements, or molded rubber profiles. For instance, multi-layer steel, MLS, head gaskets have become the standard in modern engines, especially those with aluminum heads. MLS gaskets accommodate temperature differentials and expansion rates between different metals while withstanding the high cylinder pressures found in boosted applications. Their precision thickness, combined with coatings, ensures a stable seal under intense conditions, though they do demand immaculate mating surfaces and the correct torque sequence. Gaskets also come into play beyond engine assemblies. Intake and exhaust manifolds have specialized seals that cope with temperature fluctuations and thermal expansion. Oil pans need flexible gaskets that handle vibrations and engine movements. Transmission pans rely on gaskets specifically designed for contact with transmission fluid. Each location requires materials compatible with the fluid types, temperature ranges, and mechanical stresses inherent to that part of the vehicle. One size rarely fits all. Mismatching gaskets can result in early failure and repeated leaks. Torque is the gasket's best friend and worst enemy. Over-tightening can crush or deform the gasket, leading to cracks or uneven sealing. Under-tightening, on the other hand, allows gaps that lead to leaks. Following the manufacturer's recommended torque settings and patterns is essential. These patterns ensure even compression around the entire perimeter of the gasket. While this might feel time-consuming, it's an investment in preventing the tedious rework required if a seal fails prematurely. Exploring different gasket materials and designs. Rubber gaskets are commonly found in engine valve covers, oil pans, and other moderately stressed areas. Modern synthetic rubbers such as Viton or silicone-based compounds withstand higher temperatures and resist chemical breakdown better than older natural rubber options. This resilience is key in maintaining a consistent seal over many heat cycles. Yet, rubber gaskets can deteriorate if exposed to constant heat or harsh fluids beyond their design limits, leading to brittleness or shrinkage. Technicians can often gauge a gasket's remaining life by its flexibility and appearance during disassembly. Metal gaskets offer higher rigidity and can handle extreme pressures, commonly used for exhaust manifolds or turbocharger flanges. Some incorporate expansion ridges or folding patterns to maintain a tight seal despite ongoing thermal cycling. Exhaust systems, in particular, see temperature spikes, vibrations, and possible misalignments over time. A metal gasket, often layered with graphite or high-temperature coatings, proves more durable in these punishing environments. On the flip side, metal gaskets demand impeccably flat mating surfaces, or they risk blowing out at the slightest gap. Composite gaskets blend materials like fiber, graphite, and metal into a single structure, leveraging the strengths of each component. Cylinder head gaskets are a prime example. Steel layers provide structural support, while graphite helps conform to surface irregularities. Such advanced designs can also integrate fire rings for each cylinder, focusing extra compression on critical combustion areas. Despite these innovations, installation errors, like surface contamination or ignoring torque steps, will still undermine the gasket's performance. Accuracy and cleanliness remain paramount. Molded gaskets, or rubber-in-groove designs, have become more common in engine covers and oil pans. These arrive in a formed shape that aligns precisely with a groove on the component, limiting the guesswork during installation. When seated correctly, they often don't require additional sealant. However, reusing them can be risky if the rubber has compressed or the edges have taken a set. Some molded gaskets come with built-in spacers that prevent overcompression, further reducing the likelihood of uneven clamping. The thickness of a gasket can also influence engine geometry. In high-performance builds, choosing a head gasket thickness can slightly alter compression ratios, affecting power output and detonation resistance. That's why many racing engine builders are meticulous about measuring deck heights and selecting gaskets that optimize combustion chamber volume. Even in standard street vehicles, using an incorrect gasket thickness or design can cause misalignment of intake ports, resulting in vacuum leaks or reduced efficiency. The interplay between thickness, material, and design underscores just how critical gaskets remain in an engine's overall performance. Overview of automotive sealants and their functions. Automotive sealants complement or sometimes replace traditional gaskets to prevent leakage of fluids like oil, coolant, or transmission fluid. They fill microscopic surface imperfections and provide a chemical bond between mating parts. Often sold in tubes or cartridges, sealants can be applied directly onto flanges during reassembly. Their formulations vary widely, from anaerobic sealants that cure without air to silicone-based RTV, room temperature vulcanizing, compounds that begin curing upon exposure to moisture. The wide variety ensures coverage for nearly any automotive scenario, provided the correct sealant is chosen. RTV silicone sealants see extensive use in engine and drivetrain assemblies due to their excellent temperature tolerance. They can handle everything from engine heat to sub-freezing temperatures, while their flexibility compensates for thermal expansion. Some versions are labeled as ultra or high temp, indicating suitability for even more extreme environments like turbocharger housings or exhaust connections. Yet, applying silicone in thick beads or letting it cure incorrectly can produce lumps that dislodge, potentially blocking oil galleries or coolant passages. Technicians must follow recommended application thickness and curing times for best results. Anaerobic sealants cure in the absence of air, making them ideal for tight-fitting metal-to-metal assemblies such as transmission cases or differential covers. They remain liquid until squeezed between surfaces, ensuring a controlled bond that's also easily cleaned if disassembled later. Their advantage lies in forming a robust seal only where needed, reducing excess. However, these sealants typically require the surfaces to be oil-free and properly primed. Any contamination can compromise curing and result in micro-leaks that only appear under load or at elevated temperatures. Thread sealants protect fastener threads or pipe fittings from leaks, especially in fuel systems or coolant lines. Unlike typical lock compounds that secure bolts in place, thread sealants remain pliable enough to prevent fluid passage along the threads. PTFE-based Teflon tapes or pastes are common in plumbing connections but must be used judiciously in automotive settings, ensuring fragments don't break off into critical passages. Loctite and similar brands produce specialized formulas for coolant and oil lines, balancing the need for sealing with the ability to remove the fitting later. Specialized sealants address unique challenges. Liquid gaskets can replace paper or cork gaskets for oil pans if specified by the manufacturer, forming a continuous bond that shapes to complex surfaces. Exhaust sealants, often paste-like compounds, resist extreme heat and help seal joints or cracks in exhaust pipes. Rubberized undercoating or seam sealers ensure water doesn't infiltrate body seams, preventing corrosion. In each case, success hinges on surface preparation, cure times, and compatibility with the fluid or environment. Grabbing any random sealant off the shelf is a gamble. Informed selection is the sure path to reliable outcomes. Guiding principles for selecting the right fasteners, gaskets, and sealants. One of the key practices in proper hardware selection is matching the component specifications to the manufacturer's recommendations or well-regarded industry standards. Service manuals often list torque values and specify the exact class of bolt or the thickness of a gasket needed. While there can be flexibility in certain situations, deviating from guidelines without a solid technical justification is risky. This approach ensures that the mechanical joint or seal is neither understressed nor overtaxed, optimizing reliability. Environmental conditions significantly influence material choices. In high-heat areas, a steel bolt with a higher grade or a specialized nickel coating might be essential to prevent thermal fatigue. If the vehicle is driven in snowy regions or near saltwater, stainless steel or carefully coated fasteners may ward off rust. Interiors or sheltered compartments might allow for lighter, lower-cost materials. For gaskets, temperature rating, fluid compatibility, and required flexibility guide the final selection. Sealants must also withstand the chemical environment, coolant, brake fluid, or gear oil, without breaking down or contaminating other systems. Budget constraints can tempt a technician to pick cheaper alternatives, but short-term savings often yield bigger expenses later. Low-grade bolts can snap under vibration, forcing an expensive extraction or leading to part damage. Inadequate sealants might degrade prematurely, causing leaks that demand significant teardown to correct. Skilled technicians learn to weigh cost, durability, and potential liability. Sometimes, the best compromise is choosing a mid-grade fastener with proven reliability rather than the cheapest or the most expensive option. Another deciding factor is ease of disassembly for future service. For instance, if a component must be removed periodically, using thread sealant that's too strong could complicate the next repair. Gaskets that permanently bond surfaces might be inadvisable if regular inspections are needed. In these cases, the technician might opt for fasteners with reusable features, or choose a sealant that's robust but still removable with standard hand tools. Balancing secure installation with serviceability is part of a forward-thinking approach that benefits both the technician and the vehicle owner over the long run. Lastly, personal experience and continuous learning enrich a technician's judgment. When a particular brand or material has performed well in the past, that success builds confidence for future jobs. Conversely, if certain fasteners frequently corrode despite theoretical compatibility, it might be time to explore better coatings or a different supplier. Gathering feedback from colleagues, following forum discussions, and taking note of engineering bulletins fosters a culture of informed experimentation. Over time, this knowledge base sharpens one's ability to select the best fasteners, gaskets, and sealants under a wide range of conditions. Proper installation techniques and best practices. Cleanliness is paramount. Even the highest grade gasket or top-tier fastener fails if surfaces are greasy or contaminated. Before bolting components together, technicians typically wipe them with a degreaser or solvent. For gaskets, ensuring both mating surfaces are free of old residue or burrs is equally critical. Sealants adhere best to surfaces that are free from oil, moisture, or rust. Any shortcuts here can jeopardize the mechanical bond, making thorough cleaning a non-negotiable habit. Equal torque distribution is key to compressing gaskets and stabilizing fasteners. For cylinder heads, oil pans, and valve covers, manufacturers often specify a crisscross or spiral torque sequence. This pattern exerts even pressure on the gasket, preventing warping or lumps. Using a calibrated torque wrench ensures that each fastener is tightened to the exact specification. In some high-stress assemblies, like engine main caps, technicians must also adhere to angle torque techniques, where bolts are turned a specific degree after achieving a preliminary torque. Failing to follow these steps can produce uneven clamping, heightening the risk of leaks or mechanical stress fractures. Lubrication of fastener threads is another subtle but important detail. Many torque specifications assume lightly oiled or dry threads. Changing thread friction, by adding anti-seize or using an alternate coating, can alter the actual clamping force. In some cases, like head bolts that pass through coolant channels, a manufacturer might specifically require thread sealant. Adhering to these instructions prevents fluid leaks or uneven torque distribution. Over-lubricating a bolt not intended for it can cause over-torquing, stretching the fastener beyond safe limits. Fasteners often need checks after a short run-in period, especially in assemblies prone to thermal expansion or heavy vibration. Exhaust flange bolts, for example, might loosen after repeated heating and cooling cycles. Rechecking torque can prevent exhaust leaks or rattles down the line. Gaskets can also settle, requiring retorquing in certain older engine designs, though many modern gaskets are designed for one-and-done torquing. Regardless, awareness of manufacturer instructions regarding follow-up checks protects the end result. Documentation closes the loop on proper installation. Noting torque values, sealant types, and batch codes for gaskets ensures traceability if a problem surfaces later. In professional environments, especially those with warranty commitments, thorough records showcase diligence and can streamline troubleshooting. Even independent technicians benefit from referencing prior work details, accelerating future repairs. This methodical habit distinguishes a seasoned professional, ensuring consistent quality and promoting trust with clients. Diagnosing and addressing common issues with fasteners, gaskets, and sealants. Loose or missing fasteners stand out as one of the most glaring issues, often revealed by rattling, vibrations, or fluid leaks. They can stem from incorrect torque, inadequate thread engagement, or simply from reusing old hardware that had compromised threads. The fix typically involves properly replacing the fastener, checking the mating threads for wear, and then retorquing to specification. In some cases, upgrading to a lock nut or thread locking compound can provide an extra layer of security against repeated loosening. Stripped threads pose another frequent headache. Over-enthusiastic tightening or cross-threading can destroy bolt or nut threads, leaving a weakened connection. Repair strategies vary from using a thread chaser to completely installing a helicoil if the female threads in an engine block or housing are damaged. The key is to remain calm and methodical. Forceful actions usually exacerbate the damage. Determining the root cause of the stripping, such as mismatched pitches or a misaligned approach, can prevent repeats of the same error. Gasket leaks typically show up as fluid seepage or drips from joints. When investigating, technicians look for evidence of a twisted or pinched gasket, uneven clamping, or contamination along the sealing surfaces. Occasionally, a mismatch between the gasket material and the fluid environment can cause premature degradation. If a leak is minor, gentle retorquing might suffice, assuming the gasket type allows it. However, significant leakage usually demands removing the component, inspecting it thoroughly, and installing a new gasket while addressing the root cause, such as a warped flange or incorrect torque. Overapplication or poor cure of sealants can create blockages or insufficient sealing. Symptoms might include restricted oil flow if a silicone bead dislodges, or persistent seepage if the sealant never fully cured due to contamination. Correcting these problems involves removing the old sealant, meticulously cleaning both surfaces, and reapplying the correct product in a thin, even layer. Patience is crucial. Some sealants need time to form a skin or partially cure before assembly. Shortcutting recommended wait periods courts repeated failures. Corrosion can degrade both fasteners and gaskets, particularly in humid or salted environments. Rusty bolts can seize, snapping off if forced. Gaskets, even those labeled as corrosion-resistant, might weaken if moisture infiltrates. Combating corrosion includes routine inspections, applying anti-seize on threads in appropriate cases, and using protective coatings or washers. Once severe corrosion sets in, replacement becomes the safest course, accompanied by preventative measures like improved drainage or rust-inhibiting sprays. Recognizing the initial signs of corrosion and addressing them early helps avoid major breakdowns. The evolving landscape of fastener, gasket, and sealant technologies. Automotive engineering continually pushes boundaries, and even the humble fastener evolves in response. Innovations in weight reduction, like advanced composite bolts or specialized alloys, have gained traction in performance vehicles. Manufacturers also explore coatings that provide enhanced corrosion resistance with minimal friction changes, allowing consistent torque. Some advanced designs integrate washers or captive nuts for more precise assembly in automated manufacturing lines. Technicians who stay aware of these trends better anticipate what they'll find in newer models or specialized performance vehicles. Gasket technologies likewise adapt. MLS head gaskets have become the norm, and refinements in coating technology have led to improved microsealing capabilities. Likewise, manufacturers experiment with elastomeric compounds that remain flexible across a broader temperature range. These materials handle greater mechanical stress without cracking or taking a permanent set. Hybrid gaskets, combining metal frames and molded rubber edges, appear in transmissions or oil pans for quicker assembly and improved durability. Forward-thinking mechanics learn to identify these designs, enabling them to recommend suitable replacements during service. Sealants, especially those used in high-performance or electric vehicles, incorporate more specialized chemical formulas. Electric powertrains often require different fluid types and more rigorous sealing to protect high-voltage components. We see an uptick in adhesives that double as sealants, used for bonding structural parts like battery enclosures. These adhesives often cure under specific conditions, thermal, UV light, or moisture levels, meaning that installing them properly takes precision and the correct environmental controls. In the near future, more vehicle assemblies might skip traditional mechanical fasteners in favor of structural adhesives where appropriate. Digital torque tools and smart assembly processes represent another progressive step. Some shops embrace torque wrenches that electronically log each fastener's torque, preventing under- or over-tightening. This data syncs with software to confirm that every bolt meets spec, leaving an electronic trail for quality audits. Such systems reduce human error, a critical factor as vehicles become more intricate. As these methods permeate the aftermarket, technicians adept at interpreting digital readouts and calibrating advanced tools stand to distinguish themselves in the job market. Finally, sustainability concerns are shaping the entire automotive supply chain, including small components like fasteners and sealants. Eco-friendly sealants with lower emissions or water-based chemistries are emerging. Biodegradable washers or packaging for fasteners help reduce waste. While these changes may seem subtle at first, they reflect broader industry shifts. Technicians who adapt to new products, reading up on their properties and adjusting installation methods, contribute to a cleaner future without compromising on performance or safety. Synthesis and future direction in mastering fasteners, gaskets, and sealants. Exploring the roles and properties of fasteners, gaskets, and sealants underscores their profound impact on a vehicle's reliability and performance. These elements, while often small or hidden, are integral to securing major subsystems, preventing dangerous leaks, and preserving structural integrity. Technicians who treat these components with respect, following guidelines for selection, installation, and maintenance, establish a track record of successful repairs. They demonstrate not just mechanical aptitude but also an eye for detail that sets apart high-caliber automotive service from mediocrity. Continuous learning stands out as the cornerstone of expertise in this field. Automakers routinely refine designs to cope with emerging fuels, advanced powertrains, and stringent emission standards. Observing service bulletins, manufacturer updates, and trade resources keeps you on the cutting edge. A willingness to experiment with new gasket materials or specialized sealants can yield invaluable experience. Rather than treating each job as repetitive, treat it as an opportunity to refine your craft, noting how various components and conditions respond to your chosen methods. Moreover, collaboration and mentorship can speed up mastery. In a busy shop, seasoned technicians may have encountered unique or obscure sealing challenges, like successfully patching a leaking differential with a specialized anaerobic product. Sharing these experiences fosters a healthy learning environment. Apprentices, in turn, bring fresh perspectives and might spot new solutions or products. Strong shops rotate knowledge among all members, ensuring every customer's vehicle benefits from the collective wisdom of the team. In the future, expect to see further integration of advanced materials. Graphene-enhanced gaskets or self-sealing fasteners may not be far-fetched. Automated assembly lines may require new categories of fasteners that allow robotic torque checks or connectivity sensors. Electric and hybrid drivetrains will bring new challenges, as battery cooling systems and power electronics demand novel sealing strategies. Technicians who keep a pulse on these developments will position themselves to handle tomorrow's vehicles with confidence. Regardless of where technology leads, the fundamentals remain consistent: pay attention to detail, respect the engineering requirements, and never cut corners on quality or cleanliness. Bolts, gaskets, and sealants might seem mundane, but they safeguard the functionality and longevity of the intricate machines we rely on. By continually honing the skills and knowledge related to these components, you build a foundation for excellence that endures through every generation of automotive technology. Lesson 6: Automotive Systems Overview and Exploration of how core systems work together to create a functional vehicle. Automobiles are more than just a collection of metal parts and electronic circuits. Each vehicle comprises multiple interconnected systems: fuel, electrical, braking, suspension, and more, that must function in harmony for a car to operate safely and efficiently. When one system lags behind or develops a fault, the effects can reverberate through the entire automobile. This interconnectedness underscores why technicians need a broad understanding of each system's purpose, layout, and maintenance requirements. From the powertrain that translates fuel to motion, to the steering and suspension that guide a vehicle along the road, each system is essential to a car's overall performance and reliability. In this lesson, we will provide an expansive overview of core automotive systems, exploring their roles, key components, and how they integrate to form the modern car. Whether you're just stepping into the automotive world or looking to enhance your knowledge, understanding these systems equips you with a stronger, more holistic grasp of vehicle design. This approach underpins the very essence of ASE, Automotive Service Excellence, certification, ensuring that practitioners see beyond single repairs, recognizing the bigger mechanical picture. By the end, you'll not only appreciate each system's function but also comprehend the countless ways they interact with one another in real-world conditions. Understanding the powertrain. The basics of internal combustion. The engine forms the heart of many automobiles, relying on the internal combustion process to convert chemical energy in fuel into rotational power. Inside the cylinders, a precise air-fuel mixture is compressed and ignited, causing controlled explosions that push pistons downward. These pistons connect to a crankshaft, translating linear movement into rotational force. It's a dance of heat, chemistry, and mechanical principles, one that requires balanced temperatures, correct fuel mixtures, and exact timing. This core concept is the backbone of automotive engineering, shaping design features like cylinder arrangement, displacement, and compression ratios. A deep grasp of internal combustion clarifies why routine oil changes, spark plug replacements, and fuel system upkeep matter so much for performance and longevity. Transferring power to the wheels and engines. Rotation alone doesn't move a vehicle. The transmission steps into harness and direct engine torque, optimizing it for speed or strength depending on driver demands. Whether manual, automatic, or continuously variable, the transmission chooses the best gear ratio to match conditions. From there, torque flows through a drive shaft or transaxle, ultimately arriving at the differential, which compensates for different wheel speeds during turns. The process is so seamless that many drivers forget the complexity beneath their feet. Understanding it helps technicians troubleshoot shifting issues, gear slip, and abnormal noises. Proper fluid maintenance, filter changes, and ensuring correct operation of components like the torque converter or clutch can make the difference between a smooth ride and a jolting one. Front wheel, rear wheel, and all-wheel drive systems. Automotive engineers utilize various drive configurations to meet different performance and traction goals. Front-wheel drive, FWD, places the engine and transaxle in the front, enhancing packaging efficiency and traction on slippery surfaces due to the weight over the drive wheels. Rear-wheel drive, RWD, offers balanced handling, favored in sports cars for its steering feel and acceleration dynamics. All-wheel drive, AWD, or four-wheel drive, 4WD, directs torque to both axles, a boon in off-road or inclement weather situations. Each setup affects weight distribution, handling characteristics, and mechanical complexity. When diagnosing traction issues, a technician must consider how power flows, from transversely mounted engines in FWD layouts to transfer cases in 4WD systems, making it vital to know each system's architecture. Hybrid and electric powertrains. With the global push toward cleaner mobility, hybrids and electric vehicles have gained popularity. Hybrids combine an internal combustion engine with one or more electric motors, capturing kinetic energy through regenerative braking and storing it in a battery. This allows electric-only propulsion at low speeds or additional motor assist during acceleration. Full electric vehicles, EVs, omit the engine altogether, relying on sizable battery packs and electric motors to provide torque instantly. These technologies change the service landscape. Traditional concepts like oil changes shift in importance, while battery health, high-voltage safety, and advanced diagnostics become paramount. Understanding these systems also illustrates how they unlock new performance potentials, like instantaneous torque and simplified transmissions. Lubrication and cooling support engines and transmissions generate heat and friction. Without an efficient lubrication and cooling network, mechanical parts degrade quickly. Engine oil, circulated by an oil pump, coats moving surfaces to reduce friction and wear. Simultaneously, the coolant system transfers excess heat from the engine to the radiator, where it's dissipated into the ambient air. Transmissions also need fluid to cool and lubricate gears and clutches. When a technician inspects coolant levels, checks for leaks, or performs an oil change, they're safeguarding the entire powertrain's lifespan. Catching minor coolant leaks or low oil pressure early averts overheating, seized components, or catastrophic engine damage. Thus, these support systems stand as silent protectors of the vehicle's heartbeat. Diving into the fuel and emission system. Fuel delivery approaches. Modern cars largely utilize electronic fuel injection, precisely measuring the needed amount of fuel. The fuel pump pushes gasoline or diesel through lines, regulated by pressure controls, delivering it to injectors. These injectors atomize fuel into the intake air. Electronic control units, ECUs, monitor parameters like engine load, temperature, and oxygen sensor readings to fine-tune injection duration. Properly functioning components ensure responsive acceleration, lower emissions, and optimal fuel economy. When faults arise, like clogged injectors or a failing fuel pump, the symptoms can include rough idling or power loss. Understanding how fuel is stored, pressurized, and sprayed is key to diagnosing these performance hiccups. Air induction and throttle control engines require more than just fuel. Air is equally critical. The intake system channels fresh air through filters and sensors into the combustion chambers. Past the air filter lies the throttle body, controlling airflow based on driver input. In older vehicles, the throttle cable was mechanical. Now, drive-by-wire systems rely on electronics. Additional components like mass airflow sensors, manifold pressure sensors, and intake manifolds shape how air enters the cylinders. A compromised intake, whether through leaks, blockages, or sensor malfunctions, immediately hinders performance. Recognizing that air induction is just as important as fuel delivery underscores the synergy needed for ideal combustion. Exhaust flow and catalytic converters. Once fuel combusts, gases must exit through the exhaust system. An exhaust manifold collects these gases, funneling them into pipes that typically pass through one or more catalytic converters. These converters chemically transform harmful pollutants like carbon monoxide and unburned hydrocarbons into less harmful emissions. Mufflers reduce noise, while oxygen sensors monitor exhaust composition, feeding data back to the ECU to adjust fuel trims. Exhaust leaks or failing catalytic converters can trigger check engine lights, reduce efficiency, and increase emissions. From a repair standpoint, addressing exhaust concerns demands knowledge of pipe routing, sensor placement, and the interplay between emissions regulations and mechanical design. Vapor recovery in EVAP systems. Evaporative emissions, particularly from fuel vapors, are a major pollution source. Automotive EVAP, evaporative emission control, systems capture these vapors, storing them in activated carbon canisters until the engine can burn them safely. Components like purge valves and vent solenoids regulate vapor flow, preventing them from escaping into the atmosphere. Many vehicles also feature onboard diagnostics that run self-tests, checking for leaks as small as a pinhole in hoses or canisters. If the EVAP system fails, the vehicle may exhibit a check engine light with codes referencing small or large leaks. Understanding the complexity of hoses, valves, and canisters aids in pinpointing leaks quickly, preserving both environmental standards and vehicle efficiency. Modern emissions controls and OBD modern vehicles incorporate advanced emissions controls to meet stringent regulations. Technologies such as EGR, exhaust gas recirculation, reduce nitrogen oxide formation by recirculating a portion of exhaust back into the intake. Some engines also employ secondary air injection to burn off extra hydrocarbons during cold starts. The OBD2 system, mandatory in many regions, continuously monitors these components for faults. When a problem is detected, the ECU stores diagnostic trouble codes, DTCs, and may illuminate the malfunction indicator lamp MIL. Technicians read these codes with scan tools, guiding them toward potential failures. An intimate knowledge of sensors, solenoids, and control logic is critical when diagnosing emissions-related issues, ensuring vehicles remain both compliant and efficient. Examining the electrical and electronic network basics of automotive electricity vehicles depend on a complex electrical grid to power ignition, lighting, infotainment, and more. The battery stores electricity produced by chemical reactions, providing energy to crank the engine on startup. Once running, the alternator recharges the battery and supplies power to electrical accessories. All circuits rely on conductors, insulation, and a stable ground. A break or short in any path can disrupt function. Because automotive voltage remains relatively low, 12 V nominal, it may seem harmless, but high-amperage circuits carry substantial risks. Understanding voltage, current, and resistance, along with the role of fuses, relays, and wiring harnesses, forms the foundation of diagnosing electrical gremlins, from dim headlights to intermittent sensor readings. The role of ECUs and control modules. Modern cars feature multiple electronic control units, ECUs, sometimes called modules. Each module focuses on a domain, engine management, transmission control, body electronics, and more. These modules communicate via digital networks like CAN bus, exchanging sensor data and command signals. For instance, the engine ECU might send torque requests to the transmission module while it adjusts shift points. Diagnosing module issues often requires a scan tool, software updates, and knowledge of communication protocols. Software malfunctions, wiring defects, or sensor failures can cascade across multiple modules, making a systematic, data-driven approach crucial. Starter, charging, and ignition systems. Cranking an engine requires a starter motor with enough power to overcome internal friction. The battery provides high current, mediated by a solenoid or relay. Once the engine fires, the alternator takes over, converting mechanical rotation into electricity. Meanwhile, ignition systems generate high-voltage sparks at spark plugs, triggered by signals from the engine ECU or older mechanical distributors. Each link is vital. A weak battery can't spin the starter, a failing alternator drains the battery over time, worn spark plugs hamper ignition performance. Routine testing of voltage outputs, cable integrity, and spark quality ensures consistent starts and smooth combustion. Advanced driver assistance electronics. Beyond basics, many vehicles now include advanced driver assistance systems, ADAS, such as adaptive cruise control, lane keeping assist, and automatic emergency braking. Sensors like radar modules, cameras, and ultrasonic detectors feed real-time data to specialized ECUs. These systems can warn a driver of hazards or even intervene to prevent collisions. While they enhance safety, they also raise complexity. A minor bumper repair might require sensor realignment or calibration. Technicians must stay updated on calibration procedures and system checks. The evolution towards semi-autonomous driving underscores the growing significance of electronics and software in automotive technology. Diagnostics tools and methods. Diagnosing modern electrical systems goes far beyond a simple test light. Digital multimeters measure voltage, resistance, and continuity. Oscilloscopes capture waveforms, revealing sensor signals in real time. Advanced scan tools read live data streams, configure modules, and clear codes. Wiring diagrams guide technicians through labyrinthine harness routes. In some cases, data logs are shared with manufacturer support lines for deeper analysis. The key is a systematic approach, understanding the symptom, retrieving diagnostic codes, cross-referencing circuit diagrams, then testing each suspect link. This methodical pattern, combined with an understanding of the system's design, solves issues faster and reduces guesswork. Steering, suspension, and handling. Dynamic steering systems overview. Steering systems connect the driver's inputs at the wheel to the front, and sometimes rear, tires. Rack and pinion remains common, converting rotational motion from the steering shaft into lateral movement that pivots the wheels. Power assist, once exclusively hydraulic, now can be electric, reducing engine-driven load and improving tunability. Regardless of type, tie rods, steering knuckles, and ball joints tie the assembly together. Wherein these components affects alignment and steering feel, leading to uneven tire wear or a drifting vehicle. By recognizing normal operation and early signs of play, technicians can restore precise control before more severe damage sets in. Suspension geometry and component. Suspension systems keep tires in contact with the road across varying surfaces, while also isolating occupants from bumps. Common setups include McPherson struts, double wishbones, and multi-link designs, each with unique geometric profiles. Springs, coil, leaf, or torsion bar, support the vehicle's weight, while shock absorbers or struts damp oscillations. Control arms and bushings define wheel alignment angles, camber, caster, and toe. Periodic checks of these bushings, ball joints, and pivot points maintain stable handling. Over time, worn shocks might cause excessive body roll or bouncy rides, while misaligned wheels degrade handling in tire life. Knowing how each component interacts clarifies why small suspension issues can create big drivability concerns. Wheel alignment principles. Proper alignment ensures that wheels sit at precise angles for optimized tire wear, handling, and fuel economy. Camber describes the inward or outward tilt of the wheel, caster refers to the steering axis tilt, influencing straight-line stability, toe measures the difference in front or rear of the tires. If any angle drifts out of spec due to potholes or worn parts, the vehicle may pull to one side or display uneven tire wear. Alignment machines measure these angles relative to the vehicle's centerline and a reference plane. Knowing how to adjust tie rods, control arms, or cam bolts is essential for achieving correct alignment. Each correction step must maintain the manufacturer's recommended specs for safe and predictable driving. Types of suspension systems. Passenger cars, trucks, and SUVs may use independent suspension at all four wheels, a solid axle in the rear, or air suspension in luxury vehicles. Independent setups, where each wheel moves vertically on its own, improve ride comfort and handling. Solid axle designs excel in load-bearing and off-road durability. Air suspensions alter ride height electronically, offering adaptive damping or leveling for better comfort and versatility. Diagnosing these systems often means examining not just mechanical linkages but also air compressors, ride height sensors, and control modules. Mastering these varied architectures helps technicians adapt to the ever-widening spectrum of vehicle designs. Performance tuning and aftermarket upgrades. Car enthusiasts frequently modify suspensions with stiffer springs, performance shocks, or lowering kits. These alterations aim to reduce body roll and sharpen handling, but they also change alignment, ride comfort, and stress on suspension mounts. Similarly, installing bigger wheels or different offset rims can affect steering geometry and brake clearance. A technician must ensure that any modifications remain within safe limits. Overly stiff springs can cause a harsh ride, while incorrect shock valving might reduce traction on bumpy roads. Understanding OEM baselines and the impact of each upgrade is crucial for giving customers the handling improvements they crave without compromising safety or component longevity. Braking systems and vehicle control core components of hydraulic brakes. Most vehicles rely on hydraulic brake systems where fluid transmits pedal force to calipers or wheel cylinders. Pressing the brake pedal pressurizes fluid within the master cylinder, pushing pistons in calipers to clamp brake pads against rotors, or expanding shoes in drum brakes. Proper fluid level, free of air or contamination, is essential for consistent brake feel. Where indicators on pads reveal when replacements are needed. Drilled or slotted rotors improve heat dissipation, though standard solid rotors function well for daily use. Monitoring brake lines, seals, and the master cylinder prevents leaks that compromise stopping power. Technicians look for signs of fluid darkening or spongy pedal feel, both of which suggest maintenance is due. Anti-lock braking systems, ABS. ABS prevents will lock up under hard braking, allowing the driver to maintain some steering control. Wheel speed sensors monitor each tire's rotation, and if one wheel decelerates too quickly, the ABS module momentarily reduces brake pressure. Pulsations at the pedal indicate ABS activation. This system relies on solenoid valves and a high-pressure pump to modulate fluid flow. Faulty wheel speed sensors or corroded tone rings can disable ABS, indicated by a dashboard warning light. From the technician's perspective, diagnosing ABS issues often involves scanning for stored error codes, verifying sensor signals, and ensuring mechanical components, like reluctor rings, are intact. A properly functioning ABS significantly reduces the chances of skidding, especially on slippery roads. Electronic stability control and traction systems. Building on ABS, electronic stability control, ESC, helps maintain directional stability by selectively braking wheels and reducing engine power. When a vehicle starts to spin or plow through corners, ESC attempts to correct the course. Similarly, traction control modulates power delivery if a wheel loses grip during acceleration. These safety systems rely on your rate sensors, steering angle sensors, and wheel speed data. Common issues include sensor misalignment or malfunctions in the hydraulic actuator. A robust diagnostic approach merges mechanical checks, e.g., sensor mounting, with electronic scanning tools. Mastering these systems can prevent accidents and elevate driver confidence, reflecting the importance of advanced brake-based safety features. Brake maintenance and upkeep. Brake fluid attracts moisture over time, reducing its boiling point. Regular fluid flushes help sustain performance under heavy braking. Caliper pins need lubrication to move freely, ensuring even pad wear. Inspecting brake hoses for cracks or bulges can stop dangerous failures. On drum brakes, adjusting the shoes or checking the self-adjust mechanism is crucial. Neglect can lead to uneven braking, pulling to one side, or decreased overall effectiveness. In commercial fleets or performance vehicles, brake inspections happen more frequently due to higher stress. Technicians who emphasize consistent maintenance and use quality parts build a reputation for safe, reliable repairs. Alternative systems, regenerative and air brakes. Electric and hybrid vehicles often incorporate regenerative braking, using electric motors to slow the vehicle while recharging the battery. Hydraulic friction brakes still exist but may see less wear since regeneration handles a portion of deceleration. However, complexities arise. The brake pedal feel must blend motor regen with hydraulic intervention seamlessly. In heavier commercial vehicles, air brake systems dominate. A compressor and air tanks provide pressure to actuate large drum or disc brakes, requiring different inspection protocols. Understanding these alternative setups widens a technician's service scope, from electric cars on city roads to heavy trucks on cross-country hauls. Heating, ventilation, and air conditioning, HVAC, fundamentals of vehicle climate control. Vehicle HVAC systems aim to keep cabin temperatures comfortable, demist windows, and maintain air quality. The heater core uses hot engine coolant to warm cabin air, while the air conditioning circuit removes heat using refrigerant, a compressor, condenser, and evaporator. Blower fans distribute conditioned air through a network of ducts. A malfunction at any stage, like a clogged cabin air filter, a leaking evaporator, or a failing blower motor resistor, can degrade comfort or visibility. Recognizing HVAC's multi-component nature helps in isolating issues quickly and methodically, ensuring occupant well-being in all seasons. Air conditioning refrigerants and compressors A/C systems rely on refrigerants circulating in a closed loop. In older cars, R12, Freon, was standard, but environmental concerns pushed a shift to R134A, and more recently to R1234YF in new models. This refrigerant is compressed, condensed, and expanded, absorbing cabin heat at the evaporator. The compressor, driven by the engine or an electric motor, pressurizes the refrigerant. If the compressor clutch fails, the system won't cool. Low refrigerant from leaks leads to warm cabin air and potential compressor damage from lack of lubrication. Skilled technicians check pressures, look for dye or oil residue at leak points, and confirm proper operation of condenser fans. Respecting manufacturer guidelines on refrigerant handling protects the environment and ensures safe, effective repairs. Heater cores, thermostats, and engine temperature management. The heater core, a small radiator inside the dashboard, provides interior warmth. Hot coolant flows from the engine, releasing heat through the core's fins into the ventilation air stream. A malfunctioning thermostat or restricted coolant flow impacts not just engine temperature but also cabin warmth. If the thermostat stays open too long, the engine might run cold, reducing efficiency in heater output. Conversely, a stuck-closed thermostat leads to overheating. When diagnosing poor heat output, a technician checks coolant level, blend doors, and the condition of hoses. Catching small leaks or corroded connections early can spare a driver from a frosty cabin or an overheating engine. Climate control and cabin air filtration. Automatic climate control systems rely on temperature sensors, solar sensors, and sophisticated module logic to maintain a set cabin temperature. The system modulates blower speed, mixed doors, and ASE operation automatically. Cabin air filters remove dust, pollen, and particulates from incoming air, protecting occupants and sensitive HVAC components. A clogged filter reduces airflow, overstressing the blower motor and diminishing cooling or heating capacity. Regularly changing these filters improves air quality and HVAC efficiency. Technicians often find neglected filters filled with leaves or debris, underscoring the necessity of routine checks. Servicing and diagnostic approaches. HVAC repairs require an organized approach. For ASE issues, technicians measure high and low side pressures, compare them to expected ranges, and investigate any discrepancies. Leak detection often involves electronic sniffers, UV dyes, or bubble solutions. Heater complaints might point to coolant flow restrictions or electronic blend door failures. Modern vehicles with dual-zone or tri-zone climate control compound the complexity. Each zone could malfunction independently. Safe refrigerant handling is mandatory, with proper recovery, evacuation, and recharging procedures. Diagnostics sometimes demand scanning the HVAC module for stored fault codes or reinitializing actuators. Comprehensive training ensures all these steps are performed accurately and safely. Body, chassis, and safety structures. Unibody and body-on-frame designs. Modern cars often employ unibody construction, where the vehicle body and chassis merge as a single structure. This design saves weight and heightens crash safety. In contrast, larger SUVs and trucks still use a traditional body-on-frame approach, mounting a separate body onto a robust ladder-like frame for towing and off-road durability. The repair implications differ. A unibody hit in a collision might require precise frame straightening on specialized equipment, while body-on-frame vehicles can sometimes separate the cab or bed for easier repairs. Knowing each architecture's strengths clarifies how best to repair structural damage or accommodate modifications like lift kits. Crash zones, crumple zones, and impact management. Manufacturers engineer vehicles with crush zones that absorb collision energy, protecting occupants by decelerating the impact over a controlled deformation path. The front and rear sections are typically more prone to crumple, while the passenger cell remains rigid. Reinforced pillars and crossmembers channel forces away from occupants. Though crucial for safety, these structures complicate repairs. If an accident compromises the load paths, a technician may need to restore them exactly to factory specs, often with laser measuring systems. Failing to do so can cause unpredictable behavior in subsequent impacts. Understanding the intricacies of these zones ensures that post-collision repairs preserve both structural integrity and occupant safety. Doors, windows, and cabin ergonomics. Vehicle body design must balance aesthetics, airflow, and occupant comfort. Doors incorporate safety beams, window regulators, and locks. Windows may use tempered glass for side panels and laminated glass for windshields, each chosen for specific safety properties. An ergonomic interior arrangement ensures drivers can reach controls while maintaining good visibility. Technicians performing body repairs or interior work must keep alignment consistent, ensuring doors close flush and seals remain airtight. Misalignments can cause wind noise, water leaks, or compromised side impact performance. As technology advances, like frameless doors or power tailgates, the complexity of aligning and calibrating these features grows. Paint, coatings, and corrosion protection. Beneath a car's shiny surface lies layers of primer, color coat, and clear coat, each contributing to corrosion resistance and aesthetics. Proper prep work, including cleaning and sanding, is essential before applying new layers. Many modern finishes incorporate water-based paints for environmental compliance, requiring precise temperature and humidity control during application. Rust forms where coatings fail or from trapped moisture. Undercoating and sealants protect vulnerable seams, yet salted roads or sea air can accelerate decay. Repairing corrosion demands removing the rust, treating exposed metal, and reapplying protective layers. Technicians who excel at paint matching and rust prevention help vehicles maintain their appearance and structural health. Active and passive safety equipment. Beyond structural design, vehicles integrate numerous safety features. Airbags deploy during severe impacts, inflating to cushion occupants. Seatbelt pretensioners reduce slack, holding passengers firmly in place. Active head restraints mitigate whiplash injuries. Collectively, these systems rely on sensors that gauge crash severity. Technicians must handle and store airbags carefully, as they contain explosive charges. After an accident, scanning for airbag or seatbelt fault codes is essential to restore full functionality. Replacing sensors or control modules might be necessary if they were triggered or damaged. Understanding the synergy between passive devices, seatbelts, airbags, and active aids, ESC, ABS, illuminates how modern cars protect drivers and passengers from a range of collision scenarios. Advanced driver assist and infotainment systems. The rise of connected vehicles. Many contemporary vehicles feature built-in connectivity, enabling real-time traffic data, streaming media, and remote diagnostics. Infotainment centers typically pair a touchscreen with integrated software, controlling everything from navigation to climate settings. Wireless hotspots, smartphone integration, via Apple CarPlay or Android Auto, and telematics systems like OnStar have become commonplace. These systems rely on data processing and robust wireless communication modules. A fault could appear as a dropped Bluetooth connection, a frozen screen, or unresponsive voice commands. With more data exchange comes the potential for security vulnerabilities, prompting the industry to focus on cyber safeguards. Recognizing these interconnected layers helps technicians address software and hardware issues that can arise from malfunctioning modules or buggy updates. Radar, cameras, and sensors. ADAS functionality depends on sensors that detect obstacles, lane markings, or other vehicles. Radar can measure distance and speed, while cameras track lane lines or read speed signs. Ultrasonic sensors help with park assists, measuring proximity to curbs or other cars. LiDAR, though less common, offers high-resolution mapping of a vehicle's surroundings. When diagnosing sensor faults, technicians verify wiring integrity, sensor cleanliness, like removing dirt from radar modules, and alignment angles for cameras. Calibration stands or target boards are often necessary after collisions, windscreen replacements, or even suspension work. Any misalignment can compromise system accuracy, leading to false warnings or inconsistent driver assist actions. Automated parking and lane-keeping assist vehicles now go beyond simple alarms when reversing. Automated parking systems measure the available space and steer the vehicle into a parallel or perpendicular slot. Lane-keeping assist lightly intervenes if the car drifts out of its lane without signaling, nudging the steering wheel or activating an alert. These conveniences rely on seamless interplay between sensors, steering control motors, and intelligent software. Malfunctions could come from steering angle sensors, ultrasonic detectors, or corrupted software parameters. Diagnosing them involves reading fault codes, recalibrating sensors, and verifying mechanical linkages. Understanding how each subsystem orchestrates real-time calculations underlines the complexity modern vehicles possess. Adaptive Cruise Control and Collision Avoidance. Adaptive Cruise Control automatically adjusts the vehicle's speed based on traffic flow, using radar or camera data. In heavier traffic, some systems even handle stop-and-go conditions. Collision avoidance further steps in when it senses an impending crash, applying brakes or providing steering assistance. While these systems enhance safety, they also amplify repair complexity. What used to be a simple bumper swap may now involve sensor bracket realignment. False triggers might cause abrupt braking for no valid reason, so pinpointing sensor or calibration faults remains critical. A professional approach involves scanning for diagnostic codes, verifying sensor aiming, and confirming that software is up to date. Balancing convenience with maintenance. While technology improves safety and comfort, it also demands meticulous upkeep. Regular software updates ensure new features or bug fixes, paralleling how a smartphone updates its operating system. If a camera lens is smudged or a radar sensor is coated with ice, system performance degrades. Infotainment screens can glitch due to memory overload or damaged cables. The synergy of mechanical, electrical, and software facets intensifies. Good technicians grasp the fundamentals of each domain, bridging the gap between mechanical repairs, like mounting a new bumper, and advanced digital calibrations, reprogramming sensors or modules. This well-rounded skill set is increasingly vital as vehicles edge closer to autonomous operation. Maintenance, diagnostics, and the future of automotive systems. Preventive care and service intervals. Automakers provide guidelines for oil changes, fluid replacements, belt inspections, spark plug intervals, and more. Staying consistent with these intervals prevents many common failures. Overlooked items, like an aging serpentine belt or a low transmission fluid level, can escalate into expensive breakdowns. Additionally, the type of driving, short commutes, towing, off-roading, influences how quickly components wear. By tailoring maintenance schedules to real-world usage, technicians give vehicles the best chance to thrive. Shops that champion preventive care build loyalty, as customers appreciate fewer emergency repairs and stable performance over time. The diagnostic process and system interactions. Vehicles produce an abundance of data. Dashboard warning lights, OBD2 trouble codes, and sensor readings all guide technicians toward potential issues. But these clues interconnect. A misfire code may stem from a vacuum leak in the intake, or a battery-related fault could degrade transmission shifting if the module senses unstable voltage. The challenge is sifting through these clues methodically, using logic and an understanding of each system's normal operation. Checking mechanical, electrical, and software factors in tandem prevents tunnel vision. A successful diagnosis often combines test drives, scanning tool data, physical inspections, and sometimes direct manufacturer input for specialized problems. Emerging technologies and electrification. As environmental standards tighten, more automakers pivot to hybrid and electric lineups. Fuel cells, once niche, might see wider adoption, converting hydrogen to electricity. Electric drive systems significantly reduce mechanical parts, no multi-gear transmissions or complicated exhaust systems, yet introduce large battery packs and high-voltage circuits that demand specialized handling. Solid-state batteries promise faster charging and greater energy density, potentially revolutionizing range. Autonomous driving research is pushing sensor suites and AI integration, challenging technicians to master calibration, sensor fusion, and advanced software logic. This trajectory underscores the need for continual training and adaptability as automotive design leaps forward. Sustainability and eco-friendly practices workshops increasingly prioritize environmental responsibility, recycling used oil, managing refrigerants, and disposing of batteries through approved channels. Eco-friendly fluids or synthetic oils can extend service intervals. Cleaner manufacturing also influences parts design, with more emphasis on recyclability and minimal harmful byproducts. From a consumer standpoint, vehicles featuring start-stop systems or advanced emission controls help reduce carbon footprints. For technicians, embracing these practices isn't just moral, it aligns with evolving regulations and consumer expectations. Educating customers about the long-term benefits of timely upkeep, including optimized fuel economy and reduced emissions, fosters a beneficial cycle for all parties. Cultivating a systems-oriented mindset. The ultimate takeaway from an automotive systems overview is the interdependence of each component. Focusing on just one subsystem might fix an immediate complaint but overlook a root cause in another domain. Whether diagnosing a random misfire or upgrading suspension parts, the best technicians approach the task holistically, understanding how changes ripple through the vehicle. Building a robust knowledge base, spanning powertrains, electronics, chassis, and more, fosters greater confidence and fewer guesswork repairs. As you move forward in your ASE journey, keep feeding your curiosity. Every engine, sensor, or gear you handle is part of a dynamic whole, and mastering that interplay is what truly sets an automotive professional apart. Through this broad look at automotive systems, you've glimpsed how each major domain, powertrain, fuel and emissions, electrical networks, steering and suspension, braking systems, HVAC, body structure, and more, coalesces into the modern vehicle. Continuing to refine your knowledge in each area sharpens your diagnostic accuracy and repair skills. As vehicles evolve into electrified, software-rich platforms, maintaining a panoramic understanding of system interplay will remain the hallmark of an accomplished technician. By always approaching repairs and maintenance with an eye on the wider system, you not only solve present problems but also preempt future ones, embodying the essence of true automotive service excellence. Lesson 7: Vehicle Identification and VIN Decoding. Automotive professionals rely on precise identification methods to ensure they are working on the correct make, model, and variant of a vehicle. Accuracy in identification is especially vital in a profession where a single digit or character in a VIN, vehicle identification number, can determine key service procedures or part compatibility. This lesson dives into the complexities of vehicle identification strategies, from foundational awareness of body tags and labels to the more advanced skill of decoding a VIN. By the end, you'll have a thorough grasp of how to properly identify vehicles, interpret manufacturer data, and ultimately streamline repair, service, and documentation tasks. 1. An introduction to vehicle identification. The role of accurate identification. Accurately identifying a vehicle is about more than just matching the make and model, it's central to correct repairs and service procedures. A small discrepancy in year or engine type can lead to ordering the wrong parts, causing delays and potential safety issues. Accurate identification reassures customers that you are meticulous in your work, while also protecting your shop from liability. Ultimately, the better you can confirm a vehicle's identity, the smoother your workflow becomes. Differences between similar models. In the automotive industry, manufacturers frequently release multiple trims or variants under the same model name. Even vehicles built in a single production year can have mid-cycle updates that change their mechanical or electronic systems. Simple external cues, like a badge, may not reflect deeper changes, such as engine displacement or an upgrade to a newer transmission. Familiarizing yourself with subtle differences avoids confusion when performing repairs or sourcing replacement parts. The importance of complying with regulations. Government agencies mandate certain documentation for vehicles, from registration certificates to emissions compliance data. Inaccurate identification can expose an owner to legal consequences and fines. For example, if a vehicle's emissions equipment doesn't match what is indicated on official paperwork, it could fail inspection. By understanding how regulators track vehicles via their identification numbers, technicians support both legal compliance and consumer trust. Historical context and evolution. Vehicle identification has come a long way from the early days of the automotive industry, where basic serial numbers were often the only markers. By the 1950s, manufacturers began standardizing numbering systems to curb theft and facilitate consistent record-keeping. The modern VIN system emerged in the 1980s, driven by the need for worldwide uniformity as automotive manufacturing and sales became increasingly global. Today, each digit in a VIN holds specific meaning, representing an international standard recognized across borders. Building a foundation for future lessons. As you progress in automotive studies, you'll encounter repair manuals, service bulletins, and recall notices that hinge on precise vehicle identification. Lessons about engines, transmissions, and advanced diagnostics all assume you know how to confirm you're looking at the correct model or trim. Familiarizing yourself with the basics of identification, including VIN decoding, sets a strong baseline for nearly every other topic in automotive service. 2. Locating identification labels and tags. Common locations of ID plates. Automakers typically install ID plates and labels in standardized but varied locations. The driver's door jamb is a common place to find a placard indicating gross vehicle weight ratings, tire pressure recommendations, and sometimes build dates. The engine bay can also house a metal plate on the firewall displaying model codes, paint codes, or chassis numbers. Knowing precisely where to look speeds up initial checks and avoids dismantling unnecessary parts. Differences between body tags and emissions labels. Body tags often contain essential build data, such as engine code or transmission type, while emissions labels identify the emission standards the vehicle meets, e.g., California versus federal regulations. Emissions labels might be found under the hood or inside the engine compartment. Distinguishing between these tags is crucial because each one answers different questions. If you need to confirm an emissions component part number, the underhood sticker is your first stop. Digital identification methods. Some newer vehicles embed digital identification in electronic control units. This data can be accessed via diagnostic tools that read specific module information, including VIN confirmation. While convenient, reliance on digital methods can pose challenges if an ECU has been damaged or replaced without proper updating. In such cases, you'll still need to revert to physical plates and official paperwork to ensure accuracy. When labels are missing or damaged, vehicles involved in collisions or subject to rust and poor maintenance may have illegible or missing tags. Restoring identification might require a deeper dive, retrieving the VIN from etched glass, scanning barcodes on ancillary parts, or consulting the vehicle's title or registration. If no official documentation is available, more complex investigative steps are needed, such as referencing older insurance claims or contacting the manufacturer. Maintaining diligence in these scenarios upholds legal and ethical service standards. Implications for part selection. Even minor confusion in reading a label can lead to large mistakes in part ordering. For instance, a single-digit error in the engine code might bring in a fuel pump incompatible with the actual engine. Learning how to methodically compare found data with ordering systems or manufacturer references is a habit that prevents wasted time, cost, and potential damage to the vehicle if the wrong component is forced into place. 3. Understanding the basics of VIN structure. History of VIN standardization. Before the modern VIN format existed, manufacturers each had their own numbering systems that could easily confuse owners and law enforcement agencies. In 1981, the NHTSA, National Highway Traffic Safety Administration, in the United States mandated a 17-character standardized format, enabling consistency across all makes and models sold. This global shift simplified tracking, theft prevention, and recall procedures. The 17-character format. The VIN is a 17-character alphanumeric code, with each position conveying specific information. Characters can include digits, 0 to 9, and letters, Z, excluding I, O, and Q to avoid confusion with 1 and 0. This string is divided into the World Manufacturer Identifier, WMI, the Vehicle Descriptor section, VDS, and the Vehicle Identifier section, VIS. Knowing these divisions helps a technician decode or validate any given VIN systematically. Avoiding common reading mistakes because I, O, and Q are not used, a 0 might be mistaken for an O by someone unfamiliar with the rules. Similarly, the letter Z can be confused with the number 2 in certain fonts or low lighting. Being aware of these pitfalls is critical. One transcription error can cause hours of wasted effort or receiving the incorrect part. When in doubt, double-check the character shape or refer to official references that clarify valid VIN characters. The check digit within the 17 characters lies a specific check digit at the 9th position. This digit is calculated using a weight factor algorithm, ensuring the rest of the VIN's numeric consistency. If someone tampers with a VIN or incorrectly restamps it, the check digit will no longer match the mathematical formula, indicating fraudulent or erroneous activity. Technicians can use this concept to confirm if a VIN might be suspicious, though verifying the check digit manually is not always routine in daily shop work. Global relevance of VIN. Though the VIN structure was pioneered for the U.S. market, it's now recognized worldwide. European, Asian, and other global brands follow the same 17-character template, making cross-border data systems and part lookups more seamless. Because of this, a technician can confidently decode a Japanese or German VIN, for instance, without major differences in the underlying structure, an essential advantage in our globalized automotive era. 4. Decoding the World Manufacturer Identifier, WMI, positions 1 to 3 in the VIN. The first 3 characters of the VIN are known as the World Manufacturer Identifier. Position 1 indicates the country or region of origin. Position 2 often represents the manufacturer or a specific division of that manufacturer, and position 3 can indicate vehicle type or production division. Together, they uniquely identify the vehicle's maker. For example, 1 often signifies the United States, while J might denote Japan, and 3 can denote Mexico. These details matter because they affect regulations and part sourcing. Variation among global brands. Some brands produce vehicles in multiple countries, which can change the first digit of the VIN even for the same make and model. A Honda built in the U.S. might start with 1, while one built in Canada might have 2. For a global brand like Ford, the second character can shift, reflecting different sub-branches or divisions. Understanding these nuances saves confusion when you realize the same nameplate can have multiple WMIs due to global manufacturing strategies. When the WMI is the key to parts, occasionally, parts availability may hinge on knowing exactly which plant or country assembled a vehicle. For instance, a certain engine variant may only be used in vehicles built in one factory. If you spot a mismatch, such as an engine code not aligning with the WMI data, you can identify that someone might have transplanted an engine from a different region. Detecting these transplants early prevents futile attempts to order standard parts that simply won't fit. Impact of manufacturer mergers. The automotive industry experiences frequent mergers, acquisitions, or joint ventures. Think of alliances like Stellantis, combining FCA and PSA, or partnerships between Toyota and Subaru. These can alter or add new WMIs. If a brand transitions to a new corporate structure, newly manufactured vehicles may carry updated WMI codes. Keeping an eye on these developments ensures you stay current, especially when older brand codes are phased out and replaced with new designations. Using external databases, multiple websites, and official manufacturer portals let you enter the first 3 VIN characters to confirm the manufacturer's identity. Technicians can combine this with internal shop software that cross-references WMI data for faster part lookups. While public databases are typically reliable, always supplement with official manufacturer or dealership references when in doubt. Confirming WMI accuracy early paves the way for more detailed decoding of the rest of the VIN. 5. Unlocking the Vehicle Descriptor section, VDS, positions 4 to 8 in the VIN after the WMI, characters 4 through 8 represent the Vehicle Descriptor section. This block covers the vehicle's general platform, model, body style, engine type, and other critical features. Each manufacturer encodes these details differently, but standard frameworks exist to ensure a level of uniformity. For instance, one digit may reflect the engine's displacement or fuel type, while another may denote the body style, coupe, sedan, SUV, etc. Body style and restraint systems. One of the major data points in the VDS is the body style. This detail can differentiate a two-door coupe from a four-door sedan, even under the same model name. Additionally, occupant restraint systems, like the presence of driver/passenger airbags or advanced seatbelt features, can be encoded. Such knowledge is pivotal when diagnosing airbag light issues or ordering the correct interior trim. Engine variants and transmission. Many OEMs embed engine codes into the VDS, distinguishing among various displacements or configurations. For example, a manufacturer might label a 2.4-liter inline for engine as B, while a 3.0-liter V6 is C. Transmission data may also appear here, telling you if it's manual, automatic, or continuously variable. This level of detail is indispensable for major mechanical tasks, from rebuilding an engine to selecting the correct powertrain control module. Impact on diagnostic routines. A malfunctioning sensor or a difference in wiring harness pinouts can often be traced to a mismatch in the VDS codes. When diagnosing a check engine light, verifying the correct powertrain configuration helps you pick the right diagnostic procedure. Service manuals often list repair steps by engine code or body style, meaning that if the VDS is read incorrectly, you could waste time. By confirming VDS data, you ensure the instructions you're following truly match the vehicle on the lift. Regional differences. Although the VIN is standardized worldwide, certain digits within the VDS can reflect market-specific or emission-related variations. A car sold in the U.S. might have additional codes indicating compliance with federal or California emission rules. In contrast, an export model might encode specialized features like higher altitude tuning or left-hand versus right-hand drive. Learning these patterns expands a technician's ability to work on imported vehicles or those manufactured for diverse locales. 6. The Vehicle Identifier section, VIS, and Production Details. Positions 9 to 17 explain the final block, often referred to as the Vehicle Identifier section, zeros in on production sequence and other unique identifiers. Position 9 is the check digit mentioned earlier. Positions 10 and 11 typically denote model year and assembly plant location, respectively. The last 6 digits, positions 12 to 17, serve as a serial number, differentiating each vehicle that rolls off the line. Decoding the model year. Position 10 can be a letter or number. For example, A might represent a certain year, B the following year, and so forth. Because the sequence cycles, each code must be interpreted in context. For vehicles older than 30 years, the repeating pattern might cause confusion, making cross-referencing additional data crucial. Knowing this character helps you confirm you're indeed working on, say, a 2012 model rather than a 2002 or 1992. Assembly plant information. Position 11 indicates which factory or assembly line produced the vehicle. Larger manufacturers operate multiple plants worldwide, each with specialized tooling for different models. This digit is vital if a certain plant uses distinct specifications. For instance, a truck built at Plant X might have heavier-duty axle components than the same truck model assembled at Plant Y. Checking this code can clarify unusual build variations. Production serial number. The last 6 digits form the unique production sequence for that plant and model run. If a manufacturer made 50,000 units in a particular cycle, each vehicle would have a distinct combination of those last digits. Technicians sometimes reference these numbers to determine if a car falls into a recall range. For instance, A recall notice might specify that vehicles with serial numbers 100001 to 120,500 have a particular defect. This detailed range matching ensures accurate recall servicing. Relevance in service bulletins and recalls. OEM service bulletins frequently mention the VIS range of affected vehicles. If you see that a certain VIN's last 6 digits are within that range, you instantly know the car may exhibit a known issue, be it a faulty brake booster or a glitchy infotainment module. This saves diagnostic time by pointing you toward a documented problem. Quick identification of these details is a hallmark of an efficient, well-prepared automotive professional. 7. Special cases and exceptions. Classic and pre-1981 vehicles. Pre-1981 vehicles might not adhere to the 17-digit VIN structure. They may have serial numbers with fewer digits or use a distinctive format set by the manufacturer. Restoration and maintenance of these classics require referencing factory catalogs, club archives, and historical documents. Decoding these older IDs often involves rummaging through specialized forums or collector guides. Despite the challenge, authenticity matters greatly in the classic car market, where the right chassis number can significantly influence a vehicle's value. Trailers and motorcycles. Other forms of transport, such as trailers and motorcycles, also employ VINs but may have slightly varied standards. A motorcycle's VIN might be placed on the steering neck or near the engine case. Trailers often have an identification sticker on the frame or tongue. Though the 17-digit rule typically still applies, certain subcategories might not strictly follow passenger vehicle conventions. Aware technicians can adapt their knowledge to these smaller but still essential segments of the market. Rebuilt or salvage titles. If a vehicle has been declared a total loss and subsequently repaired, the VIN remains the same, but the title status changes to salvage or rebuilt. Some jurisdictions require additional tags or markings to indicate its history. This can impact insurance, resale value, and the types of repairs allowable. Service shops must pay close attention to these details when ordering structural components or verifying that the correct rebuild procedures have been followed for safety. Gray imports and non-conforming vehicles. Gray imports are vehicles not officially sold by the manufacturer in a specific country, yet privately imported. Their VIN might not match local decoders or may indicate specs different from domestic versions. Some non-conforming cars might need to be retrofitted with local compliant lighting or emissions equipment. Technicians must navigate these anomalies, often seeking specialized info from import brokers or global OEM databases. Failure to interpret them accurately can lead to legal complications or part incompatibilities. Tampered or fraudulent VIN tampering is a serious issue. Criminals may alter VIN plates to disguise stolen vehicles or salvage builds. Signs of tampering include mismatched rivets, uneven stamping, or the absence of the factory's special markings. Technicians who notice these red flags must handle the situation carefully, reporting potential fraud to authorities or refusing service until the matter is resolved. Protecting yourself and your shop from liability involves consistent diligence when reading VIN plates, especially if other details, like the check digit, don't align. 8. Practical steps in VIN decoding. Gathering all relevant information before diving into a decode. Collect the vehicle's registration or title, plus any labeling accessible under the hood or on the door jamb. Cross-referencing official documents with the physical VIN ensures consistency. If you spot discrepancies, like a mismatched digit, confirm which source might have errors. Sometimes, a simple typographical mistake occurs on paperwork. Using manufacturer resources. Many automakers provide online VIN decoders that yield basic build information once you input the 17 characters. Dealerships also maintain internal systems with more in-depth data, including installed options or trim codes. If you have access to these portals, you can see everything from the original color to additional packages that might affect part selection. Employing aftermarket databases. Third-party platforms compile data from various manufacturers, often allowing quick VIN lookups for common vehicles. While these tools are convenient, they may not capture every nuance, especially for rare variants or newly released models. A good practice is to verify with official sources when dealing with borderline or critical issues. Cross-referencing multiple databases builds confidence in the information gleaned. Interpreting output information. A typical decode yields details like manufacturer, year, engine type, body style, trim level, safety features, and assembly plant. Look for disclaimers indicating incomplete or approximate data. Compare this output with your physical inspection. For example, does the engine bay match the described engine displacement? If not, the vehicle might have undergone an engine swap, or the decoder might have partial data. Documenting your findings. Once a VIN is decoded, keep a record in the vehicle's file or in your shop management software. Jot down the engine code, transmission type, or any unusual specs that stand out. This reference becomes invaluable if the vehicle returns for future service, saving time by not repeating the identification process. A thorough record promotes consistent, efficient care across the automotive service team. Integration into everyday workshop routine. Streamlining parts procurement. Part suppliers often ask for the VIN when you place an order, especially for complex assemblies. Providing the VIN ensures that the supplier's system filters out incorrect items. This synergy speeds up the delivery process and minimizes returns. Hence, making VIN checks part of your standard operating procedure, right alongside a multi-point inspection, demonstrates a professional, organized approach that customers value. Enhancing diagnostic accuracy. When you connect a scan tool to read trouble codes, some diagnostic equipment auto-detects the VIN from the vehicle's control module. This ensures the system selects the right code definitions and diagnostic routines. By confirming the detected VIN matches the physical one, you eliminate confusion if a module was replaced or if the vehicle has software from a different model. This alignment secures diagnostic integrity. Communication with vehicle owners. Customers may not be aware of the nuances behind VIN decoding. Educating them briefly, like explaining why you need the last 8 digits for a specific part, builds transparency and trust. They see that you're meticulous. This small effort also sets realistic expectations for timelines if a part is special order or if the vehicle is a rare model. Gaining a reputation for thoroughness fosters customer loyalty. Collision repair and insurance. After an accident, insurers frequently require thorough documentation of the VIN and any related assembly details. If the vehicle is declared totaled but later rebuilt, the VIN remains a point of reference for any subsequent claims or liability issues. Shops specializing in collision repair often keep detailed digital and photographic records tied to each VIN, ensuring the job's scope and parts usage are always traceable. Resale and trade-in evaluations. A pre-owned vehicle's VIN data helps determine its value. By decoding the VIN, buyers and sellers confirm if the listed features and condition match the original build. Major discrepancies, such as an upgraded engine that's not official, might reduce the resale price or signal undisclosed modifications. Technicians performing a pre-purchase inspection rely heavily on the VIN decode to give accurate assessments, boosting their credibility in the eyes of clients. Preparing for the future of vehicle identification. Digital tagging and blockchain. As technology evolves, manufacturers are exploring digital forms of vehicle identification. Some propose blockchain-based records to prevent tampering or create an immutable service history for each VIN. If widely adopted, technicians might soon interact with online ledgers that log maintenance or accidents. This shift could enhance transparency but also requires learning new tools. Adapting to these emerging concepts ensures you stay ahead in an industry defined by continual innovation. Cybersecurity in connected cars. VIN data might eventually link to advanced telematics or over-the-air (OTA) update systems, where a car's software configuration is tracked in real time. With each new software patch, the vehicle's identity and update status might be automatically recorded. While this offers convenience, it also raises privacy and security concerns. Technicians in the future must balance streamlined data access with rigorous cybersecurity protocols to protect both customers and the broader ecosystem of connected vehicles. Autonomous vehicles and unique identifiers. Self-driving cars rely on an even more complex network of sensors and software. Some speculate that beyond the VIN, additional identifying signatures, like sensor calibrations, may be needed for service tasks. In an autonomous world, verifying the correct sensor suite or LiDAR specification becomes akin to checking an engine code. Understanding how these extended identifiers interplay with the VIN broadens a technician's capacity to service cutting-edge models. Environmental regulations and tracking. Stricter environmental regulations may require more robust vehicle monitoring. Future legislation could mandate that certain high-emission parts or systems be recorded by VIN at the point of repair. Technicians might need to submit updates to a central registry, ensuring compliance. This scenario underscores how VIN data might become an even bigger part of day-to-day shop operations, shaping everything from parts ordering to legal reporting. Sustaining a culture of continuous learning. Vehicle identification may appear static at first glance, just digits on a plate. Yet it evolves with new technologies, regulatory changes, and global industry shifts. Cultivating a mindset of ongoing education helps you adapt. Reading the latest manufacturer bulletins, attending workshops, and engaging with automotive forums keep you sharp. By embracing a forward-thinking attitude, you retain confidence in your VIN decoding prowess, no matter how the automotive landscape transforms. Through this lesson, you've uncovered the intricacies of vehicle identification, from spotting physical labels to systematically decoding each character of a VIN. Understanding how automakers encode manufacturing data, model year details, and assembly specifics empowers you to perform more accurate repairs and streamline part sourcing. These identification skills also enrich customer trust, ensuring you handle each vehicle with precision and adherence to official specifications. As vehicles incorporate more sophisticated electronics and global manufacturing footprints, the demand for thorough identification and decoding expertise will only grow. By mastering these fundamentals now, you're well-positioned to navigate an evolving automotive world, where the VIN remains the guardian of essential data underpinning every mechanical and diagnostic endeavor. Lesson 8: Automotive Fluids, Oils, and Lubricants. Automotive fluids are the lifeblood of any vehicle. From engine oil that keeps moving components slick and friction-free, to coolant that stabilizes temperatures in scorching conditions, these substances do more than just fill reservoirs. They manage heat, transfer force, lubricate gear sets, and ensure that brake pads engage with dependable bite. Each fluid must be selected with care, matching the unique demands of various vehicle systems. A single oversight, such as using the wrong transmission fluid, can lead to shifting problems or even mechanical failure. In this lesson, we will dive deep into the broad universe of automotive fluids and lubricants, helping you build a robust understanding of their properties, roles, and best practices for handling and maintenance. Understanding fluid classifications. The nature of viscosity. Viscosity measures a fluid's resistance to flow. In an automotive context, an oil with higher viscosity clings more thoroughly to engine components but can also be sluggish in cold weather. Conversely, a lower viscosity might flow easily in cold starts yet risk thinning out under high temperatures. Hence, you often see multi-grade oils like 5W30, indicating different flow characteristics when the engine is cold versus running hot. Viscosity is not just a number, it is the balancing act that ensures metals stay lubricated across varying engine conditions. When selecting fluids, it is crucial to interpret these viscosity grades correctly. A 10W40 oil, for instance, thickens less in cold environments compared to a single-grade 40 oil. This nuance matters. A vehicle that experiences sub-zero winters benefits from a multi-grade oil that can quickly reach engine components at startup. By contrast, a performance car in a hot climate might choose an oil grade that maintains thickness under punishing conditions. Understanding viscosity allows you to anticipate how a fluid behaves under different stressors, informing decisions about the best product for any specific scenario. The role of additives. Modern lubricants seldom rely on base oil alone, they gain performance from additives. These chemicals may include detergents that clean deposits, dispersants that suspend contaminants, anti-wear agents like zinc dialkyl dithiosphate, ZDDP, and friction modifiers that reduce sliding resistance. Such additives allow oils to handle the extremes of combustion, high-pressure metal contact, and rapid temperature changes inside an engine. Beyond engine oil, additives appear in power steering fluid, transmission fluid, and even brake fluid. In transmissions, friction modifiers ensure clutches and bands engage smoothly, preventing shudder. In engine oils, antioxidants slow down the chemical breakdown caused by high heat. By recognizing which additives serve which purpose, you gain insight into why certain fluids claim benefits like extended drain intervals or higher temperature stability. Understanding these formulations guides you towards selecting a fluid that aligns with a vehicle's driving conditions. Fluid compatibility. Not all fluids are interchangeable. Using an engine oil labeled for diesel applications in a small gasoline engine might introduce additives that the smaller system does not need, sometimes causing deposits or catalytic converter harm. Likewise, filling a manual gearbox with an automatic transmission fluid can lead to gear wear if the fluid lacks adequate EP, extreme pressure, additives. The same caution applies to coolants. Mixing an OAT, organic additive technology, coolant with a conventional green coolant can result in sludge. Compatibility becomes especially pressing in transmissions, where a manufacturer might demand a proprietary fluid to match frictional characteristics. While it can be tempting to grab a one-size-fits-all product, modern vehicles increasingly rely on precisely tuned fluids. Sticking to OEM recommendations or high-quality equivalents ensures you do not compromise system health. Proper research and referencing technical literature or reputable fluid charts are key to avoiding cross-contamination or damage. Environmental and regulatory factors. Government regulations, such as those set by the Environmental Protection Agency, push fluid manufacturers to reduce harmful emissions or pollutants. This push influences not only the composition of lubricants, leading to lower sulfur or phosphorus levels, but also the disposal process once fluids are spent. Certain industrial oils and coolants might classify as hazardous waste, demanding specialized handling. In terms of automotive design, regulations often shape fluid chemistry. Emission-compliant motor oils reduce catalytic converter poisoning, while advanced coolants limit environmental harm if a radiator leak occurs. Technicians must stay current on these evolving standards, especially if they service a wide range of vehicle types or live in areas with stricter environmental laws. Being aware of eco-friendly fluid options, like synthetic base stocks with extended drain intervals, can align with both ethical and regulatory considerations. Safety in handling fluids. Automotive fluids can be flammable, toxic, or irritating to skin and eyes. From the intense odor of gear oil to the chemical sting of brake cleaner, each product poses distinct risks if handled recklessly. Wearing gloves, eye protection, and ensuring adequate ventilation is not just a suggestion, it is a fundamental safety measure. In some shops, local regulations require that certain chemicals be stored in fire-resistant cabinets or used only in well-ventilated areas. Technicians also need to be conscious of fluid disposal. Dumping used oil or coolant down the drain is environmentally damaging and often illegal. Many regions have collection centers or recycling programs that handle waste fluid. By staying mindful of safe handling procedures, you protect both personal health and the broader community. Customers also appreciate a shop that demonstrates responsible stewardship of hazardous substances. Engine oils and lubrication principles. Function of engine oil. Engine oil is the champion of friction reduction. It forms a thin film between pistons, rings, and cylinder walls, preventing direct metal-to-metal contact. Meanwhile, it picks up heat and transports it to areas where it can dissipate. Oil also collects combustion byproducts, such as soot or acid, suspending them so filters can remove debris. Without this lubrication, engines would seize under friction's intense heat, drastically shortening component lifespans. Quality engine oil further cushions shock loads in bearings, especially under heavy acceleration or load changes. This damping effect ensures that rods, crankshafts, and camshafts operate smoothly, even when an engine transitions from idle to maximum RPM. Consequently, consistent lubrication cuts mechanical noise, reduces wear, and stabilizes performance. Technicians who understand these nuances can quickly identify if an engine's oil is delivering the protective qualities it should, or if there's cause for an upgrade or more frequent oil changes. Conventional versus synthetic oils. Conventional oils originate from refined crude petroleum, typically fortified with additives. They handle everyday driving but may degrade faster under extreme conditions. Synthetic oils, by contrast, are chemically engineered, offering more uniform molecular structures that yield superior temperature stability, less sludge formation, and extended intervals between changes. Synthetic blends marry aspects of both worlds, balancing cost against performance improvements. Choosing between conventional and synthetic hinges on various factors: manufacturer recommendations, driving style, climate, and budget. A performance-oriented turbocharged engine might thrive with synthetics' advanced film strength, while a lightly driven commuter car could find conventional oil adequate. Some modern vehicles mandate synthetics to support advanced technologies like variable valve timing, where oil cleanliness and pressure are paramount. Understanding how each category is produced and performs empowers you to give nuanced advice to customers or fellow technicians. Oil grade selections. Vehicle handbooks specify the ideal oil grade, such as 5W, 30 or 0W, 20, reflecting how the fluid performs cold, the W rating, and at operating temperature, the second number. A low winter rating fosters quick lubrication at startup, mitigating the moment of highest wear. The second number reveals thickness under hot conditions. A 50 grade oil can endure high heat without thinning excessively, suitable for heavy loads or high temperatures. Selecting the correct grade is critical for maintaining the right oil pressure, especially in engines with tight clearances or complex valve trains. Many newer engines operate on very thin oils for improved fuel economy, as thicker oils create more drag. Going thicker than recommended could hamper hydraulic lifters or cause stiffer cold starts. On the other hand, choosing too thin an oil in high heat environments might compromise the protection film. Aligning with the OEM or a reputable cross-reference guide remains the safest route. Extended drain intervals. Decades ago, 3,000-mile oil changes were the norm. Modern synthetics, improved engine designs, and sophisticated filtration now allow intervals of 7,500 to 10,000 miles or more in certain vehicles. Some manufacturers even equip cars with onboard oil life monitors that track operating conditions, adjusting recommended service intervals in real time. However, extended drain schedules only function well if the correct oil grade, additive package, and filter quality meet the demands. Frequent short trips, dusty environments, towing, or track use can degrade oil more quickly. Technicians must weigh driving patterns when deciding if an extended interval is safe. Overextending too far leads to increased contaminants, acid buildup, and potential sludge formation. Though longer intervals save customers time and money, those benefits vanish if the engine suffers from insufficient lubrication. Evaluating usage conditions is key to preventing unintentional neglect. Oil analysis and diagnostics. Oil analysis, a laboratory-based process, samples used oil and checks for wear metals, fuel dilution, water contamination, and additive depletion. This technique reveals hidden engine stressors before catastrophic failure. Elevated iron might point to valve train or cylinder wear, heightened silicon could signal unfiltered air infiltration. If results repeatedly indicate high contamination, it might prompt a deeper mechanical inspection or changes to service intervals. Regular analysis is especially beneficial for commercial fleets or high-performance vehicles, where proactive maintenance can avert downtime. By spotting patterns, like climbing bearing metals, a manager or owner can schedule repairs during off-peak periods instead of experiencing roadside breakdowns. For technicians, analyzing oil data merges chemistry with mechanical insight, bridging the gap between lab results and real-world engine health. Coolants and the thermal regulation system. The significance of engine coolants. Engine coolant transfers heat from the cylinders to the radiator, preventing overheating. Coolant typically consists of water mixed with antifreeze, ethylene glycol or propylene glycol, plus corrosion inhibitors and other additives. The correct ratio of coolant to water is essential for freezing point depression and boiling point elevation. Without this mixture, engines risk freezing in cold climates or overheating in scorching conditions. A well-maintained coolant also guards against rust and scale deposits that clog passages. Over time, however, the anti-corrosion chemicals degrade. When that happens, internal surfaces can corrode, leading to leaks in the radiator, heater core, or cylinder head gaskets. Frequent checks and timely replacements ensure stable operation, especially under heavy load or harsh weather. Types of coolant formulations. Different coolant formulations abound. Inorganic additive technology, IAT, typically shows a bright green color, common in older vehicles. Organic acid technology, OAT, often orange or pink, features extended life properties. Hybrid organic acid technology, HOAT, merges aspects of both, found in certain European and Asian models, frequently dyed yellow, purple, or blue. Each formula uses unique corrosion inhibitors tailored to different metals and system designs. Mixing incompatible coolants can trigger gel-like residues or reduced corrosion protection. That is why many bottles warn, "Do not mix with other coolants." If a system has the wrong coolant, it might require a full flush to prevent damage. When uncertain, verifying the owner's manual or specialized guidelines is crucial. Technicians who keep color-coded references or database notes reduce the risk of inadvertently creating cooling system sludge. Radiator, water pump, and thermostat rolls. A radiator dissipates heat by passing the hot coolant through thin tubes, with airflow removing heat as the car moves or fans operate. The water pump circulates coolant, drawing cooler fluid from the radiator into the engine. The thermostat regulates flow based on temperature, staying shut until coolant warms, then opening to maintain an optimal operating range. If the thermostat malfunctions, like staying open too soon, fuel efficiency plummets. If it sticks closed, temperatures can spike dangerously. Maintaining these components ensures the entire cooling loop performs seamlessly. A leaking water pump or corroded radiator robs the system of its capacity. Overheating not only warps heads and blocks but can degrade oil quality, compounding mechanical wear. By understanding each piece's function, you can trace diagnostic steps logically when facing temperature anomalies or coolant leaks. Pressure caps and overflow tanks. Cooling systems operate under pressure, raising the boiling point of the fluid. The radiator or coolant reservoir cap contains a spring-loaded valve that allows pressure to escape once it exceeds a certain threshold. This prevents hoses or radiators from bursting under high heat. An overflow tank collects the excess coolant, which can be drawn back into the system once it cools and pressure drops. A faulty cap can leak pressure prematurely or fail to release it, causing boiling or vacuum issues. Technicians who examine the cap seals and springs as part of routine checks can catch subtle problems before they lead to bigger repairs. Also, verifying the overflow line's integrity ensures coolant can flow back properly during cooldown, maintaining a stable fluid level. Coolant flushes and maintenance. As coolant ages, corrosion inhibitors wear out, and contaminants accumulate. Over time, that leads to rust inside the block or radiator, forming scale that compromises cooling efficiency. A thorough flush replaces the old mix with fresh fluid, restoring anti-corrosion benefits. While top-ups are normal, periodic complete flushes, as recommended by OEM intervals, prevent chronic buildup. During a flush, it is prudent to inspect hoses for bulging or cracking. Renewing a thermostat, if it shows signs of sticking, can be a proactive measure. For heavy-duty or off-road vehicles, frequent flushes might be vital due to harsher operating conditions. By methodically checking system components during coolant service, you maintain robust engine health and avoid sporadic overheating complaints. Transmission fluids and gear lubricants. Automatic transmission fluid, ATF, variations. Modern automatic transmissions rely heavily on fluid not just for lubrication, but also for hydraulic control of clutches and bands. ATF must exhibit precise friction characteristics, ensuring shifts feel smooth instead of harsh or slippy. That is why manufacturers specify unique ATF types, such as Dexron, Mercon, or specialized formulas like Toyota WS or Honda DW1. Throwing in the wrong fluid can break the delicate friction balance, leading to erratic shifts or transmission damage. Some systems incorporate lockup torque converters or advanced shift algorithms that absolutely require the fluid's viscosity and friction to be on point. Technicians who keep an ATF reference chart on hand minimize errors and costly comebacks due to shift quality complaints. Manual gearbox and differential fluids. Manual transmissions often use gear oils with designations like API GL4 or GL5. These feature compounds that manage high-pressure contact between gears and bearings. Differential fluids can be even thicker, like 75W, 90 or 80W, 140, equipped with extreme pressure additives to handle ring and pinion loads. If you fit a lower spec oil in a differential, the metal might scuff under load, generating heat and wear. Limited slip differentials may call for additional friction modifiers to allow clutch plates or cones to operate correctly. Without that additive, the diff might chatter in tight turns. Sometimes, a gear fluid brand includes a friction modifier already blended in, while other times, you must add it separately. Confirming the recommended specifications for each drivetrain component remains crucial for longevity and performance. Fluid degradation over time. Although transmission fluids are often labeled as lifetime or extended life, they do degrade, especially under high heat or heavy towing. Oxidation leads to fluid darkening and a burnt smell. Depleted additives cannot protect metal surfaces or preserve smooth shifts. Overly contaminated fluid may carry clutch material or metal shavings, accelerating internal damage. Even manual transmissions produce wear particles that remain suspended in gear oil, harming synchronizers. Draining old fluid is an opportunity to visually inspect for metal flakes or lumps that point to imminent mechanical trouble. Sticking to recommended service intervals, sometimes as low as 30,000 miles for severe usage, avoids diminishing lubrication. Observing fluid color, odor, and consistency is a straightforward barometer of system health. Transmission flush versus drain and fill. A simple drain and fill typically replaces a fraction of old fluid, given that much remains in the torque converter or lines. Conversely, a flush uses specialized equipment to cycle new fluid until the old fluid is almost entirely purged. However, flushes can dislodge deposits that might clog channels if not done carefully. Some vehicle owners or technicians worry that an aggressive flush may jostle worn clutches in older transmissions, triggering issues. Each approach has merits. Drain and fill is less invasive but often incomplete. A flush is thorough but demands the correct machine setup and a healthy transmission to start with. Shops often weigh the vehicle's mileage, service history, and fluid condition before deciding. If done properly on a well-maintained gearbox, a flush can restore shift crispness and remove most contaminants. Identifying transmission fluid leaks. ATF often appears reddish or pinkish, though certain synthetic varieties might be nearly clear. A leak might form around the transmission pan gasket, cooler lines, or the input-output shaft seals. Spotting a drop in fluid level can be tricky on sealed transmissions without dipsticks. Low fluid often manifests as delayed shifting, slipping under load, or harsh engagements. Technicians must check fluid from fill plugs or specialized ports, using factory procedures to get accurate readings. Addressing even a minor leak promptly prevents a downward spiral. If the fluid level dips repeatedly, the transmission runs hotter, degrading fluid further and risking expensive overhauls. Gasket or seal replacement, plus verifying that vent tubes are clear, can eliminate leak points. Regularly scanning the underside for residue or drips during oil changes is a simple preventative measure that keeps drivetrains trouble-free. Brake fluid and hydraulic systems. Characteristics of brake fluid. Brake fluid is uniquely designed to withstand high pressures and temperatures while maintaining incompressibility. Glycol-based fluids, such as DOT3, DOT4, or DOT5. 1. Are hygroscopic, meaning they attract moisture. Over time, water accumulation lowers the fluid's boiling point. When fluid boils under hard braking, vapor pockets form, causing spongy pedal feel or brake fade. A fluid's dry boiling point references fresh fluid, while the wet boiling point indicates performance with water content. Performance vehicles or heavy braking scenarios demand higher-grade fluid with superior heat tolerance. Keeping an eye on the fluid's color, clarity, and moisture content, via test strips or a specialized meter, helps ensure the system remains responsive. Differences among DOT ratings. DOT3 brake fluid is common in many daily drivers, with adequate temperature ratings for normal use. DOT4 typically features higher boiling points, suitable for spirited driving or heavier loads. DOT5 is silicone-based, used in select classic or specialty applications, but it should never mix with glycol-based fluids. 5. 1, though labeled 5.1, remains glycol-based, bridging the performance gap for track or rally conditions. Each rating has unique pros and cons. Silicone-based fluids, DOT5, do not absorb moisture but can entrap air bubbles and are incompatible with ABS systems in many cases. By contrast, DOT4 or 5.1 support advanced braking technologies, though they require more frequent changes to manage moisture absorption. Matching the fluid to the vehicle's usage pattern is key to stable, reliable braking. Bleeding and flushing brake lines. Air pockets or water in brake lines degrade pedal firmness. Thus, bleeding the system removes trapped air after brake repairs or fluid replacement. In older setups, you might do a manual bleed, working each wheel cylinder or caliper in turn, ensuring fluid flows steadily without bubbles. Modern vehicles might incorporate ABS modules that require special bleed procedures or scan tool activation to cycle internal valves. Every year or two, a complete flush can be beneficial, expelling accumulated moisture and contaminants. Some manufacturers incorporate recommended intervals. The color shift from fresh, light fluid to darker fluid signals that it is time. By meticulously flushing, you safeguard brake performance during emergencies. An even pedal feel, short stopping distances, and minimal fade reflect a well-bled, moisture-free system. ABS systems and fluid requirements. Anti-lock braking systems modulate brake pressure via rapid solenoid control. Contaminated or stale brake fluid can hamper the speed at which these solenoids operate, undermining ABS performance. That is why high-quality fluid with a stable boiling point is crucial if the system is to cycle effectively during hard stops. During an ABS bleed, you may need a scan tool to run the pump and solenoids, ensuring any trapped air in the module is released. Avoiding cross-contamination, like mixing different fluid types, becomes even more critical, as the fine passages in the ABS block can clog easily. Understanding the synergy between ABS hardware, software, and fluid properties helps you deliver consistent braking solutions. Detecting leaks and soft pedals. Leaks in the brake hydraulic system might appear at caliper piston seals, brake lines, or the master cylinder. The fluid, often a pale amber or clear color, unless tinted by age, can leave sticky residues. A dropping fluid level in the reservoir or a spongy pedal are early indicators. Diagnosing the root cause might involve pressurizing the system and watching for seepage. Because brake fluid can damage paint and attract dirt, leaks often reveal themselves by discolored or peeling areas near the leak source. Quick action is paramount. Any compromise in brake hydraulics raises serious safety risks. By routinely inspecting hoses, fittings, and around-wheel cylinders, you catch issues preemptively, preserving both performance and peace of mind for the driver. Power steering fluids and system care. Evolution of power steering fluids. Traditional power steering systems used hydraulic pressure from a pump to ease wheel turns. They typically relied on fluids similar to ATF or distinct power steering fluid. Modern electric power steering often eliminates fluid altogether, but many vehicles on the road still maintain hydraulic setups. Over time, manufacturers introduced specialized fluids with anti-foaming and anti-wear additives, tailoring them to unique pump and seal designs. While older vehicles may accept generic power steering fluid, newer models might specify a certain type, like CHF11S or a variant that aligns with the brand's internal components. Mismatched fluid can degrade seals or produce noise, so verifying the owner's manual or reservoir cap is essential. As steering designs get more advanced, fluid chemistry also evolves. Identifying symptoms of fluid problems: a whining or groaning power steering pump often points to low fluid or aeration. If fluid levels drop, air can mix in, causing a foamy, noisy system. Steering might feel stiff or jerky, especially at low speeds. Discolored or burnt-smelling fluid suggests heat stress or contamination. When diagnosing such issues, checking hoses, seals, and the pump for leaks or blockages is a top priority. Sometimes, the power steering reservoir includes a small filter or mesh screen that collects debris. Overlooking this component can lead to restricted flow if it becomes clogged. Regularly examining the fluid's color and clarity can warn of brewing trouble. Correcting fluid concerns early helps preserve pump life and maintain that effortless steering feel. Proper flushing techniques: when a power steering system develops persistent contamination, like metal shavings from a failing pump or moisture intrusion, a flush can reset the system. Technicians might disconnect a return line, add fresh fluid to the reservoir, and cycle the steering from lock to lock while old fluid drains. This procedure can be messy but ensures a more complete refresh compared to a simple top-up. If your flush includes replacing major components, priming them with fluid before hooking up lines can prevent a dry start. Some professional flush machines automate the process, but manual methods remain valid if done carefully. Avoid overfilling, as fluid expands when heated. By ensuring no air pockets linger, you avert pump starvation or irritating steering squeal. Sealing and leak prevention: power steering racks or gearboxes feature seals that control fluid under high hydraulic pressure. A minor seal tear can leak slowly, leading to sticky residue on the steering gear or subframe. Over time, fluid loss can starve the pump, culminating in costly repair bills. Regular underhood checks help catch these weeps early. If a vehicle repeatedly loses fluid, checking the high-pressure line, rack boots, and pump shaft seals are essential. Sometimes, retorquing a fitting or replacing an O-ring solves the problem. Other cases involve deeper rack rebuilds. Because power steering fluid can degrade rubber over many years, older hoses and seals tend to fail from age. Preventive replacement often saves time and money in the long run. Transitioning to electric systems: electric power steering, EPS, uses an electric motor instead of hydraulic fluid. It reduces weight, eliminates leaks, and can adjust steering assistance electronically. While EPS is increasingly common, many existing vehicles remain hydraulic or electrohydraulic. Technicians should be prepared to handle both realms. Understanding hydraulic fluid care remains relevant for millions of vehicles still on the road. As EPS adoption grows, fluid-based systems may become less prevalent, yet they will not vanish overnight. Shops that maintain robust power steering fluid knowledge can better serve older or specialized vehicles. When fluid systems do come in, applying thorough inspection and flush protocols ensures top-notch service. Specialty fluids, transfer cases and differentials: transfer case lubricants for WD and AWD vehicles often house a transfer case that splits power between the front and rear axles. The fluid within must handle gear sets or chains under load, plus potential friction clutches for torque on demand. Some automakers specify ATF, while others require specialized transfer case oil with distinct friction modifiers. A mismatch can lead to binding or slipping in the driveline. Servicing a transfer case includes draining and refilling the fluid at recommended intervals, especially for vehicles used off-road or in severe conditions. Contamination, water ingress from deep water crossing, or simply high mileage can degrade fluid performance. By adopting regular checks, you ensure that the transfer case reliably transfers torque, preventing drive binding or excessive gear wear. Front and rear differential fluids. Differentials house ring and pinion gears that endure high torque multiplication. Proper gear oil, often labeled with a GL5 rating, features robust extreme pressure additives, enabling gear teeth to mesh under load without galling. Some final drives run thicker oils like 85W140 for heavy towing, while standard conditions might suit 75W90. Limited slip differentials rely on friction clutches or cones. These need friction modifiers or specialized fluids so that the LSD can lock and unlock smoothly. If the fluid lacks these modifiers, the diff might chatter or slip under cornering. Meanwhile, open differentials do not require special friction traits, but they still need the correct viscosity and EP rating. Checking for contamination. Metal shavings on a magnetic drain plug can indicate wear or break-in patterns. A light fuzz is often normal in new setups, but larger flakes raise concern. Water intrusion turns oil milky, while severe heat can darken it and produce a burnt smell. Synthetic gear oils typically flow better at low temperatures, reducing wear on cold starts. They also sustain viscosity under high heat, beneficial for towing or high-performance usage. For differentials generating significant heat, such as racing or off-roading, synthetics often prove superior. However, conventional oils remain viable and can be more economical for everyday commuting or older vehicles with looser tolerances. Some older seals might also be more compatible with certain conventional formulations. Checking manufacturer recommendations and balancing performance needs guides technicians toward the right gear oil selection. Windshield washer fluid and miscellaneous substances. Washer fluid composition. While not as critical as engine or transmission fluids, washer fluid still serves a key safety function by cleaning the windshield. Typically a mixture of water, methanol or ethanol, and detergents, it loosens grime and improves visibility. Special winter blends include a higher alcohol content to lower the freezing point, preventing the reservoir and lines from icing. Some automotive stores sell concentrated washer solutions that must be diluted. Using pure water alone can cause freeze-ups in cold climates and might not remove bugs or oily residue effectively. By recommending a proper washer fluid, you minimize streaks, enhance clarity, and reduce freezing risks in winter driving. De-icer formulas. In sub-zero areas, de-icer washer fluids help melt ice on the windshield. They often contain additional chemicals to break down frost quickly. While useful, these formulas may be more aggressive toward paint or rubber if oversprayed. Technicians who notice swirl marks or dull wiper blades can suspect repeated exposure to harsh de-icing solvents. Customers might also store a separate spray bottle of de-icer for door locks or external handles. Advising them about the potential for dryness on rubber seals or paint means they can take extra steps, like applying silicone protectant or carefully wiping spills. Balancing the convenience of instant ice removal with protective measures is good automotive care. Air conditioning. Refrigerants. Though not a lubricant in the conventional sense, refrigerant is crucial for the AC system's operation. R134A has long dominated, but newer, more eco-friendly types like R1234YF are gaining ground. Each refrigerant type requires specific oils for the compressor and unique service equipment. Mixing refrigerants can damage components and is often illegal due to environmental regulations. Technicians must use dedicated recovery and recharge machines for each refrigerant type, ensuring no cross-contamination. Proper labeling and hoses help avoid misapplication. The lubrication within the system, usually PAG or POE oil, supports the compressor's internals. Failing to match the correct oil with the correct refrigerant can lead to seizing or inadequate cooling. Undercoating and rustproofing. While not a fluid in the same sense as engine oil, rustproofing compounds or undercoatings often start as liquid sprays that coat a vehicle's underside. These may be petroleum-based or wax-based, forming a protective barrier against salt, moisture, and debris. Over time, they solidify into a tacky or waxy film. Effective undercoating can prolong the life of brake lines, suspension components, and the frame. However, improperly applied coatings can trap moisture, accelerating rust. Technicians must carefully clean and dry surfaces before application. For vehicles in regions with heavy road salt, reapplying undercoating every few years can be beneficial. Handling these chemicals calls for respiratory protection to avoid inhalation of fumes. Specialty lubricants and greases. A myriad of special-purpose lubricants exist: silicone grease for rubber parts, white lithium for hinges, molybdenum disulfide paste for CV joints, or copper anti-seize for exhaust hardware. Each addresses a distinct challenge, like extreme heat or the need to protect moving parts from corrosion. Selecting the right grease matters as much as choosing the proper engine oil. For instance, wheel bearings might need a high-temperature grease that resists liquefying under brake heat. Door hinges might benefit from a lighter grease that does not drip. Armed with knowledge of each product's temperature range, consistency, NLGI grade, and base oil type, technicians can keep everything from door latches to universal joints operating smoothly. Maintenance best practices and diagnostic clues. Periodic fluid inspections. Regular fluid checks form the backbone of preventative maintenance. Conducting a multi-point inspection at each oil change is a standard procedure. Checking coolant in the overflow tank, verifying brake fluid level in its reservoir, evaluating power steering fluid, if applicable, and confirming windshield washer fluid might seem mundane, yet they catch small issues. A discolored or foul-smelling fluid signals advanced contamination. A rapidly dropping level suggests leaks or internal consumption, like coolant in the combustion chamber. By systematically logging observations each visit, a technician can notice trends, such as a gradual coolant decrease, and address them before they escalate into engine damage. Identifying cross-contamination. In rare but harmful scenarios, fluids can mix due to a failed internal seal or cooler. Transmission fluid mixing with coolant is particularly damaging, forming a milky emulsion that impacts both systems. Oil in the coolant, or coolant in the oil, often points to a head gasket breach. Vigilance in checking fluid color and consistency at every service reveals these problems early. When you suspect cross-contamination, flushing both systems thoroughly is mandatory. Additional repairs, like replacing a cracked radiator or installing a new head gasket, are often needed. Post-repair checks verify that systems now remain separate and uncontaminated. By recognizing the warning signs promptly, you minimize internal corrosion or mechanical breakdowns. The influence of driving conditions. City stop-and-go commuting, mountainous roads, racing events, or heavy hauling. Each shape fluid wear. Engines operating under high load run hotter, degrading oil or coolant sooner. Meanwhile, constant short trips might never let the engine warm fully, causing condensation buildup in the oil. Technicians who ask about driving habits can tailor fluid service intervals or product recommendations. A driver who tows a camper regularly might need a more robust transmission fluid, while a track day enthusiast might choose a higher viscosity engine oil with stronger anti-wear additives. Personalizing these suggestions fosters trust and protects the vehicle's reliability under real-world usage. Early signs of fluid-related problems: knocking sounds at startup, metal flakes in oil, or a burning smell from the gearbox are all fluid red flags. Weak steering assist and noisy pumps hint at power steering fluid issues. Faint sweet odor near the engine bay could mean a coolant leak, while a spongy brake pedal reveals potential air or moisture infiltration. Documenting these warning signs systematically helps narrow diagnostic steps. For instance, if a driver reports that the check engine light appears after a high-temperature climb, you might check the coolant levels or oil condition first. Technicians who connect fluid symptoms to mechanical functions streamline troubleshooting, saving time and potential guesswork. Establishing a preventive maintenance culture. Motorists often delay fluid changes, focusing on the more visible repairs. Encouraging them to follow manufacturer schedules or to adopt a cautious approach if usage is severe fosters a stronger maintenance culture. Shops can provide printed or digital reminders, explaining how proactive fluid care guards against bigger bills. Consistent, accurate record-keeping underscores your credibility. Checking off each fluid check or flush on a detailed inspection sheet reassures owners that every angle has been addressed. Over time, this diligence pays dividends in brand loyalty, as satisfied customers return knowing their vehicles receive thorough, fluid-focused attention. Disposal, recycling, and environmental stewardship. Hazardous waste regulations. Spent engine oil and other automotive fluids often qualify as hazardous waste. Laws typically forbid pouring them into sewers or landfills due to toxic heavy metals and chemical additives. Repair shops must store used fluids in clearly labeled, sealed containers, then contract with licensed disposal services. Fines for non-compliance can be steep. Even used antifreeze can be toxic to wildlife due to ethylene glycol's sweet taste. Some locales require businesses to process it via distillation or recycling systems on site. Staying updated on these legal obligations ensures your workshop remains both environmentally responsible and legally compliant. Customers increasingly value eco-friendly practices, so highlighting proper waste management can be a selling point. The rise of recycling centers. Many communities now offer dedicated collection points for used oil, filters, and coolant. Some automotive retailers accept these items at no charge. The oil is re-refined, turning it into fresh lubricant. Antifreeze can be purified and reused. By directing these products into recycling streams, we conserve resources and reduce environmental harm. Shops that proactively promote recycling underscore their commitment to the environment, winning respect among conscientious drivers. This approach can also reduce disposal fees if your local recycling facility provides free or subsidized pickups. The bottom line, adopting greener practices fosters a safer community and a cleaner planet. Minimizing spill risk. Storage areas for fluids should feature spill containment measures, like secondary basins or absorbent materials. Splashes or drips can degrade floors, create slip hazards, or infiltrate drains if left unattended. An oil spill kit equipped with mats, booms, or sawdust-type absorbent stands ready for quick response, preventing widespread contamination. Following routine housekeeping, like wiping up small spills immediately and sealing every container after use, discourages accidents. Labeling each container in big, clear text eliminates confusion among staff, ensuring no one dumps coolant into an engine oil barrel by mistake. Such discipline is a hallmark of a well-organized, safety-conscious shop. Educating customers on disposal. Beyond professional shops, many do-it-yourself enthusiasts change their own oil or coolant at home. Encouraging them to bring waste fluids to your facility or explaining the location of local recycling centers helps reduce improper disposal. Posting easy-to-read flyers or offering a fluid return service fosters community goodwill. By bridging the knowledge gap about correct disposal, you lessen the chance of environmental harm. Customers are often unaware of the legal or ecological consequences of pouring old fluids down a drain. A bit of education can shift behaviors, with your shop serving as the reliable hub for responsible automotive waste management. Future outlook for environmentally friendly fluids. Technology is moving toward more biodegradable options and closed-loop recycling. Bio-based lubricants from renewable feedstocks might become more common, reducing dependence on petroleum. Already, some industrial sectors use biodegradable hydraulic oils to limit ecological damage from accidental spills. As automotive electrification expands, certain fluid demands may decrease, but others, like specialized thermal management fluids for battery cooling, will rise. A forward-thinking technician stays curious about these emerging solutions, adapting as the industry shifts. Embracing greener fluid technology is not just an environmental advantage, it can also open new revenue streams for shops that cultivate expertise in sustainable servicing. Final reflections and moving forward. Mastering fluid knowledge in service. Fluids facilitate every facet of automotive function, from pumping pistons to chilling radiators. By grasping how oils, coolants, and specialty liquids each play their part, you transform from a parts replacer into a diagnostician who sees the bigger mechanical tapestry. This holistic viewpoint enables informed recommendations, where fluid selection and service frequency reflect the vehicle's real-world demands. As you continue your ASE journey, you will encounter advanced topics, like diagnosing internal transmission woes or optimizing track day lubrication. Yet the principles covered here form the sturdy base upon which specialized knowledge stands. By revisiting and refining these basics, you ensure your approach to fluid management remains consistent and effective. Embracing continuous education. Automotive fluid technology does not remain static. Each year brings fresh formulations and brand-specific blends. Original equipment manufacturers sometimes alter fluid recommendations mid-generation to enhance durability or handle recall concerns. Staying current requires active learning, attending technical seminars, reading service bulletins, and trading experiences with peers who discover new issues or solutions. Working in a dynamic environment compels you to stay curious. A new synthetic blend might solve chronic deposit issues in an engine family, or an advanced brake fluid could handle high track temperatures. By embracing these developments, you give each vehicle the best protection and performance possible. Your professional reputation grows as someone who invests in continuous improvement. Collaboration with customers and colleagues. Transparency about fluid-related choices fosters trust. When a customer asks why a certain coolant is more expensive, explaining its extended life or superior corrosion inhibitors clarifies the value. When a colleague wonders why a differential is whining after a fluid change, you can guide them through checking for the correct viscosity or friction modifier. A workshop thrives when team members share fluid-based insights, like discovering a particular brand that works better in certain transmissions. Collective expertise elevates the quality of service and reduces trial and error. Whether in a quick lube franchise or a performance tuner garage, dialogue about fluid experiences prevents repeated mistakes and fosters consistent excellence. Practical steps for future-proofing. Looking ahead, the shift towards hybrids and fully electric vehicles will change how often certain fluids are replaced. Transmission intervals might extend, while advanced cooling loops for battery packs need specialized attention. Some EVs even require unique greases for electric motor bearings. By staying informed about these evolutions, you remain ready to service a broad range of vehicles. Additionally, advanced telematics or vehicle health monitors might track fluid conditions, generating alerts before the fluid is visibly compromised. This synergy of data and mechanical expertise promises more accurate service intervals, though it also demands that technicians interpret digital logs and sensor data carefully. Positioning yourself at this intersection of technology and fluid management keeps you competitive and relevant. Concluding thoughts on fluid mastery. Automotive fluids appear mundane on the surface, yet they stand at the heart of mechanical reliability and efficiency. They unite metal components, dissipate heat, support critical shifts, and anchor braking responsiveness. By mastering their chemistry, application, and maintenance intervals, you elevate every aspect of vehicle service. Customers gain safer, smoother rides, while you develop a stronger foundation for advanced automotive troubleshooting. Carrying forward this expertise, you will find your diagnostic confidence strengthened. Whether detecting subtle coolant leaks or advising on the best differential oil, your knowledge translates directly into trust and repeat business. Embrace fluid science as both a daily practice and a gateway to broader mechanical understanding. In a landscape where the smallest detail can make the biggest difference, your fluency in fluids becomes a hallmark of professional distinction. Lesson 9: Shop environment and best practices. An examination of how organized spaces and methodical procedures elevate automotive work. The importance of cleanliness in daily operations. A well-maintained shop directly impacts both safety and efficiency. When floors remain free of debris, oil spills, or loose parts, technicians can move about without tripping hazards or distractions. Clean tabletops and tool carts also make it easier to locate specific wrenches, sockets, or diagnostic devices. Additionally, an orderly environment fosters professionalism, leaving a positive impression on customers who visit or observe the premises. Streamlined tool organization and accessibility tools stored in logical groupings reduce wasted motion and frustration. Technicians save time by not hunting for misplaced equipment under benches or at the bottom of random boxes. Magnetic trays, pegboards, shadow boards, and labeled drawers each help indicate where every item belongs. A standardized storage method means anyone on the team can locate vital instruments in seconds, accelerating repairs and ensuring tasks proceed uninterrupted. Environmental comfort and lighting mechanics often face physically taxing tasks, so workshop comfort cannot be overlooked. Proper ventilation disperses fumes from chemicals and running engines. Bright, evenly distributed lighting reveals details under the hood or beneath vehicles, aiding accurate diagnosis. Temperature regulation, whether through fans or heating, helps keep staff focused, improving both morale and quality of workmanship. By investing in a comfortable, well-lit space, you bolster productivity and reduce fatigue. Customer-friendly reception and waiting areas. Even though most of the labor happens behind the scenes, an inviting front desk and waiting area sets the tone for client interactions. Simple touches, like clear signage, clean seating, and a refreshment corner, demonstrate care for visitors' comfort. Displays or posters explaining common automotive issues can also educate customers. When clients feel welcomed, they tend to trust the shop more, encouraging long-term relationships and positive word of mouth. Scheduling and workflow management. A chaotic schedule can hobble even the best-equipped garage. Effective workflow planning avoids bottlenecks by assigning tasks to technicians with the right expertise and distributing workload evenly. Employing software or a shared calendar helps everyone stay aware of upcoming appointments or vehicles waiting for parts. Proper scheduling ensures minimal downtime, keeps customers informed, and maintains a steady pace without overburdening staff. Adhering to safety regulations and compliance. Understanding OSHA and local workplace standards. Compliance with workplace safety regulations goes beyond fulfilling a legal requirement, it ensures employees stay healthy. The Occupational Safety and Health Administration, OSHA, sets guidelines covering machine guarding, hazardous chemical usage, and protective equipment. Local or regional agencies may impose additional rules for emergency exits, signage, or noise levels. Abiding by these standards protects employees from harm and shields the business from fines or legal action. Personal protective equipment, PPE, usage. Effective PPE use stands at the core of shop safety. Eye protection blocks flying metal shards from grinders, respirators filter airborne chemicals, and steel-toe boots protect feet from dropped components. Mandating these items, along with gloves, earplugs, and welding helmets when appropriate, reduces workplace injuries significantly. Setting a positive example at the managerial level also encourages technicians to adhere to PPE protocols consistently. Fire prevention and emergency preparedness. Shops deal with flammable liquids like gasoline, solvents, and cleaning agents, making fire safety essential. Emergency exits must be unobstructed, with clear signage and functional lighting. Fire extinguishers rated for Class B or C fires should be strategically placed, and staff must know how to operate them. Conducting routine safety drills, checking sprinkler systems, and having a plan for hazardous spills all form part of a robust emergency protocol. Handling hazardous substances and chemicals. Many automotive substances, brake fluid, battery acid, or certain cleaners, pose risks if mishandled. Proper labeling, storage in approved containers, and adherence to hazard communication, HAZCOM, standards keep employees safe. Technicians benefit from accessible safety data sheets, SDS, detailing each chemical's properties and first aid measures. Appropriately sealed cabinets for flammables, along with mandatory ventilation during usage, prevent accidental inhalation or fire hazards. Regular safety audits and training. Safety practices cannot remain static. Periodic audits unearth overlooked risks, such as frayed cords or blocked walkways. Management can schedule refresher training sessions on lockout/tagout procedures or updated PPE guidelines. Adding short monthly meetings for staff to voice safety concerns encourages continuous improvement. By actively monitoring compliance and adjusting protocols, you develop a lasting culture that places employee well-being at the forefront. Optimizing workflow through team coordination. Role clarity and task allocation. Confusion about responsibilities can slow progress and breed errors. Clear job descriptions and daily briefings ensure each technician knows which tasks belong to them, be it tire rotations, engine diagnostics, or brake replacements. When staff stay in their areas of expertise, tasks proceed efficiently, though cross-training can provide coverage if someone is absent. This structured allocation of roles helps prevent overlapping efforts or neglected jobs. Collaborative problem-solving for complex repairs. Complex issues, like intermittent electrical faults or obscure engine vibrations, can benefit from brainstorming among multiple technicians. Sharing observations, referencing past experiences, or conducting group diagnosis fosters a deeper understanding of the underlying problem. Team problem-solving not only hastens solutions but also enriches individual skill sets. Encouraging open dialogue across varying expertise levels elevates overall shop capabilities. Effective communication with support staff. Non-technical personnel also play crucial roles. Service advisors interact with customers, parts specialists source components, and front desk staff manage appointments. Technicians who communicate repair progress help service advisors provide accurate updates to customers, reducing frustration. Meanwhile, parts specialists benefit from early notifications if a job requires specialized seals or gaskets. This synergy ensures minimal downtime and improves the entire shop's operational rhythm. Using technology for better coordination. Today's automotive environment offers digital shop management software that tracks work orders, stores vehicle histories, and logs technician notes. Instead of rummaging through paper forms, staff can check updates on tablets or computers. Status boards display who's working on which car, preventing duplication. With integrated messaging platforms, urgent bulletins, like a recall notice, can instantly reach all employees. Embracing these tools shortens turnaround times and boosts accuracy. Motivating the team and celebrating success. A motivated crew puts forth higher quality work. Celebrating small wins, like an exceptionally fast turnaround or a seamless diagnostic success, reinforces positive behaviors. Recognition can come in many forms: a staff shout-out in a morning huddle, a gift card, or a simple "thank you" in front of peers. By fostering an environment where contributions are acknowledged, you nurture loyalty, team spirit, and a drive for consistent improvement. Ensuring quality control and consistency. Standardized repair procedures. When each mechanic follows the same documented steps for common tasks, errors decrease significantly. For example, a uniform procedure for brake pad replacements, including rotor measurement and lubrication points, ensures reliable results. Standardization also helps new employees integrate quickly, as they have clear instructions to follow. Consistent quality reassures customers that any technician in the shop can deliver an equally proficient repair. Checklists and final inspections. Before handing over a vehicle, a structured checklist helps confirm every bolt is torqued and every fluid is topped up. Missing a single detail, like tightening an oil drain plug, can undermine the best efforts. These lists act as mental triggers, reducing oversight. A final inspection, sometimes by a senior technician or foreman, verifies that the vehicle meets shop standards, preventing customers from discovering an unfinished detail later. Tracking and analyzing comebacks. A comeback is a vehicle returning for a repeated or unresolved issue. Monitoring these instances clarifies patterns or weak points in your workflow, whether they stem from hurried diagnostics, subpar parts, or communication missteps. By openly discussing comebacks with the team, you create an opportunity to refine procedures. Reducing repeat visits not only saves time and resources but also elevates the shop's reputation. Benchmarking time and accuracy. Setting realistic labor times for jobs helps measure efficiency. If a technician consistently exceeds the standard hours for certain repairs, it may indicate a training need or a unique challenge not accounted for in standard times. On the flip side, finishing far ahead of schedule can highlight expertise or potential shortcuts. Tracking these metrics guides management in offering constructive feedback, promotions, or additional education. Harnessing feedback from customers' customer satisfaction surveys or direct commentary reveal how repairs hold up after the customer has left. Complaints about unexplained noises or continued leaks might mean further training in specific areas. Praise for prompt completion or excellent communication shows which aspects are working well. By welcoming both positive and negative feedback, shops refine their best practices and maintain accountability. Building positive customer relationships. Clear and transparent estimates. Customers appreciate honesty about costs and timelines. Providing a detailed breakdown of parts, labor charges, and relevant taxes assures them there are no hidden fees. If any step might increase the price, like discovering a worn rotor or a seized bolt, early communication prevents shock. This transparency fosters trust, the bedrock of long-term client loyalty. Explaining technical details in plain language. Automotive jargon can confuse or intimidate those without mechanical backgrounds. Translating complex terms into relatable examples, like likening a faulty oxygen sensor to a clogged airway, helps customers grasp why a repair is needed. Visual aids, like showing them the worn brake pad or the cracked belt, can reinforce the necessity. This clarity empowers customers to make informed decisions about their vehicle. Maintaining professional etiquette. Whether talking over the phone or greeting someone at the counter, politeness and empathy set the tone. Patience becomes vital when customers are stressed about an urgent breakdown. Addressing them by name, making eye contact, and listening attentively fosters a welcoming atmosphere. Technicians who demonstrate patience and courtesy cultivate a reputation for approachability, leading to stronger word-of-mouth referrals. Following up on completed work. A short phone call or email a few days after returning the vehicle demonstrates genuine care. Asking whether everything is running smoothly and if they have any lingering questions builds rapport. If issues arise, prompt follow-up ensures problems don't fester into major complaints. Customers often feel valued by this attention, reinforcing the idea that your shop stands behind its workmanship. Handling disputes or dissatisfaction. No matter how carefully a shop operates, misunderstandings or unexpected part failures can occur. When a customer voices dissatisfaction, listening calmly forms the first step. A solution-focused response, offering to re-inspect, waive a diagnostic fee, or investigate further, demonstrates integrity. By approaching disputes with empathy and concrete remedies, you can preserve goodwill and possibly convert a frustrated client into a loyal advocate. Tools, equipment, and facility upkeep. Regular equipment calibration and maintenance. Torque wrenches, alignment machines, and diagnostic scanners lose accuracy over time. Scheduling periodic calibrations ensures each device remains precise. Tire pressure gauges, for instance, can drift, leading to incorrect inflation advice. Diligent upkeep extends equipment lifespan and supports consistent service quality. This professionalism also reflects well on the shop, showing that you refuse to rely on guesswork. Inventory management for parts and supplies. An organized stockroom prevents project delays caused by missing or mislabeled parts. Implementing a digital inventory system can track usage patterns, flag reorder points, and reduce waste. Separating new from used or core return items averts accidental misuse. Maintaining a balance of just-in-time ordering and essential spares keeps the workflow smooth without tying up excessive funds in stockpiles. Clean and safe working bays. Individual service bays must be large enough for vehicles to enter and open doors easily. A dedicated corner for hazardous tasks, like welding or grinding, limits sparks and airborne particles from drifting into other areas. Using protective curtains or screens isolates these operations. Proper drainage in wash bays prevents water from pooling, while slip-resistant mats reduce the risk of falls on wet surfaces. Specialized tools for complex repairs. As vehicles embrace advanced technologies, think ADAS calibrations or hybrid battery replacements, specialized tools become essential. Buying or leasing these devices can pay off by attracting customers who value specialized expertise. Technicians benefit from standardized training on each new piece of equipment, ensuring correct usage. Regular software updates and manufacturer bulletins keep these tools relevant for evolving automotive designs. Continuous facility improvements. Shops can modernize gradually, adding LED lighting for better visibility, installing energy-efficient air compressors, or upgrading lifts with enhanced safety features. Periodic reinvestment shows staff and customers a commitment to excellence. Employees appreciate ergonomic improvements, a well-placed parts counter or a comfortable break room, while clients notice when the workshop appears updated and professionally maintained. Training, growth, and professional development onboarding programs for new technicians rapidly immersing newcomers in shop culture and standards sets them on a path to success. Assigning a mentor or buddy eases them into daily routines, encourages them to ask questions, and reduces the risk of costly mistakes. Structured introductions to shop equipment, safety rules, and standard operating procedures ensure everyone starts from a solid foundation. ASE and other certifications. Earning recognized certifications elevates the shop's credibility and a technician's confidence. Whether focusing on brakes, engine diagnostics, or electronic systems, ASE credentials affirm mastery in those specialties. Employers often reward certified staff with higher pay or leadership roles, recognizing the effort required. Furthermore, displaying these certificates in the waiting area reassures customers of the shop's expertise. Regular skills upgrades and cross-training. Automotive technology evolves rapidly, with new engine layouts, fuel systems, and software updates. Ongoing training sessions help staff keep pace. Cross-training fosters adaptability. If the main transmission specialist is busy, someone else who's partially cross-trained can handle simpler gearbox tasks. This approach also breaks monotony by letting technicians expand into varied roles, fueling motivation and deeper understanding. Factory bulletins and manufacturer resources. Car manufacturers release technical service bulletins, TSBs, or recalls that detail updated procedures or known defects. Monitoring these bulletins helps shops diagnose repeating problems more efficiently. Subscription-based portals might provide schematic diagrams, torque values, and advanced diagnostics tips for new models. Staying tapped into such resources ensures the team never falls behind on crucial design changes that affect repair protocols. Cultivating a learning culture. Encourage staff to share newly acquired knowledge in brief, tech talks at staff meetings. Perhaps a technician discovered a trick for swiftly resetting a certain car's adaptive transmission or found an innovative method to remove corroded fasteners. Each small insight, when disseminated, raises collective capability. Over time, this environment of open learning cements the shop's reputation for continuous improvement. Workflow technologies and digital integration. Using management software for job tracking. Modern shop management platforms enable scheduling, estimating, and billing in one place. Each vehicle's status can update in real time, from diagnosis ongoing to parts ordered. Technicians can view their queue and post notes on a shared dashboard. This reduces phone calls or manual tracking, ensuring everyone knows precisely which stage each car occupies. Electronic repair manuals and diagrams. Bulky paper manuals can become outdated quickly. Digital references, complete with searchable indexes, wiring diagrams, and high-resolution component breakdowns, make repairs more efficient. Technicians can swiftly locate torque specs or recall steps using a tablet or workstation near the lift. As manufacturers push for eco-friendly solutions, these digital resources keep pace with frequent model updates. Paperless inspections and customer reports. Vehicle inspections captured on tablets can store photographic evidence of worn parts or fluid leaks. Sending an electronic link or PDF to a customer's phone fosters transparency, no more cryptic descriptions. By visually showcasing the need for new tires or a belt, trust and acceptance of recommendations tend to grow. Simultaneously, the shop archives these digital records for future reference. Adopting online payment systems. Customers increasingly prefer touchless transactions. Integrating online payment portals or card readers expedites checkout, saving time for both parties. Automated invoicing can detail each repair step, itemized parts, and total labor hours. By streamlining billing, the shop reduces confusion over charges and also modernizes the customer experience. Cybersecurity and data protection. With greater digital reliance comes the need for data security. Customer details, payment info, and service histories must remain safeguarded against breaches. Regularly updating software, using secure Wi-Fi networks, and applying strong passwords deter unauthorized access. Training staff on phishing or suspicious links likewise protects your digital infrastructure. A secure, professional approach to data fosters trust in the modern automotive era. Waste management and environmental responsibility. Recycling oils and hazardous materials used. Engine oil, transmission fluid, and other lubricants require correct disposal to protect waterways and soil. Partnering with certified waste collectors ensures these oils can be re-refined or incinerated according to environmental standards. Similarly, oil filters can be drained and recycled as metal scrap, reducing landfill waste. Responsible fluid management is both an ethical and regulatory necessity in modern shops. Managing coolant and chemical runoff. Coolant spills can be dangerous to pets and wildlife if they reach storm drains. Technicians should keep spill containment kits nearby to handle accidental leaks swiftly. Proper labeling of coolant storage tanks, along with sealed floor drains that feed into treatment systems, prevents unintentional contamination. By actively controlling chemical runoff, a shop demonstrates environmental stewardship. Minimizing solvent use and air pollutant. Solvent-based cleaners release volatile organic compounds, VOCs, impacting air quality. Where possible, shops can switch to water-based parts washers or adopt ultrasonic cleaning systems. Some advanced washers recycle cleaning solutions by filtering out contaminants. Reducing solvent dependence not only lowers hazards for employees but also aligns with cleaner operating practices that neighbors and local authorities will appreciate. Energy conservation and efficiency. The auto repair environment runs heavy equipment, lifts, air compressors, and lighting all day. Upgrading to LED fixtures, setting thermostats to moderate levels, and insulating workshop doors can trim energy bills. In some places, local utilities offer rebates for adopting efficient HVAC or lighting systems. Beyond cost savings, such measures convey a forward-thinking, eco-friendly approach that resonates with customers seeking socially responsible businesses. Encouraging eco-minded practices. Providing designated bins for recycling metal scrap, cardboard packaging, or plastic containers simplifies waste separation. Motivating employees to be mindful, turning off unused lights or closing large doors in cold weather, adds up. Posting reminders, or even small incentives for eco-initiatives, keeps these habits ingrained. Each incremental improvement helps build a lasting culture of environmental care within the shop. Strategic growth and long-term shop success. Establishing a recognizable brand identity. Branding goes beyond a catchy name or logo. A well-defined identity highlights your shop's strengths, like specialization in European imports or exceptional customer service. A consistent brand message across signage, uniforms, and business cards fosters trust. Over time, customers associate that brand with reliable, high-quality automotive work, giving your shop a tangible competitive advantage. Digital marketing and online presence. Customers increasingly search for repair shops online, checking reviews before making decisions. Maintaining a website with details about services, staff credentials, and contact information boosts credibility. Posting timely updates on social media, like photos of interesting projects or behind-the-scenes glimpses, can engage followers. Positive reviews on platforms like Google or Yelp further solidify a shop's standing. Being responsive to customer comments or inquiries online also signals attentiveness. Building partnerships with vendors and local businesses. Reliable suppliers ensure timely part deliveries, reducing service delays. Negotiating beneficial terms or volume discounts helps manage inventory expenses. Collaborating with neighboring businesses, like car dealerships, tire retailers, or auto detailers, broadens referral networks. Even non-automotive alliances, such as local charities or sports teams, can generate community goodwill, shining a positive light on the shop. Planning for expansion or modernization. If demand outpaces available bays or specialized tasks increase, expansion becomes a strategic option. This could involve adding a dedicated paint booth, investing in advanced diagnostic tools, or opening a second location. Each leap requires robust financial forecasting, ensuring the additional overhead is sustainable. Thoughtful scheduling of expansions during off-peak seasons can ease the transition. Legacy and succession planning. For shop owners eyeing retirement or new ventures, grooming future leaders is crucial. Whether passing the torch to a family member or a loyal employee, transparent discussion fosters continuity. Detailed documentation, covering vendor contacts, maintenance schedules, and operational protocols, reduces disruption when leadership changes. A smooth handover preserves customer relationships and ensures the shop's reputation remains intact. Concluding reflections on a thriving shop environment. Integrating best practices from start to finish. A successful automotive workshop integrates a wide range of best practices, from cleanliness and safety compliance to robust communication. Each facet builds on the other. Strong scheduling keeps technicians organized, which supports consistent quality checks, in turn reducing comebacks and boosting customer satisfaction. By weaving these elements into daily routines, you create a synergistic system that underpins seamless operations. Continual assessment and adaptation. No strategy or layout remains optimal forever. Vehicles evolve, regulations shift, and technology demands new approaches. Regularly revisiting your shop's processes helps uncover inefficiencies or untapped potentials. Perhaps staff can benefit from new training, or a corner of the shop could be reconfigured for better traffic flow. A mindset open to feedback and experimentation ensures long-term resilience. Fostering a professional and collegial atmosphere. Behind every efficient workflow stands a cohesive team. Mutual respect, transparent communication, and recognition of each member's efforts cultivate a collegial environment. When conflicts or misunderstandings arise, a fair, solution-oriented approach keeps morale intact. Investing in staff well-being, through thoughtful breaks, clear career advancement paths, or modest perks, stabilizes the workforce and enriches overall productivity. Striking the right balance of innovation and tradition. Certain old-school methods, like a seasoned mechanic's knack for diagnosing by sound, remain invaluable. Yet the modern shop also wields digital tools and advanced diagnostics. Blending these traditions with innovation sets your business apart. Balancing computerized processes with human expertise fosters adaptability, reducing vulnerabilities if a system crashes or if an unusual classic car arrives in need of hands-on inspection. Sustaining a reputation for excellence. A well-organized, safety-conscious, and customer-centric environment does more than generate profits. It shapes how people view the entire automotive profession: honest, skillful, and progressive. When each repair is approached with care, transparency, and a commitment to improvement, your reputation solidifies. Customers return and spread the word, staff feel proud, and ultimately, the shop thrives. This positive cycle fuels enduring success in the automotive world. Through Lesson 9, we have explored how a well-structured shop environment, grounded in safety, teamwork, and continuous improvement, is essential for delivering exceptional service. By refining daily practices, from tool organization and regulatory compliance to maintaining strong client communication, an auto repair business can elevate both its internal culture and its public standing. With these insights, you gain a blueprint for fostering a workplace where expertise, integrity, and professionalism shine through each repair. Lesson 10: Basic Math and Measurements in Auto Repair. The foundation of math in automotive work. Why math skills matter on the shop floor. Mathematics underpins nearly every procedure in an automotive shop, from calculating torque settings to measuring fluid capacities. Even tasks that feel purely mechanical often demand basic arithmetic or conversions, such as ensuring a bolt is tightened to a specified inch-pound requirement or mixing coolant at the correct ratio. A technician who grows comfortable with math basics can approach repairs with greater confidence and accuracy, minimizing mistakes. Over time, these numerical proficiencies become second nature, shaping how one diagnoses, solves, and double-checks automotive tasks. Overcoming math anxiety. Many individuals enter the automotive field hoping to focus on practical, hands-on work, sometimes harboring apprehensions about math. However, the level of mathematics needed in a repair setting does not have to be intimidating. By breaking down calculations into smaller steps, such as recognizing which formula applies, or how to apply a conversion factor, technicians can tackle each challenge methodically. Building routine by practicing real-world scenarios helps banish math anxiety. As the skill grows, the sense of accomplishment also increases, paving the way for more intricate tasks with comfort. Linking concepts to mechanical reality. Seeing a formula on paper is one thing, but applying it to fix a misalignment or set a certain clearance fosters a more intuitive grasp of math. For example, understanding that a ratio of 12:1 in a mechanical lever system implies certain force advantages becomes clearer when that lever is a pry bar under a vehicle. Linking math concepts, like ratios, proportions, and geometric measurements, to tangible objects cements the knowledge in a context that is both memorable and meaningful. This synergy between theory and practice is where an automotive technician's math skills truly flourish. Building blocks of accuracy. A technician who can measure, calculate, and verify numeric results is less likely to guess or assume. Math serves as a backbone for precision, whether you are identifying the correct tire size, determining the total clearance for a new exhaust, or calculating a final drive ratio. These building blocks guard against common errors, like installing a mismatched part or incorrectly torquing critical fasteners, and help maintain the professional standards customers expect. Embracing these numerical building blocks fosters a culture of careful, quality-focused automotive work. Continuous improvement through practice. Just as a mechanic's skill with tools improves through repeated use, so too does math competency. An experienced technician calculates offsets and clearances swiftly because they have encountered similar calculations countless times. Rather than shying away from the math behind a procedure, proactively looking for chances to practice, such as checking the ratio on a gear set or verifying decimal placements for torque, accelerates progress. Technicians who challenge themselves with new tasks see gains not only in math skills but also in mechanical problem solving. Understanding units and conversions. Metric versus imperial systems. In an automotive context, a bolt might be measured in inches while a fluid capacity is specified in liters. Vehicles' origins, domestic or foreign, contribute to this dual usage. Mastering the interplay between metric and imperial units is fundamental. A 10 mm bolt is not the same diameter as a 3/8 inch bolt, and mixing the two can lead to stripped threads or poorly fitted fasteners. Recognizing whether torque is specified in foot-pounds or newton-meters helps you avoid over or under-tightening crucial components. Essential conversion factors. Common conversions in automotive work include inches to millimeters, quarts to liters, and foot-pounds to newton-meters. Having a small cheat sheet or memorized reference for these main conversions is invaluable when working in a fast-paced shop. For instance, 25.4 millimeters equals 1 inch, 1 liter equals roughly 1.06 quarts, and 1 foot-pound of torque is approximately 1.356 newton-meters. Regularly using these conversions strengthens your mental recall and reduces mistakes, especially in complex jobs requiring precise measurements. When and how to apply conversions. Conversions often come into play when a manufacturer's manual references one system and your tools read in another. If a torque specification lists 120 Nm, but your wrench is calibrated in FTLB, you must convert it properly. Or, you might discover a shop manual for an older domestic vehicle stating fluid capacity in quarts, but your new digital measuring device only reads liters. Learning the best times to convert, before you begin pouring fluids or applying torque, keeps tasks fluid and efficient. Pitfalls of incorrect conversions. A single miscalculation can lead to expensive, damaging errors. For instance, if a critical bolt is torqued to 120 ft-lb instead of 120 Nm, the difference can be substantial enough to damage threads. Similarly, overfilling an engine by misreading capacity in liters instead of quarts might cause foaming or blow-by. By double-checking conversions and verifying each value, technicians ensure they are meeting specification accurately, saving time, money, and potential liabilities. Utilizing digital tools while mental or paper-based calculations are valuable skills. Digital conversion apps and online calculators can supplement your capabilities. Many professional-level scan tools and shop software also include built-in conversion functions. These resources let you confirm cross-checks or handle less common conversions, for instance, bar to psi for turbo boost readings or degrees Celsius to Fahrenheit for temperature. The combination of fundamental math prowess and modern technology helps keep your shop agile and precise. Fractions, decimals, and ratios in the shop. Reading fractional tool sizes. Wrenches and sockets in imperial measurements typically come labeled with fractional sizes, 1/4, 3/8, 1/2, or 9/16 inch. Understanding how these fractions relate to each other ensures you do not accidentally pick a 7/16 socket when you need 1/2 inch. Translating them into decimal equivalents, like 0.5 inch for 1/2, can assist if you are measuring a bolt with calipers. Recognizing fraction equivalences lessens the risk of rounding or damaging fasteners, especially when parts are borderline in dimension. Decimals and precision measurements. Thickness gauges, bore gauges, or micrometers often read in decimals, such as 0.025 inch. Converting that to a fraction can be cumbersome, but being comfortable with decimal places allows you to interpret clearances or tolerances precisely. Should you measure a valve clearance at 0.008 inch but a spec calls for 0.010 inch, it's evident you are 0.002 inch out of range. Quick decimal recognition means you can calibrate or adjust settings on the fly. Ratio examples in gear sets. Automotive gear ratios define how many revolutions the output shaft makes for each revolution of the input. A ratio of 4:10:1 means the output rotates 4.1 times for every 1 revolution of the drive shaft, common in performance differentials. Grasping how to interpret such ratios helps you predict off-the-line acceleration versus cruising RPM. If a manual transmission lists gear ratios for each gear, like 3:83:1 in first gear, you can gauge potential torque multiplication or speed range. Fractional versus decimal brake measurements. When measuring brake rotor thickness, you might see a spec that calls for 1.010 inch as the minimum safe thickness, or perhaps 25.6 mm in a metric system. Technicians often convert whichever system the caliper reads into the manual spec format. Even a small fraction below the minimum can compromise stopping power. Decimals and fractions meet daily in these tasks, requiring fluid switching between both forms for accurate reading and reporting. Basic fraction and ratio operations. Adding or subtracting fractions is necessary if you measure multiple parts that stack up. For instance, installing washers or shims in a certain assembly might require a total thickness of 5/8 inch. If the washers come in 1/4 inch increments, you have to determine how many washers or what combination yields the correct total. Ratios come into play if you are mixing 2 parts water to 1 part coolant, demanding awareness of how each portion scales up or down. These simple operations are easy once you practice them on real automotive tasks. Torque and angular measurements. Understanding torque is a rotational force that turns or twists objects, measured commonly in foot-pounds, ft-lb, or newton-meters, Nm. When tightening cylinder head bolts or lug nuts, torque specs ensure the fasteners compress mating surfaces correctly. Too little torque risks a loose or leaky assembly, too much can strip threads or warp components. Being adept at torque readings and applying them precisely is vital for safe, reliable repairs. Converting inch-pounds and foot-pounds. Some smaller fasteners in transmissions or electronics might be specified in lb, while heavier-duty bolts, like lug nuts, use ft-lb. 1 foot-pound equals 12 inch-pounds, so if the manual calls for 120 nlb, that is 10 ft-lb. Similarly, you can reconvert foot-pounds back to inch-pounds for smaller torque wrenches. Mastering these conversions saves confusion, ensuring you reach the correct clamp force every time. Angular torque method. Some modern vehicles specify torque plus angle, or torque to yield, fasteners. After an initial torque, you might rotate the bolt another 90 degrees or 120 degrees. This approach ensures a consistent stretch in bolts for uniform clamping, particularly in cylinder heads or main bearings. Learning how to measure angles, using an angle gauge or marks on the bolt head, adds another layer of accuracy. A single missed degree can lead to uneven tension across a head gasket or bottom end. Practical tips for using torque wrenches. Calibration remains essential. Over time, a torque wrench can drift from its true reading. Storing it at the lowest setting, avoiding drops, and periodically checking it with a calibration service keeps it reliable. Additionally, pulling on a torque wrench smoothly rather than jerking helps dial in a consistent reading. For digital or click-type wrenches, hearing or feeling the final click or beep tells you to stop applying force. That tactile or audible cue is integral to preventing overtorque scenarios. Applying torque in tight spaces. Some bolts hide in cramped areas, making standard torque wrench usage challenging. Adaptations like flex head torque wrenches or crowsfoot adapters might help, but they also alter the lever arm. If you add an extension that shifts the torque pivot point, calculations are needed to maintain correct final torque. Recognizing how geometry affects torque readings ensures you do not unknowingly overstress or under-tighten fasteners in awkward spots. Simple geometry for automotive tasks. Measuring angles and alignments. Wheel alignments hinge on angles like camber, caster, and toe. Camber describes the tilt of the tire relative to vertical, while caster addresses the steering pivot angle. Understanding basic geometry, like how degrees or minutes of an angle affect tire wear, provides clarity when adjusting these settings. Similarly, any custom fabrication or bracket creation can require marking angles accurately so parts line up without binding. Calculating circumference and diameter. Tire circumference plays a role in speedometer readings and overall gear ratios. Knowing that circumference equals pi x diameter helps estimate how far a wheel travels per revolution. When switching to larger tires, the speedometer could display incorrect speeds unless recalibrated. Familiarity with this geometry helps you confirm final drive changes or troubleshoot odd shifts in ride height or speed. Visualizing triangles and structural supports. A frame or suspension component can act like a triangle, distributing loads in specific ways. If you shorten or lengthen one side, like adjusting a control arm, angles shift, altering handling or alignment. Comprehending how triangular structures handle stress clarifies why certain brackets or braces are angled. This mental model proves valuable for diagnosing bent frames after collisions or ensuring newly welded brackets align properly. Area and volume computation. Some custom jobs might involve cutting a piece of sheet metal to cover a floor pan or calculating how much trunk space an enclosure occupies. Knowing how to compute the area of a rectangle, length x width, or the volume of a rectangular box, length x width x height, keeps these tasks precise. Even fluid pans with angled sides can benefit from approximating volume using geometric breakdowns. Trigonometry and shaft alignments. For drivelines or PTO shafts, occasionally you must measure angles to confirm joints do not bind. A bit of basic trigonometry, like sine or cosine, helps determine the offset or parallel misalignment. If the manual states a universal joint must not exceed a 3-degree operating angle, you can measure the droop and link length, then use trig to confirm compliance. Though used less frequently, these calculations can be decisive in diagnosing vibration complaints. Volume, fluid quantities, and capacity calculations. Engine oil capacity in additive ratios. An engine may hold 5 quarts, 3 liters, of oil, so adding 4 quarts might underlubricate, while 5 quarts can cause foaming. Understanding fractional amounts ensures correct fill. For additives, Like zinc or friction modifiers, knowing how to measure out 1 ounce per quart or 10% of total volume is crucial. You might rely on a measuring cup or ratio-based formula, but accurate math yields the right mixture. Coolant mix percentages. A typical 50-50 coolant-to-water ratio provides balanced freeze/boil protection. If you want more freeze protection, you might move to a 60-40 ratio. Doing so requires measuring total capacity, subtracting any existing fluid, and calculating how much pure antifreeze to add. This approach ensures you do not inadvertently create a mixture too concentrated or too diluted, both of which can degrade performance. Brake and power steering fluid levels. Brake fluid reservoirs often have a max and min line. Interpreting fluid drops might require seeing how many ounces or milliliters to add to restore the recommended level. Overfilling can lead to spillage when pads retract, while underfilling triggers the brake warning light. Meanwhile, power steering systems sometimes require partial quarts. Knowing how to gauge exact amounts helps avoid repeated top-offs or spillage. Transmission fluid pan capacity. Automatic transmissions may hold 8 to 10 quarts in total, but a routine drain and fill might only remove 4 quarts while the rest remains in the converter or cooler lines. Doing repeated partial changes can approximate a near-complete fluid refresh. Calculating how many sequential drains get you close to the 8 or 10 quart total involves simple multiplication or ratio reasoning. This logical approach ensures proper final levels without guesswork. Calculating fuel efficiency and range. Although less directly a repair concern, customers may ask about fuel economy changes after certain modifications. Basic math can reveal that if a 15-gallon tank is used, and the vehicle achieves 20 miles per gallon, the maximum range is around 300 miles. Alternatively, if modifications drop efficiency to 18 miles per gallon, you might anticipate only 270 miles. Such calculations matter for trip planning or verifying a tune's effectiveness, bridging math with everyday driving realities. Electrical measurements and circuit calculations. Ohm's law. In automotive, Ohm's law states V equals I times R, voltage equals current times resistance. In diagnosing a faulty wire or sensor, you might measure voltage drop across a component. Recognizing that if the voltage is too low but the expected current is high, resistance or a poor ground could be at fault. This fundamental relationship guides everything from checking starter draw to testing the continuity of a tail light circuit. Using multimeters accurately. A multimeter can measure voltage, resistance, and current. Setting it to the correct range, like 20 V DC or ohm scale, prevents confusion or damage. For example, if you expect a 12 V battery but the meter is set to 200 V, readings might be less precise or overshadow important decimals. Understanding how to interpret the display, like 0.01 ohms or 12.6 volts, aligns with automotive specs. Parallel versus series circuits. Many vehicle systems wire components in parallel so that if one fails, others can continue functioning. Headlights or interior lights, for instance, remain unaffected by each other. However, some sensor arrays or older systems might incorporate series elements. Knowing the difference clarifies voltage distribution and helps you systematically test each component. Quick diagrams, referencing the job's wiring schematic, reduce guesswork. Calculating power and wattage. Wattage, power, is the product of voltage and current. P equals V times I. If a radio fuse frequently blows, you could measure how much current the head unit draws. Say it's 2 amps at 12 volts, that's 24 watts. If you install additional speakers or amplifiers that demand 100 watts, over 8 amps at 12 volts, the circuit must handle the extra load. Awareness of these numbers ensures you do not exceed fuse ratings or wire capacities. Battery state of charge. Automotive batteries measure around 12.6 V when fully charged. As they discharge, voltage drops accordingly. A reading of 12.2 V might indicate 50% charge, while below 12.0 V suggests a deeper discharge. Technicians who track these increments can predict if the battery can still reliably start the car or if it requires reconditioning. This simple measurement fosters quick judgments about charging system performance, bridging the gap between purely mechanical tasks and electrical diagnostics. Estimating and pricing with basic math. Calculating labor hours. Shops often rely on labor guides or experience to estimate how many hours a job might take. If a brake job is quoted at 1.5 hours per axle, and you are doing front and rear brakes, that's a total of 3.0 hours. Multiply that by your labor rate, say, $100 per hour, and you have $300 in labor. Accuracy in adding or modifying these hours for extra tasks preserves a transparent, fair pricing model. Marking up parts costs. When obtaining parts from a wholesaler, a shop might apply a markup to cover handling, ordering, and stocking. If your cost is $50 and you add a 30% markup, the retail price becomes $65. Knowing how to calculate these percentages quickly helps you quote customers promptly. Being able to break down the parts cost versus labor fosters trust and clarifies how the final invoice is constructed. Combining tax rates and fees. Different states or municipalities may levy taxes on parts, labor, or both. Adding the correct tax rate, like 8%, to the sum of parts ensures compliance with local laws. You might also need to incorporate environmental disposal fees or shop supply charges. Each of these line items must be correctly computed as percentages or flat fees to yield a final, accurate total on the invoice. Discount application. Promotions or loyalty discounts require subtracting a certain percentage from the labor or parts total. If a service advisor offers a 10% discount on a $200 repair, you reduce the price by $20, finalizing at $180. Alternatively, if a coupon states $30 off on any brake job, that's a simple direct subtraction from the labor portion. Keeping discount calculations straightforward helps customers see the real savings without confusion. Reconciling invoices and profits. At the end of the day, verifying that the total parts expense and labor hours match the revenue gained ensures the shop remains profitable. Subtracting overhead, rent, utilities, and wage costs demands fundamental arithmetic. Monitoring these figures indicates if certain repairs are more lucrative or if you are undercharging. By using consistent math practices for pricing and reconciliation, a shop can grow sustainably and mitigate financial risk. Measurement tools and best practices. Calipers and micrometers for checking brake rotor thickness or measuring small components like piston diameters. Calipers and micrometers offer high precision. Digital versions provide direct readings, while analog ones require technicians to interpret scales carefully. Ensuring the tool jaws are clean and calibrating them occasionally fosters accurate measurements. A fraction of an inch or millimeter difference can be critical in performance or wear specifications. Dial indicators and runout measurements. Wobbling brake rotors or driveshafts might show runout beyond permissible limits. A dial indicator attaches to a fixed point while the component rotates, measuring deflection in thousandths of an inch. Understanding how to set zero and interpret dial movements is key. A reading of 0.003 inch runout may be acceptable, but 0.015 inch might produce noticeable vibration. Dial indicators transform small numeric deviations into actionable data. Tape measures and rulers in shop work. From marking alignment reference points to measuring the length of exhaust pipes, tape measures remain a staple. Reading them properly, recognizing the fraction increments or the metric scale, makes tasks simpler. If you need to cut a piece of steel to exactly 25 3/4 inches, a firm understanding of fractional breakdown ensures no second cuts are needed. Similarly, a ruler or measuring stick can confirm ride heights or ground clearance differences quickly. Infrared thermometers. Diagnosing overheating or checking bearing temps can involve an infrared (IR) thermometer. It instantly reads surface temperature, providing insight into whether a brake rotor is running hotter than normal or if an engine coolant hose might be blocked. Temperature data can highlight blockages or friction. Keeping units consistent, either Celsius or Fahrenheit, helps align with OEM specs or typical shop readings. Caring for and storing precision tools. Precision instruments lose accuracy if dropped, exposed to excessive moisture, or left with debris on measuring surfaces. Micrometers need occasional lubrication, and calibration blocks keep their 0 points valid. Storing them in protective cases away from random clutter reduces the chance of accidental knocks. A tidy, methodical approach preserves the lifespan of measurement tools, reinforcing the accuracy your jobs demand. Real-world applications and problem-solving. Diagnosing a tire size mismatch. A vehicle might come in with an ABS warning light after new tires were fitted. By comparing the new tire's diameter to the OEM recommended size, you can confirm if the difference is enough to trigger sensor issues. With circumference calculations or direct measured differences, you reveal that a tire too large or small can fool the wheel speed sensor. Correcting that mismatch or recalibrating the system solves the problem, showcasing how math unravels practical dilemmas. Determining custom exhaust bends. A performance enthusiast might want a custom exhaust routing. You measure angles to avoid suspension components, then use geometry to figure out bend degrees and pipe length. The ratio of pipe diameter to clearance helps you ensure adequate flow without interfering with crossmembers or the driveshaft. Translating these measured insights into a final welded system exemplifies how math meets fabrication artistry. Checking compression ratios. Engine builders sometimes want to verify compression ratios, factoring in cylinder volume at bottom dead center versus top dead center. Lessons in units, fractions, decimals, and geometry all weave naturally into daily tasks, tightening bolts, calibrating angles, mixing fluids, or verifying clearances. This fusion of hands-on mechanics with analytical calculations elevates the quality of repairs, leading to fewer comebacks and higher customer satisfaction. As you refine these math skills, you unlock greater diagnostic acuity, efficient workflows, and the confidence to tackle even the most challenging automotive puzzles. Lesson 11: Technical Manuals and Service Information. A comprehensive guide to utilizing technical resources for effective automotive repair. The importance of technical manuals in automotive repair. Understanding the role of technical manuals. Technical manuals are indispensable tools in the automotive repair industry, serving as comprehensive guides that provide detailed information about a vehicle's systems, components, and repair procedures. These manuals ensure that technicians have access to accurate and manufacturer-approved data, which is crucial for diagnosing issues, performing maintenance, and executing repairs correctly. By following the instructions outlined in technical manuals, technicians can maintain high standards of quality and consistency in their work, minimizing the risk of errors that could lead to vehicle malfunctions or safety hazards. Types of technical manuals. There are several types of technical manuals available to automotive technicians, each serving a unique purpose. Factory Service Manuals, FSMs, are produced by vehicle manufacturers and offer the most detailed and accurate information for specific makes and models. Aftermarket Service Manuals, such as those published by Haynes or Chilton, provide broader coverage and are often more affordable, making them popular among independent shops. Additionally, digital manuals and online databases offer interactive features and regular updates, enhancing accessibility and ease of use. Understanding the differences between these types of manuals allows technicians to select the most appropriate resource for each repair scenario. Accessing manufacturer service information. Manufacturers provide service information through various channels, including official websites, dedicated portals, and subscription-based services. This information often includes service bulletins, SBs, and technical service bulletins, TSBs, which address known issues and provide recommended solutions for specific vehicle models. Access to this information typically requires registration and may be restricted to authorized dealers or certified technicians. By utilizing these resources, technicians can stay informed about the latest updates, recalls, and repair procedures, ensuring that they are equipped to handle emerging vehicle issues effectively. Utilizing aftermarket service resources. Aftermarket service resources complement manufacturer-provided manuals by offering additional insights and alternative repair methods. Publications from companies like Haynes and Chilton are widely recognized for their comprehensive coverage and user-friendly formats. Online platforms such as AllData and Mitchell 1 provide extensive databases of service information, including wiring diagrams, diagnostic procedures, and parts catalogs. These resources enhance a technician's ability to diagnose and repair vehicles accurately, especially when dealing with multiple makes and models in a diverse workshop environment. Integrating digital tools and software. The advent of digital technology has revolutionized the way technicians access and utilize service information. Diagnostic software and digital repair manuals enable real-time data access and interactive troubleshooting, streamlining the repair process. Tools like augmented reality, AR, and virtual reality, VR, manuals offer immersive learning experiences, allowing technicians to visualize complex repairs before executing them. Additionally, mobile applications provide on-the-go access to repair guides, parts information, and service updates, enhancing flexibility and responsiveness in the workshop. Navigating and interpreting technical manuals. Reading and understanding service procedures. Service manuals are meticulously structured to guide technicians through various repair and maintenance tasks. Each manual typically begins with an introduction that outlines safety precautions and general information about the vehicle. Subsequent sections provide detailed descriptions of each system, such as the engine, transmission, electrical, and braking systems, followed by step-by-step repair procedures. These procedures include torque specifications, calibration settings, and the sequence of operations necessary to perform tasks accurately. Mastering the ability to read and understand these procedures is fundamental for executing repairs that meet or exceed manufacturer standards. Interpreting diagrams and schematics. Technical manuals are rich with diagrams and schematics that provide visual representations of a vehicle's components and their interactions. Wiring diagrams illustrate the electrical connections between various parts, enabling technicians to diagnose and repair electrical faults efficiently. Mechanical schematics depict the arrangement and movement of mechanical components, aiding in the identification of issues such as misalignments or worn parts. Understanding how to interpret these visual tools is essential for accurate diagnostics and effective repairs, as they offer a clear blueprint of the vehicle's intricate systems. Understanding torque specifications and calibration. Proper torque application is critical in automotive repairs to ensure that fasteners are tightened to the manufacturer's specifications. Technical manuals provide precise torque values for various bolts and nuts, along with calibration procedures for torque wrenches. Calibration ensures that torque tools are accurate and reliable, preventing under-tightening or over-tightening that can lead to component failure or safety hazards. Additionally, manuals often include sequential tightening patterns for components like cylinder heads and wheel hubs, which distribute clamping force evenly and maintain structural integrity. Using indexes and search functions effectively. Technical manuals contain a wealth of information, making effective navigation essential for efficient repairs. Utilizing the index allows technicians to quickly locate specific topics, parts, or procedures by referencing keywords or part numbers. Digital manuals and online databases enhance this capability with search functions that enable keyword queries and quick access to relevant sections. Mastering these navigation techniques reduces time spent searching for information, allowing technicians to focus more on the repair tasks at hand and improving overall workflow efficiency. Keeping manuals updated. Automotive technology is continuously evolving, necessitating regular updates to technical manuals to reflect the latest advancements and changes in repair procedures. Technicians must ensure that they have access to the most recent versions of manuals by subscribing to manufacturer updates or regularly acquiring new editions. Digital platforms often provide automatic updates, ensuring that service information remains current without the need for manual intervention. Staying updated with the latest manuals is crucial for maintaining repair accuracy and adhering to the most recent industry standards. Leveraging service information for advanced diagnostics. Utilizing diagnostic trouble codes, DTCs, modern vehicles are equipped with sophisticated electronic control units, ECUs, that monitor various systems and components. When a malfunction is detected, the ECU generates diagnostic trouble codes, DTCs, that help technicians identify the source of the problem. Service manuals provide detailed explanations of each DTC, including the systems involved and potential causes. By accurately retrieving and interpreting these codes using diagnostic tools, technicians can streamline the diagnostic process and target repairs more effectively, reducing guesswork and improving repair accuracy. Reference to Technical Service Bulletins, TSBs. Technical Service Bulletins, TSBs, are issued by manufacturers to address known issues and provide standardized repair procedures for specific problems encountered in their vehicles. These bulletins often include detailed instructions for diagnosing and fixing recurring issues, such as electrical malfunctions or mechanical defects. By consulting relevant TSBs, technicians can apply manufacturer-recommended solutions, ensuring that repairs are consistent with the latest updates and effectively resolving issues that may not be covered in standard service manuals. Accessing factory training and webinars. Manufacturers frequently offer specialized training programs and webinars to keep technicians informed about new technologies, repair techniques, and updates to service procedures. These training sessions provide in-depth knowledge and hands-on experience with the latest vehicle systems and diagnostic tools. Participating in factory training enhances a technician's expertise, enabling them to handle complex repairs with greater confidence and efficiency. Additionally, these training resources often include access to exclusive service information and advanced diagnostic methods that are not available in standard manuals. Collaborating with manufacturer representatives. Building relationships with manufacturer representatives can provide valuable support and access to specialized resources. Representatives can offer expert guidance on complex repairs, provide insights into new vehicle technologies, and facilitate access to the latest service information and tools. Collaborating with these representatives ensures that technicians have a direct line to manufacturer expertise, which can be instrumental in resolving difficult diagnostic challenges and staying ahead of industry developments. Implementing advanced diagnostic procedures. Advanced diagnostic procedures outlined in technical manuals and service bulletins enable technicians to tackle more complex issues with precision. These procedures often involve multiple steps, including the use of specialized diagnostic equipment, detailed system tests, and iterative troubleshooting methods. By following these comprehensive diagnostic protocols, technicians can accurately identify root causes of problems, implement effective repairs, and verify the success of their interventions, ensuring that vehicles operate reliably and safely after service. Maintaining and updating technical knowledge. Regularly reviewing new service bulletins and manuals. Staying current with the latest service bulletins and technical manuals is essential for maintaining expertise in automotive repair. Technicians should allocate time regularly to review updates from manufacturers, including new repair procedures, recall information, and changes to diagnostic protocols. This ongoing education ensures that technicians are equipped with the most up-to-date knowledge, enabling them to handle emerging vehicle issues effectively and maintain high standards of service quality. Organizing and managing manual libraries. An organized library of technical manuals is crucial for efficient workshop operations. Technicians should categorize manuals by vehicle make, model, and year, making it easy to locate relevant information quickly. Implementing a digital inventory system can further enhance accessibility, allowing technicians to search for specific manuals or sections electronically. Proper organization reduces time spent searching for information, streamlines the repair process, and ensures that technicians have immediate access to the resources they need to perform accurate and efficient repairs. Encouraging knowledge sharing among technicians. Fostering a culture of knowledge sharing within the workshop enhances the collective expertise of the team. Technicians should be encouraged to share insights, discuss challenging repairs, and collaborate on complex diagnostic tasks. Regular team meetings, workshops, and informal discussions provide opportunities for technicians to learn from each other's experiences and expertise. This collaborative environment not only improves individual skills but also promotes a more cohesive and effective repair team, capable of handling a diverse range of vehicle issues with confidence. Leveraging technology for enhanced learning. Integrating modern technologies into learning processes can significantly boost a technician's understanding and retention of technical information. Interactive digital manuals, simulation software, and virtual reality (VR) training modules offer immersive and engaging ways to learn complex repair procedures and vehicle systems. These technologies provide hands-on experience in a controlled environment, allowing technicians to practice and refine their skills without the risk of damaging actual vehicles. Embracing these advanced learning tools enhances technical proficiency and prepares technicians to handle the latest automotive technologies with ease. Participating in professional development programs. Engaging in professional development programs, such as certification courses and specialized training seminars, is vital for continuous growth in the automotive repair field. Certifications from recognized organizations like the National Institute for Automotive Service Excellence, ASE, validate a technician's expertise and commitment to excellence. Participating in these programs not only enhances technical skills but also opens up opportunities for career advancement and specialization in specific areas of automotive repair. Investing in professional development ensures that technicians remain competitive and knowledgeable in an ever-evolving industry. Practical applications and case studies. Diagnosing an intermittent starting issue. A customer reports that their vehicle occasionally fails to start. Utilizing the service manual, the technician begins by retrieving any stored diagnostic trouble codes, DTCs, using a scan tool. The codes indicate a sporadic fault in the ignition system, specifically pointing to the ignition coil. Following the step-by-step diagnostic procedures in the manual, the technician tests the ignition coil's resistance and inspects the wiring harness for any signs of wear or damage. By systematically eliminating potential causes, the technician identifies a faulty ignition coil and replaces it, resolving the intermittent starting issue and ensuring reliable vehicle operation. Performing a torque-to-yield head bolt replacement. Torque-to-yield, TTY, head bolts require specific procedures for removal and installation to ensure proper clamping force and engine integrity. The service manual outlines the precise torque values and angles for tightening new TTY bolts. The technician begins by loosening and removing the old bolts, carefully following the manual's instructions to prevent damage. Using a calibrated torque wrench and angle gauge, the technician installs the new bolts, applying the specified torque followed by the required rotational angle. This meticulous process ensures that the cylinder head is secured correctly, preventing leaks and maintaining optimal engine performance. Addressing ABS system malfunctions. A vehicle's anti-lock braking system, ABS, warning light is illuminated, indicating a malfunction. The technician references the service manual to retrieve the specific DTCs related to the ABS system. The codes point to a faulty wheel speed sensor on the front right axle. Consulting the wiring diagrams, the technician inspects the sensor's electrical connections and tests its functionality using a multimeter. After confirming the sensor is defective, the technician replaces it with a new unit, clears the DTCs, and verifies that the ABS warning light is no longer active. This targeted approach ensures that the ABS system operates correctly, maintaining vehicle safety. Calculating engine compression ratios. An engine is experiencing poor performance and misfires. To diagnose the issue, the technician decides to check the engine's compression ratios. Using the service manual specifications, the technician measures the compression pressure in each cylinder with a compression tester. The readings reveal significantly lower compression in cylinder 4 compared to the others. Referring to the service manual's troubleshooting guide, the technician inspects the valve seals, piston rings, and head gasket for potential leaks. Upon finding worn piston rings in cylinder 4, the technician replaces them, restoring proper compression and resolving the engine's performance issues. Evaluating brake rotor lateral runout. A customer complains of steering wheel vibrations when braking. The technician suspects excessive lateral runout in the brake rotors. Following the service manual's procedure, the technician uses a dial indicator to measure the runout of each rotor. The measurements reveal that the front left rotor has a runout of 0.005 inches, exceeding the manufacturer's specification of 0. 0.002 inches. Based on the service manual's recommendations, the technician decides to resurface the rotor. After machining, the technician rechecks the runout to ensure it is within acceptable limits. The resurfaced rotor eliminates the vibrations, enhancing the vehicle's braking performance and ride comfort. Replacing a failing oxygen sensor. A vehicle exhibits a noticeable drop in fuel efficiency and emits a strong smell of exhaust fumes. The service manual indicates that the oxygen sensor plays a crucial role in regulating the air-fuel mixture. Following the diagnostic steps, the technician locates the malfunctioning oxygen sensor as indicated by the DTCs. Using the wiring diagrams, the technician identifies the correct sensor location and disconnects the electrical connector. Carefully removing the old sensor with an oxygen sensor socket, the technician installs the new unit, ensuring it is securely fastened and properly connected. After clearing the DTCs and testing the vehicle, fuel efficiency returns to normal, and exhaust odors are eliminated. Diagnosing a faulty mass airflow sensor. A customer reports that their vehicle hesitates during acceleration and struggles to maintain speed. The service manual highlights the mass airflow (MAF) sensor as a potential culprit affecting engine performance. The technician uses the service manual's diagnostic procedures to test the MAF sensor's functionality, including voltage output and airflow readings. Upon identifying inconsistent readings, the technician inspects the sensor for dirt or damage. Cleaning the MAF sensor with approved cleaner resolves the issue, restoring smooth acceleration and stable engine performance. Repairing a malfunctioning fuel injector. An engine misfire persists despite other components functioning correctly. The service manual guides the technician to inspect the fuel injectors as a potential source of the problem. Using a Noid light to test injector pulses and a fuel pressure gauge to verify system pressure, the technician identifies a clogged injector causing the misfire. Cleaning the injector with specialized cleaning tools and replacing worn seals restores proper fuel delivery, eliminating the misfire and improving engine performance. Calibrating a rearview camera system. A modern vehicle equipped with a rearview camera experiences intermittent display issues and inaccurate distance measurements. The service manual provides detailed calibration procedures for the camera system, including alignment and software settings. Following the manual's instructions, the technician adjusts the camera angle and recalibrates the system using diagnostic software. After completing the calibration steps, the rearview camera operates correctly, providing accurate distance measurements and reliable display functionality. Performing a software update on the ECU. A vehicle exhibits persistent sensor errors and suboptimal engine performance despite hardware components being in good condition. The service manual indicates that a software update for the engine control unit, ECU, can resolve these issues. Connecting the diagnostic tool to the vehicle's OBD2 port, the technician accesses the ECU's software update section. Following the step-by-step instructions in the manual, the technician downloads and installs the latest firmware, ensuring compatibility and functionality. Post-update testing confirms the resolution of sensor errors and improved engine performance. Advanced reference tools and supplemental resources using parts catalogs and cross-reference guides. Parts catalogs provide detailed information about the components used in specific vehicle models, including part numbers, specifications, and compatibility information. By employing these diagnostic tools, technicians can perform more accurate and comprehensive diagnostics, access manufacturer-specific information, and ensure that repairs are conducted in line with the latest technical specifications. Mastery of these tools is essential for technicians working on modern, technology-rich vehicles. Accessing proprietary repair information. In addition to standard service manuals, manufacturers often offer proprietary repair information that is accessible only to authorized technicians or dealerships. This information may include detailed schematics, advanced diagnostic procedures, and specialized repair techniques not available in general service manuals. Accessing and utilizing proprietary repair information allows technicians to perform high-level repairs that require intimate knowledge of specific vehicle systems, thereby expanding their expertise and enhancing their capability to handle complex automotive issues. Utilizing multimedia learning resources, such as instructional videos, webinars, and interactive tutorials, provide dynamic and engaging ways for technicians to learn and reference repair procedures. Videos can demonstrate complex tasks step by step, offering visual guidance that complements written manuals. Interactive tutorials and simulations allow technicians to practice repairs in a virtual environment, reinforcing their understanding and proficiency. By integrating multimedia resources into their learning and reference routines, technicians can enhance their comprehension and execution of intricate repair tasks, leading to higher quality service outcomes. Safety and best practices when using technical manuals. Understanding safety warnings and precautions. Technical manuals include critical safety warnings and precautions to protect technicians during repairs. These warnings highlight potential hazards, such as electrical shocks, chemical exposures, or mechanical injuries, associated with specific tasks or components. By thoroughly reviewing and adhering to these safety guidelines, technicians can minimize the risk of accidents and ensure a safe working environment. Incorporating these precautions into daily practices reinforces a culture of safety and responsibility within the workshop. Handling hazardous information responsibly. Service manuals contain sensitive information about vehicle systems and repair procedures that must be handled responsibly. Technicians should follow protocols for accessing, storing, and sharing this information to prevent unauthorized dissemination or misuse. This responsibility extends to maintaining the confidentiality of proprietary data and adhering to intellectual property laws. Proper handling of hazardous information safeguards the integrity of the workshop's operations and respects the rights of vehicle manufacturers. Maintaining focus and avoiding misinterpretation. Technical manuals present detailed and sometimes complex information that requires careful interpretation. Technicians must maintain focus while reading and avoid misinterpreting instructions or diagrams, which can lead to improper repairs or safety issues. Taking the time to thoroughly understand each step, cross-referencing sections when necessary, and seeking clarification on unclear points are essential best practices. By maintaining attentiveness and precision, technicians can execute repairs accurately and uphold high-quality standards. Ensuring confidentiality of proprietary information. Proprietary information contained within service manuals and manufacturer bulletins must be kept confidential to protect the intellectual property of vehicle manufacturers. Technicians should ensure that manuals are stored securely and that digital access is restricted to authorized personnel only. Avoiding the unauthorized distribution or sharing of proprietary information preserves the trust between workshops and manufacturers, and helps maintain the integrity of the repair process. Implementing safety protocols in repairs. In addition to following safety guidelines in manuals, technicians should implement comprehensive safety protocols during repairs. This includes using appropriate personal protective equipment, PPE, maintaining a clean and organized workspace, and following safe lifting and handling practices. Integrating these protocols into daily operations not only protects technicians but also ensures that repairs are conducted in a methodical and risk-averse manner, contributing to overall workshop safety and efficiency. Troubleshooting complex systems using manuals. Diagnosing electrical systems issues. Electrical systems in modern vehicles are intricate and interconnected, making diagnosis challenging without the proper resources. Service manuals provide detailed wiring diagrams, component locations, and diagnostic procedures for identifying electrical faults. Technicians can use these manuals to systematically test circuits, verify sensor functionality, and trace wiring paths to locate issues such as short circuits, open circuits, or faulty sensors. Accurate diagnosis of electrical problems ensures that repairs address the root cause, restoring proper vehicle functionality and preventing recurring issues. Addressing engine management problems. Engine management systems control critical functions such as fuel injection, ignition timing, and emission controls. Service manuals offer comprehensive information on engine control modules, ECMs, sensor specifications, and calibration procedures. When faced with engine management problems, technicians can refer to these manuals to perform precise diagnostics, adjust calibration settings, and replace faulty components. Understanding the nuances of engine management systems through service manuals allows technicians to optimize engine performance, reduce emissions, and enhance overall vehicle reliability. Repairing transmission and drivetrain systems. Transmission and drivetrain systems are vital for vehicle performance and efficiency. Service manuals provide in-depth procedures for diagnosing and repairing issues related to gear shifting, torque conversion, and power distribution. Detailed instructions for fluid changes, seal replacements, and component adjustments guide technicians in maintaining and restoring the functionality of these complex systems. By following the structured repair protocols in service manuals, technicians can ensure smooth transmission operations and prevent costly drivetrain failures. Fixing HVAC system faults. Heating, ventilation, and air conditioning (HVAC) systems require precise calibration and maintenance to function correctly. Service manuals include detailed service procedures for diagnosing and repairing HVAC issues, such as faulty compressors, refrigerant leaks, or sensor malfunctions. Technicians can refer to these manuals to perform tasks like refrigerant charging, system flushing, and component replacement, ensuring that the HVAC system operates efficiently and provides optimal climate control for the vehicle occupants. Accurate repair of HVAC systems enhances vehicle comfort and customer satisfaction. Restoring Advanced Driver Assistance Systems (ADAS). Advanced Driver Assistance Systems (ADAS) encompass technologies like lane departure warnings, adaptive cruise control, and automatic emergency braking. These systems rely on a network of sensors, cameras, and control units that require precise calibration and alignment. Service manuals provide specific instructions for diagnosing ADAS faults, performing sensor calibrations, and updating software to restore functionality. Technicians equipped with the knowledge and resources outlined in service manuals can effectively troubleshoot and repair ADAS components, ensuring that these safety features operate as intended and contribute to the vehicle's overall safety. Quality assurance and verification. Using technical manuals. Performing post-repair testing. After completing a repair, it is essential to perform post-repair testing to ensure that the issue has been fully resolved and that all systems are functioning correctly. Service manuals outline specific testing procedures and performance benchmarks that technicians must follow to verify the success of their repairs. This includes running diagnostic scans, performing road tests, and measuring system outputs against manufacturer specifications. Thorough post-repair testing ensures that the vehicle is safe, reliable, and meets the quality standards expected by customers. Verifying system functionality. Service manuals provide detailed instructions for verifying the functionality of repaired systems. This involves checking operational parameters, sensor readings, and system responses to confirm that repairs have been executed correctly. Technicians can use the verification steps outlined in the manuals to assess the performance of components such as engine sensors, braking systems, and electrical circuits. By systematically verifying system functionality, technicians ensure that all repairs have restored the vehicle to optimal operating conditions. Ensuring compliance with standards. Adhering to industry standards and manufacturer specifications is crucial for maintaining the integrity and reliability of automotive repairs. Service manuals include specifications for torque settings, fluid types, and component tolerances that technicians must follow. Ensuring compliance with these standards guarantees that repairs are performed correctly and safely, preventing future issues and maintaining the vehicle's performance and longevity. Compliance also reinforces the technician's professionalism and commitment to quality service. Conducting final inspections based on manuals. Final inspections are a critical step in the repair process, ensuring that all tasks have been completed to the highest standards. Service manuals provide checklists and inspection guidelines that technicians can use to conduct comprehensive final inspections. This includes verifying that all fasteners are torqued correctly, fluids are filled to the proper levels, and all components are installed as per the manual specifications. Conducting thorough final inspections based on service manuals helps prevent oversights and ensures that the vehicle is ready for customer return with confidence. Gathering feedback for continuous improvement. Feedback mechanisms, such as customer reviews and internal quality assessments, are essential for continuous improvement in automotive repair. Service manuals can guide the creation of standardized feedback forms and evaluation criteria, allowing technicians to gather valuable insights into the effectiveness of their repairs. By analyzing feedback and comparing it against the procedures outlined in the manuals, technicians can identify areas for improvement, refine their repair techniques, and enhance overall service quality. This commitment to continuous improvement fosters a culture of excellence and ensures that the workshop consistently delivers high-quality automotive services. Conclusion: mastering technical manuals for superior automotive service. Integrating manual knowledge into daily practice. Technical manuals are not merely reference materials, they are integral to every aspect of automotive service. By systematically incorporating manual knowledge into daily routines, technicians can enhance diagnostic precision, ensure repair accuracy, boost efficiency, and elevate customer trust. Utilizing detailed procedures and adhering to manufacturer specifications transforms routine tasks into high-quality repairs, fostering a professional environment where excellence is the standard. Committing to lifelong learning and adaptation. The automotive landscape is ever-evolving, with new technologies and methodologies continually emerging. To remain proficient and competitive, technicians must embrace a mindset of lifelong learning and adaptation. Staying curious, pursuing ongoing education, embracing technological advancements, and fostering a growth mindset are essential for maintaining expertise and meeting the challenges of modern automotive repair. This commitment ensures that technicians can handle the vehicles of today and tomorrow with confidence and skill. Upholding professional standards through technical mastery. Mastery of technical manuals and service information upholds the highest standards of professionalism in the automotive industry. It reflects a dedication to quality service, safety, integrity, and reliability. By excelling in the use of these resources, technicians contribute to a culture of excellence that defines reputable automotive service shops. This mastery not only enhances individual skills but also strengthens the overall reputation and success of the workshop, ensuring long-term customer satisfaction and business sustainability. Through Lesson 11, you have delved into the critical role of technical manuals and service information in automotive repair. By mastering the use of these resources, interpreting complex diagrams, and staying updated with the latest service bulletins and training, you enhance your diagnostic and repair capabilities. This proficiency not only ensures accurate and efficient vehicle servicing but also builds trust and credibility with customers. Embrace the knowledge contained within technical manuals as a vital tool in your journey toward becoming a skilled and respected automotive professional. Lesson 12: Automotive Communication and Customer Service. A comprehensive guide to effective communication and exceptional customer service in automotive repair. The foundation of automotive communication. Understanding the importance of communication in automotive repair. Effective communication is the backbone of any successful automotive repair business. It bridges the gap between technicians and customers, ensuring that vehicle issues are accurately understood and addressed. Clear communication fosters trust, enhances customer satisfaction, and reduces the likelihood of misunderstandings that can lead to disputes or dissatisfaction. By mastering communication skills, automotive professionals can create a positive and efficient service experience, encouraging repeat business and positive word-of-mouth referrals. Types of communication in the automotive industry. Communication in the automotive industry encompasses various forms, each serving a distinct purpose. Verbal communication occurs during face-to-face interactions, phone calls, and video consultations, allowing for real-time dialogue and immediate feedback. Written communication includes emails, text messages, service reports, and invoices, providing a documented trail of interactions and agreements. Nonverbal communication, such as body language and visual aids like diagrams or photos, plays a crucial role in conveying information effectively. Understanding and utilizing each type appropriately enhances overall communication effectiveness and customer relationships. Barriers to effective communication. Several barriers can impede effective communication in the automotive repair setting. Language differences, technical jargon, and varying levels of customer understanding can create misunderstandings. Additionally, environmental factors such as noise in the workshop or distractions during conversations can disrupt communication flow. Personal barriers, including biases or emotional states, can also affect how messages are sent and received. Recognizing and addressing these barriers is essential for maintaining clear and productive communication channels, ensuring that both technicians and customers are on the same page regarding service expectations and outcomes. The role of active listening is a fundamental component of effective communication. It involves fully concentrating, understanding, responding, and remembering what the customer is saying. By practicing active listening, technicians can accurately identify customer concerns, ask pertinent questions, and demonstrate empathy and respect. This not only helps in diagnosing vehicle issues more accurately but also makes customers feel valued and heard, thereby enhancing their overall service experience. Techniques such as paraphrasing, summarizing, and providing feedback are integral to active listening and should be consistently employed in all customer interactions. Building rapport with customers is essential for establishing trust and fostering long-term relationships. Simple gestures like greeting customers warmly, maintaining eye contact, and using their names can significantly enhance the rapport-building process. Showing genuine interest in their concerns and expressing empathy towards their situations further strengthens this connection. A positive rapport encourages open communication, making customers more comfortable sharing detailed information about their vehicle issues, which in turn facilitates more accurate diagnostics and effective repairs. Effective communication strategies. Clear and concise explanations. Technicians must be able to explain complex automotive issues and repair procedures in a clear and concise manner. Avoiding excessive technical jargon ensures that customers can easily understand the information being conveyed. Utilizing analogies or relatable examples can help bridge the knowledge gap, making technical details more accessible. Clear explanations not only aid in customer comprehension but also enhance their confidence in the technician's expertise and the proposed solutions. Tailoring communication to customer knowledge levels. Customers come with varying degrees of automotive knowledge. Tailoring communication to match their understanding is crucial for effective information transfer. For novice customers, simplifying explanations and focusing on the most relevant details can prevent confusion and overwhelm. For more knowledgeable customers, providing detailed technical information and engaging in in-depth discussions can satisfy their curiosity and demonstrate the technician's proficiency. Adapting communication styles to meet individual customer needs ensures that all interactions are productive and meaningful. Utilizing visual aids and demonstrations. Visual aids such as diagrams, photos, and videos can significantly enhance communication by providing tangible references for complex concepts. Demonstrations, whether live or through multimedia presentations, allow customers to see the issues firsthand and understand the proposed repairs. These tools help in illustrating the problem areas, the steps involved in the repair process, and the benefits of the recommended solutions. Incorporating visual aids not only clarifies technical information but also engages customers more effectively, making the communication process more interactive and informative. Managing customer expectations. Setting and managing customer expectations is vital for ensuring satisfaction and preventing misunderstandings. Technicians should provide realistic timelines for repairs, clearly outline the scope of work, and transparently discuss potential costs. Addressing possible delays or unforeseen issues proactively helps in maintaining trust and minimizing frustration. By managing expectations effectively, technicians can align their service delivery with customer desires, fostering a positive and reliable service reputation. Handling difficult conversations. In the automotive repair industry, technicians may encounter challenging situations, such as addressing unexpected repair costs, delays, or dissatisfied customers. Handling these conversations with professionalism and empathy is essential for maintaining positive customer relationships. Techniques such as staying calm, actively listening, acknowledging the customer's concerns, and offering practical solutions can help in resolving conflicts amicably. Effective management of difficult conversations not only mitigates immediate issues but also reinforces the customer's trust and loyalty to the repair shop. Enhancing customer service skills. Developing empathy and understanding. Empathy involves recognizing and sharing the feelings of others. In customer service, demonstrating empathy helps in building strong relationships by showing customers that their concerns are genuinely understood and valued. Technicians should strive to put themselves in the customer's shoes, acknowledging their frustrations or anxieties related to vehicle issues. This empathetic approach fosters a supportive environment where customers feel comfortable expressing their needs and concerns, leading to more effective and satisfying service interactions. Professionalism in customer interactions. Maintaining professionalism in all customer interactions is crucial for establishing credibility and trust. This includes being punctual, dressing appropriately, using polite language, and showing respect towards customers at all times. Professionalism extends to following through on promises, maintaining a clean and organized workspace, and handling customer feedback constructively. By upholding high standards of professionalism, technicians can enhance the overall customer experience and reinforce the reputation of the repair shop as a trustworthy and reliable service provider. Effective problem-solving techniques. Problem-solving is a critical skill in both technical diagnostics and customer service. Technicians must be able to identify the root causes of vehicle issues and develop effective solutions while simultaneously addressing any customer concerns or questions. Employing systematic problem-solving techniques, such as the scientific method or root cause analysis, ensures that repairs are thorough and effective. Additionally, being proactive in identifying potential issues and offering preventive solutions can enhance customer satisfaction and trust in the technician's expertise. Building long-term customer relationships. Cultivating long-term relationships with customers leads to repeat business and positive referrals. Technicians can achieve this by consistently providing high-quality service, following up with customers post-repair, and offering loyalty incentives or discounts. Personalized communication, such as remembering a customer's vehicle history or preferences, also contributes to a sense of personalized service. Building these long-term relationships not only drives business growth but also fosters a loyal customer base that values the repair shop's commitment to their automotive needs. Utilizing customer feedback for improvement. Customer feedback is a valuable resource for identifying areas of improvement and enhancing service quality. Technicians should actively seek feedback through surveys, reviews, or direct conversations and use this information to refine their service processes and communication strategies. Addressing negative feedback promptly and effectively demonstrates a commitment to customer satisfaction and continuous improvement. By leveraging customer feedback, repair shops can adapt to changing customer needs, stay competitive, and maintain high standards of service excellence. Customer service best practices. Prompt and responsive communication. Timely communication is essential for maintaining customer satisfaction. Responding promptly to inquiries, providing timely updates on repair progress, and addressing any concerns swiftly demonstrate attentiveness and reliability. Utilizing various communication channels, such as phone calls, emails, and text messages, ensures that customers can reach the repair shop conveniently. Consistently prompt and responsive communication helps in building trust and reassures customers that their vehicle is receiving the necessary attention and care. Transparent pricing and billing. Transparency in pricing and billing fosters trust and minimizes the potential for disputes. Technicians should provide detailed and itemized estimates that clearly outline labor costs, parts expenses, and any additional fees. Explaining the rationale behind costs and offering clear breakdowns ensures that customers understand the financial aspects of the repairs. Additionally, providing upfront information about potential additional costs due to unforeseen issues helps in managing expectations and maintaining transparency throughout the service process. Offering comprehensive explanations of repairs. Providing thorough explanations of the repairs being performed helps customers understand the necessity and benefits of the services. Technicians should explain the specific issues identified, the steps involved in the repair process, and how the repairs will resolve the problem. Using visual aids or showing the actual components that require attention can enhance comprehension. Comprehensive explanations empower customers to make informed decisions about their vehicle maintenance and repairs, increasing their confidence in the technician's expertise and the repair shop services. Ensuring a comfortable waiting environment. The physical environment of the repair shop can significantly impact customer satisfaction. Providing a clean, comfortable, and well-equipped waiting area with amenities such as seating, refreshments, Wi-Fi, and reading materials creates a positive impression and enhances the overall customer experience. A welcoming environment makes customers feel valued and respected, contributing to their overall satisfaction and likelihood of returning for future services. Implementing a follow-up system. Following up with customers after repairs demonstrates a commitment to their satisfaction and the quality of the service provided. Technicians can implement a follow-up system that includes post-service calls or emails to ensure that the repairs were successful and that the vehicle is functioning properly. This proactive approach not only helps in identifying any lingering issues but also reinforces the repair shop's dedication to customer care and long-term vehicle performance. Handling customer complaints and feedback. Addressing complaints effectively. Customer complaints are inevitable, but how they are handled can significantly impact the customer's perception of the repair shop. Technicians should approach complaints with a solution-oriented mindset, listening attentively to the customer's concerns, acknowledging their feelings, and offering practical resolutions. Whether it involves reworking a repair, providing a discount, or offering a complimentary service, addressing complaints effectively can turn a dissatisfied customer into a loyal advocate. Learning from negative feedback. Negative feedback provides valuable insights into areas that need improvement. Technicians should analyze the root causes of negative feedback and implement changes to prevent similar issues in the future. This may involve revising communication practices, enhancing training programs, or upgrading equipment. By learning from negative feedback, repair shops can continuously evolve and enhance their service quality, ensuring that customer expectations are consistently met or exceeded. Encouraging positive reviews and referrals. Encouraging satisfied customers to leave positive reviews and refer others can significantly boost the repair shop's reputation and attract new business. Technicians can implement strategies such as requesting reviews after successful repairs, offering referral incentives, and showcasing positive testimonials on the shop's website and social media platforms. Positive reviews and referrals serve as powerful endorsements of the repair shop services, enhancing its credibility and attracting a wider customer base. Maintaining professionalism in all interactions. Maintaining professionalism, even in challenging situations, is essential for preserving the repair shop's reputation. Technicians should remain calm, respectful, and composed when dealing with difficult customers or unexpected issues. Demonstrating professionalism in all interactions reassures customers of the repair shop's reliability and integrity, fostering trust and long-term loyalty. Implementing continuous improvement practices. Continuous improvement is key to maintaining high standards of customer service. Technicians should regularly evaluate their communication and service practices, seeking opportunities to enhance efficiency, accuracy, and customer satisfaction. This may involve adopting new technologies, refining service protocols, or participating in ongoing training programs. By embracing a culture of continuous improvement, repair shops can adapt to evolving customer needs and industry trends, ensuring sustained success and excellence in customer service. Building a customer-centric culture. Creating a service-oriented mindset. Cultivating a service-oriented mindset among all team members ensures that customer satisfaction remains a top priority. Technicians should be encouraged to view every customer interaction as an opportunity to provide exceptional service, going above and beyond to meet and exceed customer expectations. This mindset fosters a unified commitment to quality and excellence, enhancing the overall customer experience and the repair shop's reputation. Empowering technicians with communication tools. Providing technicians with the necessary tools and training to communicate effectively with customers is essential for maintaining high service standards. This includes training on active listening, empathy, conflict resolution, and clear explanation of technical concepts. Equipping technicians with these skills enables them to handle a variety of customer interactions confidently and professionally, ensuring that each customer feels heard, respected, and valued. Promoting team collaboration for enhanced service. Encouraging collaboration and teamwork within the repair shop can lead to more effective and efficient service delivery. Technicians should work together to share knowledge, assist with complex repairs, and support each other in managing customer interactions. A collaborative environment fosters mutual respect and a collective commitment to customer satisfaction, enhancing the overall performance and success of the repair shop. Recognizing and rewarding excellent customer service. Acknowledging and rewarding technicians who consistently provide excellent customer service reinforces the importance of customer-centric practices. Implementing recognition programs, such as Employee of the Month awards, bonuses, or public commendations, motivates technicians to maintain high service standards and strive for continuous improvement. Recognizing outstanding service not only boosts technician morale but also reinforces the repair shop's dedication to exceptional customer experiences. Integrating customer service into training programs. Incorporating customer service training into technician education programs ensures that effective communication and customer-centric practices are ingrained from the outset. Training modules should cover essential customer service skills, best practices for handling various customer interactions, and strategies for maintaining professionalism under pressure. By integrating customer service into training, repair shops can develop well-rounded technicians who excel both technically and in their interactions with customers. Leveraging technology for enhanced communication. Implementing customer relationship management (CRM) systems. Customer relationship management (CRM) systems help repair shops manage customer interactions, track service history, and personalize communication. By utilizing a CRM system, technicians can access detailed customer profiles, including past services, preferences, and contact information, enabling more personalized and efficient service. CRM systems also facilitate automated follow-ups, appointment reminders, and targeted marketing campaigns, enhancing overall customer engagement and satisfaction. Utilizing digital communication channels. Incorporating digital communication channels, such as email, text messaging, and social media, allows repair shops to connect with customers more effectively and conveniently. These channels enable timely updates on repair progress, appointment confirmations, and promotional offers, enhancing customer convenience and accessibility. Additionally, maintaining an active presence on social media platforms can engage customers, showcase the repair shop's expertise, and attract new business through online visibility and interaction. Offering online appointment scheduling and service requests. Providing online appointment scheduling and service request options streamlines the customer experience by offering convenience and flexibility. Customers can book appointments at their preferred times without the need for phone calls, reducing wait times and improving overall satisfaction. Enhancing the customer experience. Personalizing customer interactions. Personalizing interactions by remembering customer names, vehicle details, and past service history creates a more welcoming and individualized experience. Technicians can use this information to tailor their communication, offer relevant service recommendations, and demonstrate genuine interest in the customer's needs. Personalization fosters a sense of connection and loyalty, encouraging customers to return for future services and refer others to the repair shop. Streamlining the service process. Streamlining the service process by minimizing wait times, organizing workflow efficiently, and maintaining clear communication channels enhances the overall customer experience. Implementing standardized procedures, optimizing appointment scheduling, and ensuring prompt notifications about service progress or completion contribute to a seamless and hassle-free service journey for customers. A streamlined process not only improves customer satisfaction but also increases the efficiency and productivity of the repair shop. Providing value-added services. Offering value-added services, such as complimentary vehicle inspections, shuttle services, or loaner cars, enhances the customer experience by providing additional convenience and benefits. These services demonstrate a commitment to customer care and go beyond basic repair offerings, distinguishing the repair shop from competitors. Value-added services can also generate additional revenue streams and foster stronger customer loyalty by addressing broader customer needs and preferences. Creating a welcoming and informative waiting area. Designing a comfortable and informative waiting area contributes to a positive customer experience by providing a pleasant environment during service appointments. Amenities such as comfortable seating, refreshments, free Wi-Fi, and informative displays about automotive maintenance and services keep customers engaged and at ease. A well-appointed waiting area reflects the repair shop's professionalism and attention to detail, enhancing the overall perception of quality and care. Offering flexible payment options. Providing a variety of payment options, including credit cards, mobile payments, and financing plans, accommodates different customer preferences and enhances convenience. Flexible payment methods make it easier for customers to settle their bills promptly and without hassle, reducing barriers to service completion. Additionally, offering financing options for larger repairs can make necessary services more accessible, increasing customer satisfaction and expanding the repair shop's customer base. Building trust and credibility. Showcasing certifications and expertise. Displaying certifications, such as those from the National Institute for Automotive Service Excellence, ASE, and highlighting areas of expertise on the repair shop's premises and marketing materials builds trust and credibility with customers. Certifications validate the technician's skills and commitment to quality service, reassuring customers that their vehicles are in capable hands. Showcasing expertise in specific areas, such as European imports or hybrid vehicles, attracts customers seeking specialized services and reinforces the repair shop's reputation as a knowledgeable and reliable service provider. Maintaining transparency in repairs and pricing. Transparency in all aspects of service, including repairs and pricing, is essential for building customer trust. Technicians should clearly explain the reasons behind recommended repairs, the steps involved in the process, and the associated costs. Providing detailed estimates and seeking customer approval before proceeding with additional services ensures that customers are fully informed and in control of their vehicle's maintenance and repair decisions. Transparency eliminates surprises and fosters a sense of honesty and integrity, which are crucial for long-term customer relationships. Delivering consistent quality service. Consistently delivering high-quality service is fundamental for establishing and maintaining customer trust and loyalty. Technicians should adhere to manufacturer specifications, use quality parts, and follow best practices in every repair task. Consistency in service quality ensures that customers can rely on the repair shop for dependable and effective solutions, encouraging repeat business and positive referrals. Implementing quality control measures and regularly evaluating service standards help maintain a consistently high level of service excellence. Building a positive online presence. A positive online presence through an informative website, active social media profiles, and favorable online reviews enhances the repair shop's credibility and attracts new customers. Technicians can contribute by sharing expertise through blog posts, engaging with customers on social media, and encouraging satisfied customers to leave positive reviews. Managing the online reputation by promptly addressing negative feedback and showcasing success stories reinforces the repair shop's commitment to customer satisfaction and service excellence. Engaging with the local community through sponsorships, participation in events, and involvement in community initiatives builds a positive reputation and fosters goodwill. Technicians can participate in local car shows, sponsor youth sports teams, or contribute to community service projects, demonstrating the repair shop's commitment to the community's well-being. Community engagement not only enhances brand visibility but also positions the repair shop as a trusted and integral part of the local area, attracting customers who value community-oriented businesses. Enhancing technician communication skills. Training in effective communication techniques. Providing technicians with training in effective communication techniques ensures that they are well equipped to interact with customers professionally and confidently. Training programs should cover active listening, empathy, clear explanation of technical concepts, conflict resolution, and customer service best practices. Regular communication skills training helps technicians enhance their interpersonal abilities, enabling them to build stronger relationships with customers and handle a variety of service scenarios with ease. Encouraging open and honest dialogue. Encouraging open and honest dialogue between technicians and customers fosters transparency and trust. Technicians should feel comfortable asking clarifying questions, admitting uncertainties, and seeking customer input when necessary. An open dialogue ensures that both parties have a clear understanding of the service requirements and expectations, leading to more accurate diagnostics and effective repairs. Promoting honesty in all interactions reinforces the technician's integrity and the repair shop's reputation for reliable service. Utilizing positive language and tone. The use of positive language and a friendly tone can significantly enhance customer interactions. Technicians should focus on using language that conveys confidence, reassurance, and a willingness to help. Phrases like, "We can solve this problem together," or "I'm here to help you get back on the road safely," create a positive and supportive atmosphere. A friendly and approachable demeanor makes customers feel comfortable and valued, contributing to a more pleasant and effective communication experience. Managing time effectively during interactions. Effective time management during customer interactions ensures that communication is clear and efficient without feeling rushed or neglectful. Technicians should allocate sufficient time to listen to customer concerns, explain service procedures, and address any questions or issues. Balancing thorough communication with efficiency helps in maintaining customer satisfaction while optimizing the repair shop's operational workflow. Respecting the customer's time by being punctual and organized during interactions reinforces professionalism and reliability. Providing continuous feedback and improvement. Technicians should seek and provide continuous feedback on communication practices to identify areas for improvement and ensure ongoing development. This can involve peer reviews, customer feedback surveys, and self-assessment tools. By actively seeking feedback, technicians can refine their communication skills, address any weaknesses, and enhance their ability to interact effectively with customers. Continuous improvement in communication practices contributes to higher levels of customer satisfaction and service excellence. Utilizing technology for enhanced communication. Implementing communication platforms. Adopting communication platforms such as customer relationship management, CRM, systems, messaging apps, and online chat services facilitate seamless and efficient interactions with customers. These platforms enable technicians to manage customer information, track service history, and maintain consistent communication throughout the repair process. By leveraging technology, repair shops can enhance their ability to respond promptly to customer inquiries, provide timely updates, and maintain organized records of all customer interactions. Automating service notifications and updates. Automating service notifications and updates through email, text messages, or automated phone calls keeps customers informed about the progress of their repairs. Technicians can use these automated systems to notify customers when their vehicle is ready for pickup, if additional repairs are needed, or when delays occur. Automated notifications enhance transparency and keep customers engaged and reassured throughout the service journey, reducing anxiety and enhancing overall satisfaction. Using diagnostic tools with customer interface features. Modern diagnostic tools often come with customer interface features that allow technicians to share real-time diagnostic information and repair progress with customers. For example, some diagnostic scanners can display live data feeds or provide visual representations of detected issues, which can be shown to customers via tablets or monitors. These features enhance transparency, educate customers about their vehicle's condition, and reinforce the technician's expertise and thoroughness in addressing the problem. Providing online service tracking and portals. Offering online service tracking portals where customers can monitor the status of their repairs provides convenience and transparency. These portals allow customers to log in and view real-time updates on their vehicle's service progress, estimated completion times, and detailed service reports. Online service tracking enhances the customer experience by providing immediate access to information, reducing the need for frequent phone calls or visits to the shop, and increasing overall satisfaction with the service process. Integrating virtual consultations and support. Integrating virtual consultations and support services allows technicians to assist customers remotely, providing guidance and addressing concerns without requiring an in-person visit. Virtual consultations can be conducted through video calls, enabling technicians to visually inspect vehicle issues, offer preliminary diagnostics, and discuss repair options with customers. This flexibility enhances customer convenience, expands service reach, and provides an additional layer of support that can differentiate the repair shop from competitors. Creating a positive customer journey mapping. The customer journey involves outlining each touchpoint a customer has with the repair shop, from initial contact to post-service follow-up. By understanding the customer's perspective at each stage, technicians and staff can identify opportunities to enhance the experience and address potential pain points. A well-mapped customer journey ensures that every interaction is purposeful, consistent, and aligned with the repair shop service standards, contributing to a seamless and positive overall experience. Enhancing the initial contact experience. The initial contact sets the tone for the entire customer relationship. Whether it occurs through phone calls, online inquiries, or walk-ins, technicians and staff should ensure that the first interaction is welcoming, professional, and informative. Promptly answering questions, providing clear information about services, and demonstrating a willingness to assist creates a positive first impression and encourages customers to choose the repair shop for their automotive needs. Streamlining the service appointment process. A streamlined service appointment process minimizes wait times, reduces scheduling conflicts, and enhances overall efficiency. Technicians should ensure that appointment scheduling is user-friendly, whether through online booking systems, phone reservations, or walk-in accommodations. Clear communication about appointment details, including date, time, and expected service duration, helps customers plan accordingly and reduces the likelihood of missed or rescheduled appointments. Providing exceptional post-service support. Exceptional post-service support involves following up with customers to ensure their satisfaction, addressing any lingering concerns, and offering additional assistance if needed. Technicians can implement follow-up calls or emails to inquire about the vehicle's performance after repairs and to gather feedback on the service experience. Providing ongoing support reinforces the repair shop's commitment to customer satisfaction and encourages customers to return for future services and recommend the shop to others. Fostering a culture of continuous improvement. Fostering a culture of continuous improvement ensures that the repair shop remains responsive to customer needs and industry advancements. Technicians should regularly evaluate their communication and customer service practices, seek feedback from customers and peers, and implement changes to enhance service quality. Embracing a mindset of continuous improvement helps the repair shop adapt to evolving customer expectations, maintain high service standards, and sustain long-term success in the competitive automotive industry. Conclusion: Mastering automotive communication and customer service. Integrating communication and service excellence into daily operations. Mastering automotive communication and customer service is integral to the success and reputation of any automotive repair shop. By integrating effective communication strategies and exceptional customer service practices into daily operations, technicians can enhance the overall customer experience, build lasting relationships, and foster a positive and professional service environment. Consistently prioritizing communication and service excellence not only drives customer satisfaction and loyalty but also distinguishes the repair shop as a trusted and reliable automotive service provider. Committing to professional growth and service innovation. Commitment to professional growth and service innovation ensures that technicians remain adept at handling diverse customer interactions and stay ahead of industry trends. By continually refining communication skills, embracing new technologies, and seeking opportunities for service innovation, technicians can elevate their service capabilities and adapt to the evolving needs of customers. This dedication to growth and innovation fosters a dynamic and forward-thinking repair shop culture, enhancing both individual and collective performance. Upholding high standards of integrity and trustworthiness. Upholding high standards of integrity and trustworthiness in all customer interactions solidifies the repair shop's reputation for reliability and excellence. Technicians should consistently demonstrate honesty, transparency, and accountability in their communication and service delivery. By maintaining these ethical standards, the repair shop builds a foundation of trust with customers, ensuring long-term loyalty and sustained business success. Integrity and trustworthiness are not only essential for customer satisfaction but also for fostering a positive and respected presence in the automotive community. Through Lesson 12, you have explored the critical aspects of automotive communication and customer service that are essential for building strong customer relationships and ensuring the success of an automotive repair business. By implementing effective communication strategies, enhancing customer service skills, leveraging technology, and fostering a customer-centric culture, technicians can elevate the overall customer experience, drive satisfaction and loyalty, and establish the repair shop as a trusted and exemplary service provider in the automotive industry. Embrace these principles to enhance your professional interactions, deliver exceptional service, and contribute to the long-term success and reputation of your automotive repair business. Lesson 13. Environmental Regulations and Hazardous Waste Disposal. A comprehensive guide to understanding and complying with environmental standards in automotive repair. Understanding environmental regulations in the automotive industry. Overview of environmental regulations. Environmental regulations play a crucial role in shaping the automotive repair industry. These regulations are designed to protect the environment by controlling the emission of pollutants, managing waste disposal, and ensuring the safe handling of hazardous materials. Understanding the framework of these regulations is essential for automotive technicians to operate legally and responsibly. Key regulatory bodies, such as the Environmental Protection Agency, EPA, in the United States, establish standards that businesses must adhere to, encompassing areas like air quality, water pollution, and hazardous waste management. Compliance with these regulations not only safeguards the environment but also helps repair shops avoid hefty fines and legal repercussions. Key federal environmental laws affecting automotive repair. Several federal laws specifically impact the automotive repair sector. The Resource Conservation and Recovery Act, RCRA, governs the management of hazardous and non-hazardous waste, ensuring that waste is properly treated, stored, and disposed of. The Clean Air Act, CAA, regulates air emissions from stationary and mobile sources, including automotive repair shops, by setting limits on pollutants such as volatile organic compounds, VOCs, released during painting and solvent use. Additionally, the Clean Water Act, CWA, addresses the discharge of pollutants into water bodies, impacting how repair shops manage runoff from wash bays and other operations. Familiarity with these laws is fundamental for technicians to maintain compliance and promote environmentally responsible practices within their workplaces. State and local environmental regulations. In addition to federal laws, state and local governments often implement their own environmental regulations that can be more stringent. These regulations may include specific requirements for waste disposal, emissions control, and reporting obligations. For instance, some states mandate the use of particular types of hazardous waste containers or require repair shops to obtain permits for certain activities. Local ordinances might also dictate operational hours to minimize noise pollution or restrict the storage of certain chemicals. Automotive technicians must be aware of and comply with both federal and their specific state and local regulations to ensure comprehensive adherence to all applicable environmental standards. International environmental standards and certifications for automotive repair shops operating internationally or aspiring to meet global standards. Understanding international environmental regulations is essential. Standards such as the ISO 14001 Environmental Management System provide a framework for managing environmental responsibilities systematically. Achieving certification in such standards demonstrates a commitment to environmental stewardship and can enhance a repair shop's reputation among environmentally conscious customers. Additionally, international regulations like the European Union's registration, evaluation, authorization, and restriction of chemicals, REACH, affect how automotive chemicals and materials are handled, requiring compliance to facilitate trade and operation within global markets. The impact of environmental regulations on automotive repair operations. Environmental regulations significantly influence the daily operations of automotive repair shops. Compliance requires the implementation of proper waste management systems, investment in pollution control technologies, and ongoing training for staff on environmental best practices. These regulations can lead to increased operational costs due to the need for specialized equipment and procedures. However, they also present opportunities for repair shops to differentiate themselves by adopting eco-friendly practices, appealing to a growing segment of environmentally conscious consumers. Understanding the operational impact of these regulations enables technicians to integrate sustainable practices seamlessly into their workflow, balancing environmental responsibility with business efficiency. Hazardous materials in automotive repair. Identifying hazardous materials commonly used in automotive shops. Automotive repair shops routinely handle a variety of hazardous materials that pose risks to both human health and the environment. Common hazardous materials include solvents like acetone and brake cleaners, paints containing volatile organic compounds, VOCs, batteries filled with lead and sulfuric acid, and antifreeze containing ethylene glycol. Additionally, parts like airbags and airbags contain hazardous components such as propellants and chemicals that require careful handling. Recognizing these materials and understanding their properties is the first step in managing them safely and in compliance with environmental regulations. Health and safety risks associated with hazardous materials. Exposure to hazardous materials in automotive repair can lead to serious health and safety risks for technicians. Inhalation of fumes from solvents and paints can cause respiratory issues, dizziness, and long-term neurological damage. Skin contact with acids from batteries or chemicals in cleaners can result in burns and dermatitis. Improper handling or accidental spills of hazardous materials can also lead to environmental contamination, affecting soil and water quality. Understanding these risks underscores the importance of stringent safety protocols and the use of personal protective equipment, PPE, to mitigate potential health hazards and ensure a safe working environment. Proper storage and labeling of hazardous materials. Proper storage and labeling of hazardous materials are critical components of environmental compliance and workplace safety. Hazardous substances must be stored in designated areas that are well ventilated, secure, and resistant to leaks or spills. Containers should be clearly labeled with the contents, hazard warnings, and handling instructions in accordance with the globally harmonized system, GHS, of classification and labeling of chemicals. Segregating incompatible materials, such as acids and bases, prevents dangerous chemical reactions. Implementing an organized storage system facilitates easy access, reduces the risk of accidents, and ensures that hazardous materials are managed responsibly. Safe handling practices for hazardous materials. Safe handling practices are essential to prevent accidents and minimize exposure to hazardous materials. Technicians should be trained in the correct procedures for using, transferring, and disposing of hazardous substances. This includes using appropriate PPE such as gloves, goggles, and respirators, as well as following standardized protocols for mixing or diluting chemicals. Utilizing tools like spill containment kits and proper ventilation systems further enhances safety. Adhering to these practices not only protects technicians from health risks but also ensures compliance with environmental regulations, safeguarding the repair shop from potential legal and financial liabilities. Emergency response procedures for hazardous material incidents. Despite best efforts, accidents involving hazardous materials can occur. Having well-defined emergency response procedures is crucial for minimizing the impact of such incidents. This includes immediate actions like containing spills, evacuating the affected area, and administering first aid to exposed individuals. Repair shops should maintain readily accessible emergency equipment, such as eye wash stations, spill kits, and fire extinguishers, and ensure that all staff are trained in their use. Additionally, establishing clear communication channels with local emergency services ensures a swift and coordinated response, reducing the severity of accidents and protecting both personnel and the environment. Hazardous waste management and disposal. Understanding hazardous waste classification. Hazardous waste management begins with accurately classifying waste materials based on their properties and potential hazards. The Environmental Protection Agency, EPA, classifies hazardous waste into 4 categories: ignitable, corrosive, reactive, and toxic. Ignitable wastes include flammable liquids like gasoline and solvents. Corrosive wastes consist of substances like battery acid and antifreeze that can destroy living tissue. Reactive wastes are unstable and can cause explosions or release toxic gases, while toxic wastes contain harmful chemicals that can contaminate water, soil, and air. Proper classification ensures that hazardous waste is managed appropriately, reducing environmental and health risks. Developing a hazardous waste management plan. A comprehensive hazardous waste management plan is essential for ensuring compliance with environmental regulations and promoting safe practices within the repair shop. This plan should outline procedures for waste identification, segregation, storage, transportation, and disposal. It should also include responsibilities for staff members, emergency response protocols, and documentation requirements. Regular reviews and updates of the management plan ensure that it remains effective and aligned with current regulations. Implementing a robust management plan helps in minimizing waste generation, reducing disposal costs, and enhancing the overall environmental performance of the repair shop. Proper waste segregation technique. Segregating hazardous waste based on its classification is a critical step in effective waste management. Different types of hazardous waste require distinct handling and disposal methods to prevent chemical reactions and contamination. For example, flammable solvents should be stored separately from corrosive acids to avoid dangerous interactions. Using clearly labeled containers for each waste category facilitates proper segregation and ensures that waste is managed in accordance with regulatory requirements. Implementing color-coded bins and training staff on segregation protocols enhances accuracy and efficiency in waste handling, reducing the risk of cross-contamination and ensuring safe disposal practices. Safe storage solutions for hazardous waste. Safe storage of hazardous waste involves using containers and storage areas that are compatible with the types of waste being stored. Containers should be made of materials that resist corrosion and leakage, and they must be clearly labeled with the contents and hazard warnings. Storage areas should be secure, well ventilated, and equipped with spill containment systems to prevent accidental releases. Implementing secondary containment measures, such as bunding or drip trays, adds an extra layer of protection against spills and leaks. Proper storage not only ensures compliance with environmental regulations but also protects the health and safety of technicians by minimizing exposure to hazardous substances. Transportation and disposal of hazardous waste. Transportation and disposal of hazardous waste must be conducted in strict accordance with regulatory guidelines to prevent environmental contamination and legal penalties. Waste should be transported using licensed hazardous waste carriers who follow approved routes and safety protocols. Proper documentation, including manifests and disposal records, must accompany the waste to ensure traceability and accountability. Disposal methods vary based on the type of hazardous waste, with options including incineration, chemical treatment, and secure landfilling. Partnering with certified disposal facilities ensures that hazardous waste is handled responsibly and in compliance with all relevant regulations, safeguarding the environment and the repair shop's reputation. Compliance and legal responsibilities. Understanding regulatory compliance requirements. Compliance with environmental regulations is non-negotiable for automotive repair shops. Understanding the specific requirements set forth by federal, state, and local authorities is essential for avoiding legal penalties and maintaining operational legitimacy. Compliance encompasses areas such as hazardous waste management, emissions control, water discharge regulations, and record-keeping. Technicians and management must stay informed about regulatory changes and ensure that all aspects of the repair shop's operations adhere to current laws. Regular compliance audits and consultations with environmental experts can help identify and address any gaps in adherence, ensuring that the repair shop remains in good standing with regulatory bodies. Obtaining necessary permits and licenses. Operating within the automotive repair industry often requires obtaining various permits and licenses related to environmental compliance. These may include hazardous waste storage permits, air emission permits, and water discharge permits, depending on the repair shop's operations and location. The application process for these permits typically involves detailed documentation of the shop's waste management practices, emission control measures, and environmental safeguards. Maintaining an up-to-date inventory of required permits and ensuring timely renewals is crucial for uninterrupted operations and legal compliance. Failure to secure the necessary permits can result in fines, operational shutdowns, and reputational damage. Record-keeping and documentation practices. Accurate record-keeping is a fundamental aspect of environmental compliance. Repair shops must maintain detailed records of hazardous waste generation, storage, transportation, and disposal, as well as emissions and other environmental metrics. These records should be organized, easily accessible, and retained for the duration specified by regulatory authorities. Implementing digital record-keeping systems can enhance accuracy, streamline access, and facilitate reporting during compliance inspections. Proper documentation not only demonstrates adherence to environmental regulations but also provides a valuable resource for monitoring waste management practices and identifying opportunities for improvement. Employee training and awareness programs. Ensuring that all employees are adequately trained and aware of environmental regulations and safe handling practices is essential for maintaining compliance and promoting a culture of environmental responsibility. Training programs should cover topics such as hazardous material identification, safe handling and storage procedures, emergency response protocols, and the importance of regulatory compliance. Regular training sessions, refresher courses, and the dissemination of informational materials help keep employees informed and vigilant about their roles in environmental stewardship. Empowering employees with the knowledge and skills to manage hazardous materials safely enhances overall compliance and reduces the likelihood of accidental spills or regulatory violations. Engaging with environmental audits and inspections. Environmental audits and inspections are conducted by regulatory authorities to assess a repair shop's compliance with environmental laws and regulations. Preparing for these audits involves conducting internal assessments to ensure that all practices align with regulatory standards, addressing any identified deficiencies, and maintaining organized documentation. During inspections, technicians should cooperate fully, provide requested information promptly, and demonstrate a thorough understanding of compliance procedures. Engaging proactively with audits and inspections not only ensures compliance but also provides opportunities to identify areas for improvement and reinforce the repair shop's commitment to environmental responsibility. Sustainable practices in automotive repair. Implementing energy-efficient technologies. Adopting energy-efficient technologies in automotive repair shops can significantly reduce energy consumption and environmental impact. Upgrading to energy-efficient lighting, such as LED fixtures, reduces electricity usage and lowers utility costs. Installing high-efficiency HVAC systems ensures optimal climate control with minimal energy waste. Additionally, utilizing energy-efficient machinery and tools, such as electric lifts and low-energy diagnostic equipment, contributes to overall energy savings. Implementing these technologies not only supports environmental sustainability but also enhances the repair shop's operational efficiency and reduces long-term operating expenses. Promoting recycling and reuse of materials. Recycling and reusing materials within the repair shop minimizes waste generation and conserves natural resources. Repair shops can establish recycling programs for materials such as metal parts, plastics, glass, and cardboard, ensuring that these materials are diverted from landfills and repurposed for future use. Additionally, reusing components like batteries, tires, and certain auto parts extends their life cycle and reduces the need for new resources. Implementing designated recycling stations, providing clear instructions for waste segregation, and partnering with local recycling facilities enhance the effectiveness of these programs. Promoting recycling and reuse not only supports environmental sustainability but also demonstrates the repair shop's commitment to responsible resource management. Adopting eco-friendly cleaning practices. Traditional cleaning practices in automotive repair can involve the use of harsh chemicals that are harmful to both the environment and human health. Adopting eco-friendly cleaning alternatives, such as biodegradable solvents, low VOC paints, and non-toxic cleaners, reduces the release of hazardous substances into the environment. Implementing practices like water recycling systems for wash bays and using steam cleaners instead of chemical-based methods further enhances sustainability efforts. Eco-friendly cleaning practices not only protect the environment but also create a safer and healthier workplace for technicians, contributing to overall well-being and productivity. Minimizing waste generation through lean practices. Implementing lean practices focused on minimizing waste generation enhances operational efficiency and reduces environmental impact. Techniques such as just-in-time inventory management prevent overstocking and reduce the likelihood of unused materials becoming waste. Streamlining repair processes to eliminate unnecessary steps and optimizing resource utilization ensure that materials are used effectively and efficiently. Additionally, conducting regular waste audits to identify and address sources of waste generation helps in continuously improving waste reduction strategies. Minimizing waste through lean practices not only supports environmental sustainability but also improves cost-effectiveness and operational performance within the repair shop. Incorporating renewable energy sources. Integrating renewable energy sources into the repair shop's operations can significantly reduce reliance on non-renewable energy and lower carbon emissions. Installing solar panels on the roof provides a sustainable source of electricity, powering lighting, HVAC systems, and machinery. Wind turbines, if feasible, can further contribute to the energy needs of the repair shop. Additionally, exploring options for purchasing green energy from utility providers supports broader renewable energy initiatives. Incorporating renewable energy sources not only diminishes the repair shop's environmental footprint but also positions it as a forward-thinking and environmentally responsible business, attracting eco-conscious customers and partners. Best practices for hazardous waste disposal. Selecting certified hazardous waste disposal contractors. Choosing certified hazardous waste disposal contractors ensures that waste is handled and disposed of in compliance with environmental regulations. Certified contractors possess the necessary licenses, training, and equipment to manage hazardous materials safely and responsibly. They follow established protocols for transportation, treatment, and disposal, minimizing the risk of environmental contamination and legal violations. Repair shops should conduct due diligence when selecting disposal partners, verifying their certifications and reputation for reliability and compliance. Partnering with reputable contractors fosters trust and ensures that hazardous waste is managed in an environmentally sound manner. Complying with disposal timelines and regulations. Adhering to disposal timelines and regulations is essential for maintaining compliance and avoiding penalties. Hazardous waste must be disposed of within specified timeframes to prevent accumulation and potential hazards. Repair shops should establish clear schedules for waste removal, ensuring that containers are not overfilled and that waste is transported to disposal facilities promptly. Staying informed about changes in disposal regulations and adjusting practices accordingly helps in maintaining ongoing compliance. Implementing automated reminders and tracking systems can aid in managing disposal timelines effectively, ensuring that hazardous waste is handled responsibly and in accordance with all regulatory requirements. Implementing spill prevention and control measures. Preventing and controlling spills is critical for minimizing environmental contamination and ensuring workplace safety. Repair shops should implement comprehensive spill prevention measures, such as using spill-resistant containers, installing containment systems around hazardous material storage areas, and maintaining proper ventilation. Additionally, having spill control kits readily available and training staff on their use ensures a swift and effective response in the event of a spill. Regular inspections and maintenance of containment systems help in identifying and addressing potential vulnerabilities, further reducing the risk of accidental releases of hazardous materials. Effective spill prevention and control measures protect both the environment and the health of technicians, promoting a safe and sustainable work environment. Utilizing proper disposal techniques for specific materials. Different hazardous materials require specific disposal techniques to ensure safe and compliant management. For example, batteries containing lead and acid must be recycled through specialized facilities, while used motor oil should be collected and reprocessed or disposed of according to regulatory guidelines. Paints and solvents often require solvent recovery systems or secure disposal methods to prevent VOC emissions. Understanding the unique disposal requirements for each type of hazardous material ensures that repair shops manage their waste streams appropriately, reducing environmental impact and adhering to legal obligations. Providing clear guidelines and training for technicians on proper disposal techniques enhances overall waste management effectiveness and compliance. Maintaining documentation for hazardous waste disposal. Maintaining accurate and comprehensive documentation for hazardous waste disposal is essential for regulatory compliance and accountability. Records should include details such as the types and quantities of hazardous waste generated, storage locations, disposal dates, and the names of disposal contractors used. These records must be organized and readily accessible for inspection by regulatory authorities. Implementing digital record-keeping systems can streamline the documentation process, ensuring accuracy and ease of retrieval. Proper documentation not only demonstrates compliance with environmental regulations but also provides valuable data for tracking waste generation trends and identifying opportunities for waste reduction and process improvement. Environmental impact and sustainability in automotive repair. Assessing the environmental impact of automotive repair activities. Automotive repair activities can have significant environmental impacts, including air and water pollution, soil contamination, and resource depletion. Assessing these impacts involves evaluating factors such as emissions from painting and solvent use, runoff from wash bays, disposal of hazardous waste, and energy consumption. Understanding the environmental footprint of repair operations enables technicians and management to identify areas where improvements can be made, implement sustainable practices, and mitigate negative effects on the environment. Conducting regular environmental impact assessments fosters a proactive approach to sustainability and ensures that repair shops operate responsibly within their communities. Implementing green certifications and standards. Obtaining green certifications and adhering to environmental standards enhances a repair shop's reputation and demonstrates a commitment to sustainability. Certifications such as ISO 14001 for environmental management systems or Green Seal certification validate the repair shop's efforts to minimize environmental impact through effective waste management, energy efficiency, and sustainable practices. Adhering to these standards not only promotes environmental responsibility but also attracts customers who prioritize eco-friendly businesses. Pursuing and maintaining green certifications involves continuous improvement and dedication to environmental stewardship, reinforcing the repair shop's position as a leader in sustainable automotive repair. Encouraging customer participation in sustainability efforts. Engaging customers in sustainability efforts fosters a collaborative approach to environmental responsibility. Repair shops can encourage customers to participate by offering eco-friendly service options, such as using low-VOC paints or providing incentives for recycling used parts. Educating customers about the environmental benefits of these options and how they contribute to sustainability enhances their appreciation and support for the repair shop's green initiatives. Additionally, promoting environmentally friendly practices, such as proper vehicle maintenance to reduce emissions, empowers customers to take active roles in their own environmental stewardship. Encouraging customer participation strengthens the repair shop's community engagement and amplifies its sustainability impact. Exploring alternative and sustainable materials. Exploring and utilizing alternative and sustainable materials in automotive repairs can significantly reduce environmental impact. Sustainable materials, such as bio-based plastics, recycled metals, and non-toxic paints, offer environmentally friendly alternatives to traditional materials. Incorporating these alternatives into repair processes not only minimizes resource depletion and pollution but also aligns with global trends towards sustainability and eco-consciousness. Technicians should stay informed about the latest sustainable materials and their applications in automotive repairs, ensuring that the repair shop remains at the forefront of environmentally responsible practices and innovation. Promoting water conservation and pollution prevention. Water conservation and pollution prevention are critical components of environmental sustainability in automotive repair. Implementing water-saving techniques, such as using high-efficiency wash bays and recycling rinse water, reduces water consumption and minimizes wastewater generation. Additionally, preventing pollutants from entering water bodies involves using barriers to contain runoff, treating wastewater to remove contaminants, and properly disposing of hazardous liquids. Promoting water conservation and pollution prevention not only protects local water resources but also ensures compliance with water quality regulations, contributing to the repair shop's overall environmental sustainability goals. Training and certification for environmental compliance. Providing environmental compliance training for technicians. Comprehensive environmental compliance training ensures that technicians are knowledgeable about regulatory requirements and best practices for managing hazardous materials and minimizing environmental impact. Training programs should cover topics such as hazardous waste identification, safe handling and storage procedures, spill response protocols, and proper disposal techniques. Regular training sessions, combined with refresher courses, keep technicians updated on the latest regulations and industry standards, fostering a culture of environmental responsibility and compliance within the repair shop. Achieving environmental certifications and credentials. Obtaining environmental certifications and credentials enhances a technician's expertise and the repair shop's credibility in environmental management. Certifications such as the Certified Environmental Technician, CET, or Hazardous Waste Operations and Emergency Response, HAZWOPER, demonstrate specialized knowledge and skills in managing hazardous materials and environmental compliance. Encouraging technicians to pursue these certifications not only improves their individual capabilities but also strengthens the repair shop's overall environmental management practices, ensuring adherence to regulatory standards and promoting sustainable operations. Promoting continuous learning and development. Promoting continuous learning and development in environmental practices ensures that technicians remain proficient in the latest sustainable techniques and regulatory changes. Encouraging participation in workshops, seminars, and online courses related to environmental management and sustainable automotive repair keeps technicians informed and adaptable. Providing access to educational resources and supporting ongoing professional development fosters a commitment to environmental excellence and equips technicians with the tools needed to implement and maintain sustainable practices within the repair shop. Collaborating with environmental experts and organizations. Collaborating with environmental experts and organizations provides valuable insights and resources for enhancing environmental compliance and sustainability efforts. Partnerships with local environmental agencies, industry associations, and sustainability consultants can offer guidance on best practices, regulatory updates, and innovative solutions for reducing environmental impact. Engaging with these experts fosters a collaborative approach to environmental management, enabling repair shops to stay informed about emerging trends and leverage external expertise to strengthen their sustainability initiatives. Implementing certification programs for the repair shop. Implementing comprehensive certification programs for the entire repair shop ensures that environmental compliance and sustainability are integrated into all aspects of operations. Developing internal certification criteria based on industry standards, such as ISO 14001, and regularly evaluating the repair shop's performance against these criteria promotes accountability and continuous improvement. Achieving and maintaining certification signifies the repair shop's dedication to environmental stewardship, enhances its reputation, and attracts customers who value sustainable and responsible automotive services. Emergency response and spill management. Developing an emergency response plan. An effective emergency response plan is essential for managing incidents involving hazardous materials and minimizing their impact on health and the environment. The plan should outline procedures for responding to spills, leaks, fires, and other emergencies, including evacuation routes, communication protocols, and roles and responsibilities of staff members. Regular drills and training sessions ensure that all employees are familiar with the emergency procedures and can respond swiftly and effectively in the event of an incident. A well-developed emergency response plan enhances workplace safety and demonstrates the repair shop's preparedness and commitment to environmental protection. Implementing spill prevention controls. Implementing spill prevention controls helps in minimizing the likelihood and severity of accidental releases of hazardous materials. This includes using secondary containment systems, such as drip trays and bunding around storage areas, to catch spills before they spread. Regular maintenance and inspections of storage containers and equipment ensure that they remain in good condition and free from leaks or damage. Additionally, using appropriate handling techniques and limiting the quantity of hazardous materials stored on-site reduces the risk of spills. Effective spill prevention controls are a critical component of comprehensive environmental management and workplace safety strategies. Training employees on spill response procedures. Training employees on spill response procedures ensures that they are equipped to handle incidents involving hazardous materials safely and efficiently. Training should cover the identification of spill hazards, proper use of spill containment and cleanup equipment, personal protective equipment, PPE, usage, and steps to secure and contain the spill. Hands-on training exercises and simulations can enhance employees' readiness and confidence in responding to spills. By ensuring that all staff members are proficient in spill response, repair shops can mitigate the environmental and health risks associated with accidental releases of hazardous materials. Utilizing spill kits and equipment effectively. Spill kits and specialized equipment are essential tools for managing spills and preventing environmental contamination. Spill kits should be strategically located throughout the repair shop, particularly near areas where hazardous materials are stored or used. These kits typically include absorbent materials, gloves, protective eyewear, and tools for containing and cleaning up spills. Regularly inspecting and replenishing spill kits ensures that they are fully stocked and ready for use when needed. Additionally, technicians should be trained on the proper use of spill kit components, ensuring that spills are managed promptly and effectively to minimize their impact. Coordinating with local emergency services. Establishing a strong relationship with local emergency services enhances the repair shop's ability to respond to environmental emergencies effectively. Coordinating with fire departments, hazardous materials, hazmat, teams, and environmental agencies ensures that the repair shop can access expert assistance quickly in the event of a significant spill or environmental incident. Providing local emergency services with detailed information about the types and quantities of hazardous materials handled at the repair shop facilitates a more efficient and informed response. Collaboration with emergency services reinforces the repair shop's commitment to environmental safety and preparedness. Record-keeping and reporting requirements. Maintaining accurate environmental records. Accurate record-keeping is vital for demonstrating compliance with environmental regulations and for effective environmental management. Repair shops must maintain detailed records of hazardous waste generation, storage, transportation, and disposal activities. These records should include dates, quantities, types of waste, disposal methods, and the names of disposal contractors. Additionally, records of environmental training, spill incidents, and emergency responses should be meticulously documented. Accurate environmental records provide transparency, facilitate regulatory inspections, and serve as a valuable reference for continuous improvement in environmental practices. Reporting requirements for environmental compliance. Meeting reporting requirements is essential for maintaining regulatory compliance and demonstrating environmental accountability. Repair shops must submit regular reports to environmental authorities detailing their hazardous waste management practices, emissions data, and compliance with specific environmental standards. These reports may include annual hazardous waste manifests, quarterly emissions reports, and incident reports for spills or other environmental emergencies. Understanding the specific reporting obligations based on federal, state, and local regulations ensures that repair shops fulfill their legal responsibilities and avoid penalties associated with non-compliance. Utilizing digital tools for efficient record-keeping. Digital tools and software can streamline the record-keeping process, enhancing accuracy and accessibility of environmental records. Environmental management systems, EMS, and specialized software solutions enable repair shops to track hazardous waste generation, monitor compliance metrics, and generate required reports with ease. These digital tools facilitate real-time data entry, reduce the likelihood of human error, and provide centralized access to environmental records for authorized personnel. Implementing digital record-keeping solutions enhances efficiency, ensures data integrity, and simplifies the process of maintaining comprehensive environmental documentation. Ensuring data security and confidentiality. Protecting the security and confidentiality of environmental records is essential for safeguarding sensitive information and maintaining regulatory compliance. Digital record-keeping systems should incorporate robust security measures, such as encryption, access controls, and regular data backups, to prevent unauthorized access and data loss. Repair shops must establish protocols for granting access to environmental records only to authorized personnel and ensuring that sensitive information is handled responsibly. Ensuring data security and confidentiality protects the repair shop's reputation and complies with privacy regulations related to environmental reporting and record-keeping. Auditing and reviewing environmental records. Regular auditing and reviewing of environmental records help ensure accuracy, completeness, and compliance with regulatory requirements. Internal audits involve systematically examining environmental records and practices to identify discrepancies, gaps, or areas for improvement. Repair shops can also engage third-party auditors to conduct independent assessments of their environmental management systems and record-keeping practices. Auditing and reviewing environmental records provide valuable insights into the effectiveness of waste management practices, highlight opportunities for enhancing compliance, and support the continuous improvement of environmental performance within the repair shop. Integrating environmental responsibility into business practices. Aligning environmental goals with business objectives. Integrating environmental responsibility into business practices involves aligning sustainability goals with the overall objectives of the repair shop. This alignment ensures that environmental initiatives support and enhance business performance rather than hinder it. Repair shops can establish specific environmental targets, such as reducing waste generation, lowering energy consumption, or achieving certain sustainability certifications, and incorporate these targets into their strategic planning. By aligning environmental goals with business objectives, repair shops can create a cohesive approach that promotes both environmental stewardship and business growth. Communicating environmental commitments to customers. Effectively communicating the repair shop's environmental commitments to customers enhances transparency and builds trust. Technicians and management should highlight eco-friendly practices, certifications, and sustainability initiatives through various channels, including the repair shop's website, marketing materials, and in-person interactions. Providing information about environmentally responsible services, such as recycling programs or the use of eco-friendly products,